Hello everyone, and welcome to this live session on data analysis using Python and SQL, full course 2022 by Simplilearn. In this video, you will learn the basics of data analytics and look at the important Python libraries for analysis and visualization. You will see the different SQL commands to perform data analysis and data manipulation. We will focus mostly on exploratory data analysis and handling structured tables in this video. But before we begin, make sure you subscribe to the Simplilearn channel and hit the bell icon to never miss an update from us. So here is the agenda for today's live video. So we'll start by learning the basics of data analytics, the applications, the steps involved in the data analytics process. Then you will learn the important Python libraries to perform data cleaning, numerical computation, data analysis, statistical analysis, and data visualization. So we will look at NumPy, Pandas, and Matplotlib in Python. You will then understand how to perform exploratory data analysis using interesting datasets such as Spotify data analysis. Then we have the World Happiness Report for 2021. Next, you will learn about Uber data analysis, and then we'll look at Olympics data analysis. After that, we'll see the basics of SQL and learn to store, update, delete, retrieve, and analyze data by writing SQL queries. So here you will explore about group by and having SQL. Then you will understand about the different types of joins in SQL. Moving forward, you will learn about subqueries, stored procedures, and window functions in SQL. Finally, you will learn how to analyze data in SQL with Python programming. So let's begin.
Welcome to Data Analytics using Python. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. So we're going to cover data analytics with Python. We're going to go over what is data analytics, applications of data analytics, types of data analytics process steps, why Python for data analytics, and then we'll dive into use case demo so you can actually see some script and actually see what it looks like in the Python code. What is data analytics? Data analytics is a process of exploring and analyzing large data sets to make predictions and help data-driven decision making. Now, the definition of large data sets keeps changing, and so this can range really from just about anything to anything. But usually in today's world, we're talking significantly larger amounts of data that you can't just glance at and try to figure it out yourself. And the two steps are analyze the data and then make decisions based on the data. Applications of data analytics. Now, the sky's the limit on this. In today's world, almost every business act of life, your music on your Spotify, are driven by data analytics. But some of the big players, when you go in there job hunting, are going to be your fraud analysis. If you want to go make a lot of money and you're good at it and you like dealing with numbers, go join the banks and track down the criminals who are stealing money. It's a lot of, it's a big thing to protect credit cards, protect sales purchases, bad checks, any of those things. When you can track them down is huge. Healthcare, exploding. There is everything from trying to find cures for the COVID virus or any of the viruses out there, using your cell phone to diagnose different ailments. That way you don't have to go in and see the doctor. You can actually just go in there and take a picture of the funky growth on your arm. Hopefully it's not too big. And then they send it in there and the data analytics goes in there and looks at it and says, oh, this is what this is. This is a professional you need to go see or don't need to see. And that's just one aspect of healthcare. The databases being generated by healthcare and getting the right doctors and helping the doctors analyze whether something is benign or malignant, if it's cancerous. All those things are now part of the ongoing healthcare growth in data analytics. Inventory management. Think one of those huge warehouses where they're shipping out all the goods. How do you inventory that in such a way so that you maximize the stuff that's being purchased the most near the entrance and all the other stuff towards the back, or even pre-ship it? So it's huge to be able to manage your inventory, and pretty soon they'll just have a drone come in there and start picking up some of those boxes and move them around also. Delivery logistics. Again, this goes from getting from point A to point B. You can combine it with our inventory, so you pre-ship stuff if you know a certain area is more likely to purchase it. How do you get the delivery to the most destinations the quickest in the short amount of time? And then they even pre-stack the trucks going out, and that's all done with data analytics. How do we stack all that stuff so it comes out in the right order? Targeted marketing, huge industry. Any kind of marketing, whether you're generating the right content for the marketing, who are you targeting with that marketing, researching the people, what they want, so you know what products to market out there, all those things are huge. And these are just a few examples. You can probably go way beyond this, from tracking forest fires to astrology and studying the stars. All of this is part of data analytics now and plays a huge role in all these different areas. City planning is another one. You know, you can see a nice organized city like this one where you can get in and out of the neighborhoods if you're a fire truck. Police officers need to be able to get in and out. You want your tourists to be able to come in, yet you still want the place to look nice, and you have the right commercial development, the right industrial development, like enough residents for people to stay. All those things are part of your city planning. Again, huge in data analytics. So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many sales per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up in the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive. Then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder, or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future, gear up for how many employees we need, how much money we're going to make, and prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change. Data analytics process steps. So let's take a look at some of the basic processing and what that looks like when you're working with this data. So there's 5 basic steps. The 5 steps of processing, and this changes, and then there's a lot of things that go on when they talk about agile programming. The whole concept of agile is you take some kind of framework like this and then you build on it depending on what your business needs. So the first step is data collection. And usually with a large company you might have somebody who is responsible for the database management. You might have another one where they're pulling APIs and they're pulling data off of maybe the Census Bureau, maybe something very, very specific, domain specific. So if you're analyzing cancerous growths and how to understand them, then the data collection is going to be those measurements they take from the MRI, or it might be even the MRI images. They've used those also. So there's a lot of things with data collection and how to control that and make sure it has what you need and is clean and you don't have misinformation coming in. Once you have the data collected, there's a data preparation. So stage 2 is we take that data and we format it into something we can use. Probably one of the biggest formats that you see is when you're processing text. How do you process text? Well, you use what they call a one-hot encoder, and each word is represented by a yes-no kind of setup. So it'd be like a long array of bits. That's one way to prepare it. And so, bit number 1 is the. Bit number 2 is has, or whatever it is. Other preparations might be if you're using neural networks, you might be taking integers or float numbers and converting them to a value between 0 and 1. That way you don't have one of them creating a bias in there. So there's a lot of different things that go into data preparation. That is 80% of data science. So when we talk about the data analytics, which is a little bit more on the math side, and they usually talk about a data scientist kind of being the overall preparer of this stuff, you're going to spend 80% of your data preparation. Data exploration, that's the fun part. This is where you're exploring things. And it is maybe 10 to 15% of what you do with the data you spend with the data exploration. It is probably the most important step, because this is where you got to start asking questions. If you ask your questions wrong, you're going to get some wrong information. If you're working with a company and they want to know the marketing values, then you really got to focus on, hey, how do we generate money for this company? Or fraud, how do we lower the fraud rate while still generating a profit? 4, data modeling. This is where we start actually getting into the data code, which model to use that predicts what's going to happen. And then result interpretation. We want to be able to interpret those results. You usually see that in your Matplotlib library, where you create nice, beautiful images so that it shows up on their dashboard for the marketing manager or for the CEO, so they can take a quick look and say, hey, I can see what's going on there. You want to reduce it to something they can easily read. They don't want to hear the scientific terms. They want to see something they can use. And we'll talk about that a little bit more when we start looking at some of this in a demo. Since this is data analysis with Python, we got to ask the question, why Python for data analytics? I mean, there's C++, there's Java, there's .NET from Microsoft. Why do people go to Python for it? So the number of reasons. 1, it's easy to learn with simple syntax. You don't have a very high typeset like you do in Java and other coding, so it allows you to kind of be a little lazy in your programming. That doesn't mean that it can't be set that way and that you don't have to be careful. It just means you can spin up a code much quicker in Python. The same amount of code to do something in Python a lot of times is 1, 2, or 3 or 4 lines, where when I did the same thing, say in Java, I found myself with 10, 12, 13, 20 lines, depending on what it was. It's very scalable and flexible. So there's our flexibility, because you can do a lot with it, and you can easily scale it up. You can go from something on your machine to using PySpark into the Spark environment and spread that across hundreds, if not thousands of servers across terabytes of data or petabytes of data. So it's very scalable. There's a huge collection of libraries. This one's always interesting because Java has a huge collection of libraries. C has a huge collection of libraries. .NET does, and they're always in competition to get those libraries out. Scala for your Spark. All those have huge collections of libraries. This is always changing, but because Python's open source, you almost always have easy to access libraries that anybody can use. You don't have to go check your licensing and have special licensing like you do in some packages. Graphics and visualization, they have a really powerful package for that, so it makes it easy to create nice displays for people to read. And community support. Because Python is open source, it has a huge community that supports it. You can do a quick Google and probably find a solution for almost anything you're working on. Python libraries. Let's bring it together. We have data analytics and we have Python. So when we're talking data analytics, we're talking Python libraries for data analytics. And the big 5 players are NumPy, Pandas, Matplotlib, SciPy, which is going to be in the background, so we're not going to talk too much about the scientific formulas in SciPy, and scikit. So NumPy supports n-dimensional arrays, provides numerical computing tools useful for linear algebra and Fourier transform. And you can think of this as just a grid of numbers. And you can even have a grid inside a grid, or data. It's not even numbers, because you can also put words and characters and just about anything into that array. But you can think of a grid, and then you can have a grid inside a grid, and you end up with a nice three-dimensional array. If you want to talk three-dimensional array, you can think of images. You have your 3 channels of color, 4 if you have an alpha, and then you have your XY coordinates for the image we're looking at. So you can go X, Y, and then what are the 3 channels to generate that color. And NumPy isn't restricted to 3 dimensions. You could imagine watching a movie. Well, now you have your movie clips, and they each have their X number of frames, and each of those frames have X number of XY coordinates for the pictures in each frame, and then you have your 3 dimensions for the colors. So NumPy is just a great way to work with n-dimensional arrays. Now closely with NumPy is Pandas, useful for handling missing data, perform mathematical operations, provides functions to manipulate data. Pandas is becoming huge because it is basically a data frame. And if you're working with big data and you're working in Spark or any of the other major packages out there, you realize that the data frame is very central to a lot of that. And you can look at it as an Excel spreadsheet. You have your columns, you have your rows or indexes, and you can do all kinds of different manipulations of the data within, including filling in missing data, which is a big thing when you're dealing with large pools or lakes of data where they might be collected differently from different locations. And Matplotlib. We did kick over the SciPy, which is a lot of mathematical computations, which usually runs in the background of NumPy and Pandas. Although you do use them, they're useful for a lot of other things in there. But the Matplotlib, that's the final part. That's what you want to show people. And this is your plotting library in Python. Several toolkits extend Matplotlib functionality. There's like 100 different toolkits to extend Matplotlib, which range from how to properly display star constellations from astronomy. There's a very specific one built just for that, all the way to some very generic ones. We'll actually add Seaborn in when we do the labs in a minute. Several toolkits extend Matplotlib functionality, and it creates interactive visualization. So there's all kinds of cool things you can do as far as just displaying graphs, and there's even some that you can create interactive graphs. We won't do the interactive graphs, but you'll see, you'll get a pretty good grasp of some of the different things you can do in Matplotlib.
Now let's look at the companies using data analytics on a daily basis. So we have the e-commerce giant Amazon, then we have Accenture, followed by the American Healthcare Service Organization, Cigna. Then we have the American supplier of health information technology solutions, services, devices and hardware, Cerner, followed by Target and antivirus company McAfee. Next, we have Rapido, which is an Indian bike rental company based in Bangalore. After that, we have Flipkart and the world's largest retail company, Walmart. With that, let's understand a case study from Walmart and how it uses data analytics to grow its business and serve its customers better. Walmart is an American multinational retail company that has over 11,500 stores in 27 countries worldwide, and it has e-commerce websites in 10 different countries. It has more than 5,900 retail units operating outside the United States with 55 banners in 26 countries with more than 7 lakh associates serving more than 100 million customers every week. It has over 2.2 million employees around the world and 1.5 million employees in the United States alone. Walmart's e-commerce branch alone employs more than 3,000 technologists from Silicon Valley to India, England and South America. More than 240 million customers shop at Walmart each week online and at its banner stores. Walmart.com sees up to 100 million unique visitors a month according to ComScore and is growing every year. Walmart collects over 2.5 petabytes of data from 1 million customers every hour. That's really huge. Now, to make sense of all this information, Walmart has created Data Cafe, a state-of-the-art analytics hub located within its Bentonville, Arkansas headquarters. Here, over 200 streams of internal and external data, including 40 petabytes of recent transactional data, can be modeled, manipulated, and visualized. Teams from any part of the business are invited to bring their problems to the analytics experts and then see a solution appear before their eyes on the nerve center's touchscreen smartboards. Walmart also constantly analyzes over 100 million keywords to know what people near each store are saying on social media to understand their customer behavior on what they like and dislike. Walmart uses modern tools and technologies to derive business insights and improve customer satisfaction. Some of these tools include Python, SAS, NoSQL databases such as Cassandra, and Hadoop. Now, using all these technologies and data analysis techniques, Walmart can better manage its supply chain, optimize product assortment, personalize the shopping experience, give relevant product recommendations, and finally, optimize and analyze transportation lanes and routes for its fleet of trucks.
What's in it for you? And we're going to go over what is NumPy, installing and importing NumPy, NumPy array versus Python list, basics of NumPy, finding size and shape of any array, range and arrange functions, NumPy string functions. And then in part 2, I'll move on to cover axes, array manipulation, and much more. So let's start with what is NumPy. NumPy is the core library for scientific and numerical computing in Python. It provides high-performance, multi-dimensional array object and tools for working with arrays. And I'll go a step further and say there are so many other modules in Python built on NumPy. So the fundamentals of NumPy are so important to latch onto for the Python so that you can understand the other modules and what they're doing. NumPy's main object is a multi-dimensional array. It is a table of elements, usually numbers, all of the same type, indexed by a tuple of position integers. In NumPy, dimensions are called axes. Take a one-dimensional array, or we have, and remember dimensions are also called axes, so you can say this is the first axis, 0, 1, 2, 3, 4, 5. And you can see down here it has a shape of 6. Why? Because there's 6 different elements in it in the one-dimension array. And they usually denote that as 6 comma with an empty node on there. And then we have a two-dimensional array where you can see 0, 1, 2, 3, 4, 5, 6, 7. And in here we have 2 axes or 2 dimensions, and the shape is 2, 4. So if you were looking at this as a matrix or in other mathematical functions, you can see there's all kinds of importance on shape. We're not going to cover shape today, but we will cover that in part 2. Did you know that NumPy's array class is called NDArray for NumPy Data Array? Now we're going to take a detour here because we're working in Python, and 2 of my favorite tools in Python is the Jupyter Notebook, and then I like to use that sitting on top of Anaconda. And if you flip over to jupyter.org, that's jupyter.org, you can go in here. You can install it off of here if you don't want to use the Anaconda notebook, but this is the Jupyter setup, the documentation on the Jupyter. Jupyter opens up in your web browser. That's what makes it so nice, is it's portable. The files are saved on your computer. They do run in IPython or IronPython, and you can create all kinds of different environments in there, which I'll show you in just a minute. I myself like to use Anaconda. That's www.anaconda.com. If you install Anaconda, it will install the Jupyter Notebook with the Anaconda separate. And you can install Jupyter Notebook and it'll run completely separate from Anaconda's Jupyter Notebook. And you can see here I've now opened up my Anaconda Navigator. What I like about the Navigator, and this is a fresh install on a new computer, which is always nice, I can launch my Jupyter Notebook from in here. I can bring other tools, so the Anaconda does a lot more. And under environments, I only have the one environment, and I can open up the terminal specific to this environment. This one happens to have Python 3.7 in it, the most current version as of this tutorial. And then you open a terminal if you're going to do your pip installs and stuff like that for different modules. You can also create different environments in here. So maybe you need a Python 3.6, Python 3.5. You can see we're having a nice framework like Anaconda really helps, so you don't have to track that on your own in the Jupyter Notebook and your different Jupyter Notebook setups. We'll go ahead and launch this Jupyter Notebook. And then I've set my browser window for a default of Chrome. So it's going to open up in Chrome. And you can see here, this opens up a folder on my computer. We have a couple different options on here. Remember, I set the environment up as Python 3.7. You would install any additional modules that aren't already installed in your Python on this. And it keeps them separate. So you do have to, for each environment, install the separate modules so they match the environment on there. And in here we have a couple things where you can look up what's running. You have your different clusters. Again, I just installed this on a new machine, so I just have a couple things in here that were run on here recently. And where we go on here is we then have on the upper right, New, and from the pull down menu you'll see Python 3, and this will open up a new window. And now we're in Jupyter Python, so this is a Python window, and we'll just do a print. And this of course is, let's go hello world. And we'll run that, and it prints out hello world in the command line. There's a couple special things you have to know what we're not going to do today, which is on graphics. If you've never seen this, one of the things you can do is you can also do A equals hello world. And if you just put the A in there, now if you do a bunch of these where you have A equals hello world, B equals goodbye world, and you put A, B, A, then return B, it'll only run the last one. But you can see here, if you put the variable down here, it will show you what's in that variable. And that has to do with the Jupyter Notebook inline coding. So that's not basic Python, that's just Jupyter Notebook shorthand, which you'll see in a little bit. So back to our NumPy array versus Python list. Python list being the basic list in your Python. Why should we use NumPy array when we have Python list? Well, first, it's fast. The NumPy array has been optimized over years and years by multiple programmers, and it's usually very quick compared to the basic Python list setup. It's convenient, so it has a lot of functionality in there that's not in the basic Python list. And it also uses less memory, so it's optimized both for speed and memory use. And let's go ahead and jump into our Jupyter Notebook. Since we're coding, best way to learn coding is to code. Just like the best way to learn how to write is write, and the best way to learn how to cook is cook. So let's do some coding here today. And just like any modules, we have to import NumPy. We almost always import it as NP. That is such a standard. So you'll see that very commonly. We can just run that. And now we have access to our NumPy module inside our Python. And then the most common thing, of course, is to go ahead and create a NumPy array. And in here, we can send it a regular list. And so we'll go ahead and send this a regular array. Let's go 1, 2, 3 to make it simple. And then I'm just going to type in A, and we'll run this. And so you can see down here, the output is an array of 1, 2, 3. And we could also do print, just a reminder that this is an inline command, so that wouldn't work if you're using a different editor. You can see that it's an array 1, 2, 3. But we'll go ahead and leave it as A. Kind of a nice feature so you can see what you're doing really quick in the Jupyter Notebook. And just like all your other standard arrays, I can go A of 0, which is going to be a value of 1. Of course, we do A of 1, you go all the way through this. A of 1 has a value of 2 in it. So whether you're using the NumPy array or the basic Python list, that's going to be the same. That should all look pretty familiar and be pretty straightforward. Remember, the first value is always 0, and when we set on there. So let's take a look why we're using NumPy, because we went over the slide a little bit, but let's just take a look and see what that actually looks like. And what we want to look at is the fact that it's fast, convenient, and uses less memory. So let's take a glance at that in code and see what that actually looks like when we're writing it in Python and what the differences are. And to do this, I'm going to go ahead and import a couple other modules. We're going to import the time module so we can time it. And we're going to import the system module so that we can take a look at how much memory it uses. And we'll go ahead and just run those so those are imported. And so we'll do B equals range of 1. Yeah, 1,000 is fine. And so that's going to create a list of 1,000, 0 to 999. Remember, it starts at 0 and it stops right at the 1,000 without actually going to the 1,000. And let's go ahead and print. And we want system.getSize of. And we'll pick any integer because we have, 0 to 1,000. We'll just throw one in there, 5. It doesn't matter because it's going to, whatever integer we put in there is going to generate the same value because we're looking at the size of how much memory it stores an integer in. And then we want to have the length of the B. That's how many integers are in there. And if we go ahead and execute this and run this at a line, we'll see, oops, I did that wrong. comma. If we multiply them together, we'll see it generates 28,000. So that's the size we're looking at, is 28,000. I believe that's bytes. That sounds about right. So let's go ahead and create this in NumPy. And we'll go C equals NP. And this is a range. So that's the NumPy command to do the same thing that we were just doing in a list. And we'll also use the same value on there, the 1,000. And then once we've created the value of C for np.arange, let's go ahead and print. And we can do that by doing c.size times c.itemSize. And that's very similar to what we did before. We did get the size of, so the C size is the size of the array, and each item size, just reversed. So it's the size of an integer 5, item size is going to be the integers, and C size. Now let's just take a look and see what that generates. And wow, okay, we got 4,000 versus 28,000. That's a significant difference in memory, how much memory we're using with the array. And then let's go ahead and take a look at speed. Let's do size. We tried this with lower values, and it would happen so fast that the NP array kept coming up with 0 because it just rounded it off. So size, and let's create an L1 equals range of size, and we'll do an L2. We'll just set up to the same thing. It's also range of size on there. There we go. And then we can do on A1 equals np dot arange size. And then let's do on A2 equals np dot arange. We'll keep it the same size. And what we're going to do is we're going to take these two different arrays and we're going to perform some basic functions on them. But let's go ahead, actually let's just load these up now. We'll go ahead and run this so those are all set in memory. Except for the typo here. Quickly fix that. There we go. So these are now all loaded in here. And let's do a start equals time.time. So it's just going to look at my clock time and see what time it is. And then we'll do result equals, and let's do, let's say we got an array, and we're going to say, let's do some addition here. X plus Y for X comma Y, and we'll zip it up here. Two different arrays. So here's our two different arrays. We're going to multiply each of the individual things on here. L1, L2. There we go. So that should add up each value. So L1 plus L2, each value in each array. And then we want to go ahead and print. And let's say Python list took. And then we'll do time dot time. We'll just subtract the start out of there. So time, whoops, I messed up on some of the quotation marks on there. Okay, there we go. Time minus the start. And we'll convert that to seconds. So we'll go, because that's in milliseconds, so times 1,000. And let's hit the run on there. This is kind of fun because you also get a view while we're doing this of some ways to manipulate the script. And as you can see also my bad typing. There we go. Okay, so we'll go ahead and run this. And we can see here that the Python list took 34. Actually, I have to go back and look at the conversion on there. But you can see it takes roughly 0.34 of a second. And we can go ahead and print the result in here too. Let's do that. And we'll run that just so you can see what kind of data we're looking at. And we have the 0, 2, 4, 6, 8. So it's just adding them together. It looks pretty straightforward on there. And if we scroll down to the bottom of the answer, again we see Python list took 46. A little different time on there depending on what core, because this is on an 8-core computer, so it just depends on what core it's running on, what else is pulling on the computer at the time. And let's go back up here and do our start time. Paste that into here. And this time we're going to do a result equals, and this is really cool. Notice how elegant this is. It's so straightforward. This is a lot of reason people started using NumPy is because I can add the two arrays together by simply going A1 plus A2. It makes a lot of sense, both looking at it, and it's just very convenient. Remember that slide we're looking at? Fast, convenient, and less memory. So look how convenient that is. Real easy to read, real easy to see. And I don't know if we don't need to print the result again, so let's just go ahead and print the time on here. And we'll borrow this from the top part because I really am a lazy typer. And this isn't the Python list, this is the NumPy list, or NumPy array. And let's go ahead and see how that comes out. And we get 2.99. So let's take a look at these two numbers, 46 versus 2.99. So we'll just round this up to 3. That's a huge difference. That's like more than 10 times faster. That's like 15 times roughly at a quick glance. I'd have to go do the math to look at it. And it's going to vary a little bit depending on what's running in the background on the computer, obviously. So we've looked at this, and if we go back here, we found out it's much faster. Yes, there's going to be different speeds depending on what you're doing with the array. Very convenient, easy to read, and it uses less memory. So that's the core of the NumPy. That's why a lot of people base so many other modules on NumPy and why it's so widely used. So we did glance at a couple operations while we were looking at speed and size. Let's dive into a little bit more into the basic operations. And these are always nice to see. I mean, certainly you want to go get a cheat sheet if you're using it for the first time. Look things up. Google is your friend. We did this for the most basic numpy.array or np.array. And we'll go ahead and create an array. Let's do pairs, 1, 2. And then let's do 3, 4. And if we're going to do that, let's do 5, 6. There we go. And if we go ahead and take this and run this, I can go ahead and do our A down here so it's in line, and it'll print that out. You can see it makes a nice array for us. So we have A, and if you look at that, we have 3 different objects, each with 2 values in them. And hopefully you're starting to think, well, how many dimensions or indexes is that? And you'll see 3 by 2. So let's go ahead and take a look, and let's go, how about A.nDimensions? Speaking of which, we'll run that, and we have 2 dimensions for each object. And then we can do the item size, so A dot. We saw this earlier, where we looked up how many items. It was up here, where we wanted to multiply item size times the actual size of the object. So the memory is being used versus the item size. And we should see 4 there. Memory is compressed down. That's always a good thing. And then the shape. The shape is so important when you're working with data science and you're moving it from one format to another. So we have our shape. We just talked about that. We have 3 by 2. 3 rows by 2 objects in each one. Generally, I don't look too much at the size, but the dimensions I'm always looking up. And this is nice, you can automate it. So you might be converting something, you might need to know how many dimensions are going into the next machine learning package so that you can automatically just have it send that information over. So we looked at A shape. Let's go ahead and create a slightly different array, np.array. Let's go ahead and just do as our original setup here. And one of the features we can do, which is really important, is we can do dtype equals. In this case, let's do np float 64. And so what we've done is we're converting all of these into a float. And we type in A. And now instead of having 1, 2, 3, 4, 5, 6, you see they're all float values. 1.0, there's no actual 0 in there, just shows the 1 dot. Or the 1 period, 2, 3 period, 4 period, 5 period, 6 period. And this, again, data science, I don't know how many times I've had to convert something from an integer to a float so that's going to work correctly in the model I'm using. So very common features to be aware of and to be able to get around and use. And we'll also do, let's just curiosity, item size. We'll go ahead and run that. And we see that it doubled in size. So it's not a huge increase. Well, doubling is always a big increase in computers. But it's not a huge increase compared to what it would be if you're running this in the Python list format. And then we did the shape earlier without having it set to the float 64. Let's go ahead and do A shape with it set to 64. And it should be the same, 3, 2. So it all matches. So we've gone through, and remember, if this is all brand new to you, according to the Cambridge study at the Cambridge University, if you're learning a brand new word in a foreign language, the average person has to repeat it 163 times before it's memorized. So a lot of this, you build off of it, so hopefully you don't have to repeat it 163 times. But we did manage to repeat it at least twice here, if not a little bit more. And let's go ahead and take this. We're going to go look at one more setup on here. And let me just take this last statement here on the converting our properties of our data. And instead of float 64, let's do complex. Let's just see what that looks like. And let's go ahead and print that out and run it. And so we now have a complex data set up, and you'll see it's denoted by the 1 dot plus 0 dot j. And if we flip over here and do a basic search for NumPy data types, better to go to the original web page, but pull up a bunch of these. You can see there's a whole list of different NumPy data types. Shorthand, complex, we have complex, complex 64, complex 128. Complex number represented by two 64-bit floats, real and imaginary components. One option on there, float 16, float 32, float, shorthand for float 64, most commonly used, and of course all the different ones that you can possibly put into your NumPy array. So we covered a basic addition up there when we were comparing how fast it runs, but some very basic components, how to set up a NumPy array, how many dimensions it has, item size, data type, item, again we went to item size, and there's also the shape. Probably one of the more used. I use a shape all the time. Very commonly used. And then down here you can see where we actually created a NumPy complex data type. So let's look at some other features in NumPy. One of them is you could do NumPy dot zeros, and we're going to do 3, 4. There we go. And we'll go ahead and run this, and you can see if I do np.zeros, I create a NumPy array of zeros. This is really important. I was building my own neural network, and I needed to create an array where I initialized the weights, and I wanted them all to be the same weight. In this case, I wanted them to start off as 0 for the particular project I was working on. And there's other options, like you can do NumPy1s, and we'll do the same thing, 3, 4. We'll run that. And you can see I've created an array of NumPy1s. In this case, it comes out as a float array. And then this is an interesting to note, because we have, let's go back to our Python and do L range 5. And we'll print the L. So that's our list. And if I run that, it doesn't create the range until after the fact, until you actually execute it. That's an upgrade in Python. Python 2.7 actually created the array 0, 1, 2, 3, 4. This one actually creates the script, and then once it's used, it then actually generates the array. And if we do that in NumPy A range, remember that from before, and if we do NumPy A range 5, and let's do L equals, or we can just leave it as NumPy, that's fine. There we go, just run that. You can see there we actually get an array, 0, 1, 2, 3, 4 for the value of the NumPy A range 5. It generates the actual array. And for part 1, we're going to do just one more section on basic setup, and we're going to concatenation, do a concatenation example. There we go. We're going to do strings. Let's take a look at strings and what's going on with there. And let's do, let's see, print. Let's do an np character, something new here. And we're going to add, and then here's our brackets for what we're going to add. And let's say, let's do hello, comma, hi. And in the brackets on there, let's create another one. And this one's going to be ABC, and we'll do XYZ. So we're just creating some, randomly making some up on here. And then we'll go ahead and just print this. If we run that, you can come down here, and of course make sure all your brackets are open and closed correctly. And then you can see in here when we concatenate the example in NumPy, it takes the two different arrays that we set up in there, and it combines the hello with the ABC and the hi with XYZ. And if we can also do something like print, let's do np character dot multiply. So there's a lot of different functions in here. Again, you can look these up It's probably good to look them all up and see what they are, but it's good to also just see them in action. And let's do hello space, comma, 3, and we'll run this one and run that without the error. And you'll see it does hello, hello, hello. So we multiplied it by 3. And we can also, and let's just take this whole thing here instead of retyping it. And we can do character center. So instead of multiply, let's do center. And over here, keep our hello going. Take the space out of there. And let's do center at 20. And fill character equals, and we'll fill it with dashes. So if we run this, you can see it prints out the hello with dashes on each side. And we keep going with that. We can also, in addition to doing the fill function, we can play with capitalize, we can title, we can do lowercase, we can do uppercase, we can split, split line, strip, join. These are all the most common ones. And let's go ahead and just look at those and see what those look like, each one of them. Here we're going to do the hello world, all-time favorite of mine. I always like to say hello universe. And you can see here we did a capital H with the world, but so we want to capitalize. So capitalize is the first one in the array. So we get hello world on there. And we can also take this, and instead of capitalizing, another feature in here is title. And let's just change this to how are we doing? How are you doing? Instead of we, we'll do you. And let's run that. And you can see here, because we created it as a title, it capitalizes the first letter in each word. And in this one, we're going to do character lower. Two different examples here. We have an array. We have hello world all capitalized, and we have just hello. And you can see that one is an array and one is just a string. If we run that, you get an array with hello world lowercase and hello lowercase. And if we're going to do it that way, we can also do it the opposite way. There's also upper. And let's paste those in there. And you can see here we have character.upper opposite there, python.data, and we'll do Python is easy. Hopefully you're starting to get the picture that most of the Python and the scripting is very simple. It's when you put the bigger picture together and starts building these puzzles and somebody asks you, hey, I need the first letter capitalized, unless it's the title, and then you start realizing that this can get really complicated. So NumPy just makes it simple, and we like that. And so in this case, we did Python data. It's all uppercase. Python is easy, like shouting in your messenger. Python is easy. And then if you're ever processing text and tokenizing it, a lot of times the first thing you do is we just split the text, and we're just going to run this np.character.split. Are you coming to the party? If we do that, it returns an array of each of the individual words. Are you coming to the party, splitting it by the spaces? And then if you're going to split it by spaces, we also need to know how to split it by lines. And just like we have the basic split command, we also have split lines. Hello, and you'll see here the scoop in for our new line. And when we run that, if you're following the split part with the words, you should see hello, how are you doing? The two different lines are now split apart. And let's just review 3 more before we wrap this up. Commonly used string variable manipulations. We have strip, and in this case we have Nina, admin, Anita, and we're going to strip A off of there. And let's see what that looks like. And then you end up with nin, demin, nate. It basically takes up all leading and trailing letters. In this case we're looking for A. More common would be a space in there, but it might also be punctuation or anything like that that you need to remove from your letters and words. And if we're going to strip and clean data, we also need to be able to reformat it or join it together. So you see here we have a character join. We'll go ahead and run this. And it has on the first one, it splits each of the letters up by the colon and the second one by the dash. And you can see how this is really useful if you're processing, in this case, a date. We have day, month, year, year, month, date. Very common things to have to always switch around and manipulate depending on what they're going into and what you're working with. And finally, let's look at one last character string. We're going to do replace. If you're doing misinformation, this is good, pulling news articles and replacing is and what. In this case, we're just doing he is a good dancer. We're going to replace is with was. And you can see here, he was a good dancer. Hopefully that's not because he had a bad fall. He just was from 1920s and has gotten old. So there we go. We've covered a lot of the basics in NumPy as far as creating an array. Very important stuff here when you're feeding it in. How do we know the shape of it, the size of it? What happens when we convert it from a regular integer into a float value as far as how much space it takes? We saw that that doubled it. Item size, you have your in dimensions, and probably the most used is shape. And we'll cover more on shape in part 2. So make sure you join us on part 2 because there's a lot of important things on shaping in there and the setting them up. We also saw that you can create a zeros based array. You can create one with ones. If we do a range, you can see how it is a lot easier to use to create its own range, or a range as it is in NumPy. And you saw how easy it was to add two arrays. We saw that earlier, just plus sign. Then we got into doing strings and working with strings and how to concatenate. So if you have two different arrays of strings, you can bring them together. We also saw how you can fill, so you can add a nice headline, dash, dash, dash. We saw about capitalize the first letter. We saw about turning it into a title, so all the first letters are capitalized. Doing lowercase on all the letters, upper for all the letters, just lower and upper, nice abbreviation. We also covered how to split the character set, how to strip it. So if you want to strip all the A's out from leading A's and ending A's or spaces, you can do that very easily. Also, how to join the data sets. So here's a character join option for your strings. And finally, we did the character replace. Now let's go ahead and dive in there since we're going right into part 2, which is getting some coding going under our belt. And here in our Jupyter notebook, we can go under New and create a new folder, Python 3. I think I forgot to do this last time, but we could just do the Control++, which in any browser enlarges a page, makes it a lot easier to see. Always a nice feature. Another beautiful benefit of using Jupyter Notebook. And let me go ahead and show you a neat thing we can do in Jupyter. This is nice if you're working with people and you're doing this as a demo on a large screen. I'm going to do the hashtag or pound symbol array manipulation, kind of a title of what we're working on. And then I'm going to call this cell type markdown as opposed to code. And you'll see it highlights it here, and then if I run it, it just turns it into array manipulation. And then we're specifically going to be working on array manipulation, changing shape to start with. And we'll go ahead and mark this cell also a markdown, so it has a nice little look there. And then it comes up, and you can see it, just like I said, it just highlights it and makes it in bold print, just making it easier to read. Not a Python thing, but a Jupyter thing that's good to know about, especially if you're working with the shareholders, since they're investing money in you. Of course, the first thing we do is import. We're going to import NumPy as in P, and that should be standard by now. By now, you start a Python program, you're doing some data science. NumPy is just something you bring in there. And let's go ahead and create our array, and we're going to do that as the np.arange. Remember, that's 0. Well, we're going to do 0 to 9, and then we'll go print. Put a little title on the original array. We'll just print that array A. Remember from the first lesson, so we have our array which is 0, 1, 2, 3, 4, 5, 6, 7, 8. And let's add a print space in between. Let's create a second array, B, but we want this to reshape array A. And what does that mean? And the command is simply reshape. And then we have 9 items in here, and this is so important right now. So be very aware, if I did some weird numbers in here, it's not going to work. And we want multiples of 9. We know that 3 times 3 is 9. So we're going to reshape our A array by 3 by 3. And then we're going to print, well, let's give it a title. Oops, I had too many brackets in there. Modified array. And then let's go ahead and print our B. And let's see what that looks like. And as we come down here, you can see we've taken this and it's gone from 0, 1, 2, 3, 4, 5, 6, 7, 8 to an array of arrays. And we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And so we split this into 3 by 3. And you can guess that if I tried to reshape this, let's just do a 5 by 3, which is 15, that's going to give me an error. So it's not going to work. You're not going to be able to reshape something unless the shape, all the data in there matches correctly. So we can take this flat 9, and we call it a flat because it's just a single array. And we can reshape it into a 3 by 3 array. And first you might think matrices, which this is used for that, definitely. I use it a lot in graphing, because it'll come in that I have an array that's xy, comma, xy1, y1, comma, x2, y2. And so the shape of it might be 2 by the length of the number of points. And I need to separate that into X flat array and a Y flat array. And you can see this can be very easy to reshape the array doing that. And we can of course go back. We can do B, do a print, and we'll do B dot flatten. Remember I said it's called a flatten array? And if we run that, you'll see it just goes back to the original one. It takes this 0, 1, 2, 3, 4, 5, 6, 7, 8 and flattens it back to a single array. And then one other feature to be aware of is if we flatten it, one of the commands we can put in there is order. Let me just go ahead and do that. Order equals F. Strangely enough, F stands for Fortran. The whole Fortran days. I remember actually studying Fortran programming language. In this case, you'll see that it uses the first, like 036 is the order. So instead of flattening it like we had before, 0, 1, 2, 3, 4, 5, 6, 7, 8, it now does 0, 3, 6, 1, 4, 7, 2, 5, 8. And if you go to the NumPy array page, you can see here that they have the flatten. I just open up the NumPy ND array flatten setup to look it up. And they have three different options. They have C, F, and A. And it's whether to flatten in C, which was based on how the C code works for flattening, originally worked, which is row major, Fortran, which is column major, or preserve the column Fortran ordering from A. So whatever it was in, the default is the C version. So the default that you saw, you could put order equals C and it'd have the same effect as we saw there before. You could even do order equals A. That would also have the same effect because that's the default. So really the only other thing you really should change on here is to change it to C if you need it. And you can see right here, or F, I mean not C. The only thing you really want to change it to is to your F for the Fortran order, which then does it by column versus by row. And let's look at, here we go, reshape. So let's create a range of 12, and let's reshape it. And we'll do 4, 3 for this one. And remember this is NumPy. I forgot the NP there. np.arrange. And we can type in just A for print, or you can do full print A. And of course the Jupyter Notebook even have a little extra print at the beginning. If we run this, we'll see we create a nice array of 0, 1, 2. It's reshaped it. So we have 4 rows and 3 columns, or you could call that 3 columns and 4 rows. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But this one is so important. We'll do np transpose A. And let's go ahead and run that. And it helps if I get all the S's in there and don't leave an S out. And you'll see here we've taken our array. If you remember correctly, we had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we've swapped it. So we've gone from a 3 by 4 or a 4 by 3 to a 3 by 4. And this really helps if you're looking at like a huge number of rows and the data all comes in. Like let's say this is your features in row 1, your features in row 2, and this is X, Y, Z. Well, when you go to plot it, you send it all of X in one array, all of Y in one array, and all of Z in another array. And so it's really important that we can transpose this rather quickly. This is kind of a fun thing. I can highlight it and do brackets around it, and if you remember correctly, because we're in Jupyter, it doesn't matter where we do the print or not. It'll automatically print it for us. And you see if I hit the run button, it comes up with the same exact thing. And let's play with the reshape, and you know what, let's zoom this up a little bit here. Make that even bigger so you can really see what's going on. And let's play with the reshape just a little bit more. We'll do B equals np.arange. Let's do 8. And reshape, we'll do 2, 4. Let's go ahead and print B and then run that. And you'll see we have now the 2 rows. This is a bit more like, say we have 4, maybe 2 rows of 4 things. So this might be all of our X components and our Y components. So we can switch it back and forth real easy. Important to note here, whether we do 2, 4, or in the case of 4, 3, this has 12 elements. And so however you split it up, it's got to equal 12. So 4 times 3 equals 12. That's pretty straightforward. Same thing down here. 2 times 4 equals 8. If I change this, and let's say I do 2, 3, let's just run that in, and you'll find we get an error because you can't split 8 up into 2 rows by 3. You have to pick something that it can split up and arrange it in. So let's go ahead and run that. And just for fun, let's go reshape our B again, if I can type. Reshape our B again. And what else goes into 8? Well, we could do 2 by 2 by 2. So we can take this out to 3 different dimensions. And then, if we, because this is going to come out as a variable, we can just go ahead and run it. And it'll print it. We could also do a print statement on there, just like we did before. And you'll see we have 2 different groups of 2 variables of 2 different dimensions. So 2 by 2 by 2. And let's go ahead and assign this to a variable. C equals B reshape. And let's do something a little different. Let's roll the axes. Roll axes. And we'll take our C and do 2, 1. And if we go ahead and run this, it's going to print that out. Whoops. Hit a wrong button there. Let's do that one again. And you roll the axis, and you can see that we now have, instead of 0, 1, 2, 3, 4, 5, 6, 7, we now have the 0, 2, 1, 3, 4, 6, 5, 7. So what's going on here? We're taking and we're rolling the numbers around, and let's just simplify this. We'll just do it with C, 1 and run that. And so if we roll a single axis, you got 0, 1, and then it rolled the 4, 5 up, and then we have 2, 3, 6, 7. And if we do 2, let me see what happens there. And this is one of those things you really have to play with and start feeling what it's doing. We've now taken 0, 2, 4, 6, 1, 3, 5, 7. So you can see we've now rolled by 2 digits. Instead of rolling the 1 setup, we now rolled 2 digits up there. And so if we go back and we do the 1, so we've rolled it up, 0, 1, 4, 5. And then we're going to take the 2 in there. And we've rolled the 0, 1, 2, 3, 4, 5, and 6, 7. So we start rolling these things around on here. There's a lot of different things you can do on this. But it's another way to manipulate the numbers on your NumPy. And finally, let's go ahead and swap axes. We'll do C. And let's just go ahead and run that. It's going to give me an error on there. That's because it requires multiple arguments. Left out the arguments. So now we can swap them. We get the 0, 2, 1, 3, 4, 6, 5, 7. So you can see everything's been swapped around. So next thing we want to go over is we want to go over NumPy arithmetic operations. How can we take these and use these? Let me just go ahead and put this cell as a markdown. There we go. We'll run that so it has a nice thing. All right, nice title on there. That's always helpful. And let's start by creating 2 arrays. We'll do A is an NP range, A range 9. And let's reshape this 3 by 3. So by now you should be seeing this reshape stuff, and this should all look pretty familiar. We have our 0, 1, 2, 3, 4, 5, 6, 7, 8 on there. And let's create a second one, B. And this time, instead of doing A range, let's do NP array. We'll just create a straight up array. And we'll do an array of 3 objects. So it's going to be 3 by 1. And if we go ahead and print B out, we run that. This is actually pretty common to have something like this, where you have a 3 by whatever it is and a 3 by 3 array. When you're doing your math, you kind of have that kind of setup on there. And what we can do is we can go np.add AB. Don't forget, we can always put a print statement on there. So if we add it, you'll see that it just comes in there and it goes, okay, we're adding 10 to everything. And we could actually do something more, make it more interesting. 10, 11, 12. So let's change B's, now 10, 11, 12, and let's run that. And you can see that we have 10, and then you had 1 plus 11 is 12, 2 plus 12 is 14, 13, so 10 plus 3 is 13, 11 plus 4 is 15, and 12 plus 5 is 17, and so on. We'll put this back, since that's how the original setup was. Let's do 10 by 10 by 10, and run that, and get the original answer. And if you're going to add them together, we need to go ahead and subtract AB, and we run that. We get minus 10, minus 9, minus 8, just like you would expect. So we have our subtraction. 0 minus 10 is minus 10, and so on. And if you're going to add and subtract, you can guess what the next one is. We're going to multiply. And we'll multiply AB And this should be pretty straightforward. You should expect this. If we multiply 10 times 0, we got 0. 10 times 10 is 10, and so on. And finally, if you're going to multiply, what's the last one we got is divide. What happens when we do divide a by b? And we run this, and we're going to get 0. And this is 0 divided by 10 is 0, 1 divided by 10 is 0.1, 2 divided by 10 is 0.2, and so on and so on. So the math is pretty straightforward. It just makes it very easy to do the whole setup. And again, if we went this, and let's say, let's change this up here. Instead of 10, we do 100. And make this 1,000. There we go. And if we run that, and then we do the add, you can see we got 10 plus 100 plus 1,000. Same thing with the subtract. Same thing with the multiply. And then you can also see the same thing here with the divide. So a lot of control there with your array and your math. Again, let's set this back to 10. Oops, it's right up here, wrong section. There we go, 10. And we'll just go ahead and run these and get back to where we were. And this brings us to our next section, which is slicing. And let's put in our, we'll just make this a cell type markdown. And then we run that. Of course, it gives us a nice looking slicing there. And the slicing means we're just going to take sections of the array. So let's create an array np a range. Let's just do 20. And if you remember, if we do a, we have a 0 to 19. And then we can do a, and remember we can always print these. This can always be put in a print, but because I'm in Jupyter, if you're doing a demo in Jupyter, it's just so great that you have all these controls on here. So we can slice 4 on, and this should look familiar because this is the same as a Python and a lot of other different scripting languages. If we do 4, it goes 0, 1, 2, 3, that's the first 4 in the thing, and it skips some and starts with this one. The first 4 are skipped, and then from there on. You can also do the opposite and go till the 4th one. If we run that, we get 0, 1, 2, 3. Quite the opposite on there. We can do a single item, so we can pick object number 5 on the list, run that, and 5 happens to be 5, because that's the order they're in. And then this one's interesting, because I can do s equals slice, and let's create a slice here, and let's do 2, 9, let's leave a 2 on there. So we'll create an s slice on here. And then if we take our array, and we do array of s, we're taking our slice in there, and let's go ahead and run that. And let's take a look and see what it generated here. First off, we started with 2, so we have 2 at the beginning. We're going to end at 9, which happens to be 8, so it stops before the 9. Remember when we're doing arrays in Python. And then we step 2, so 2, 4, 6, 8. We could do this as 3. Let me run that, and you can see how that changes, 2, 5, 8. And we could do this as, let's leave this at 3, and if we change this to 10, oops, let's make it 12. There we go. And we run that, we have 2, 5, 8, 11. So that's pretty straightforward. It's a very nice feature to have on here where you can slice it and take different parts of the series right out of the middle. So now that we've accessed the different pieces of our array, let's get into iteration. And this is interesting because my sister, who runs a college data science division, the first question she asks is, how do you go through data? And she's asking, do you know how to iterate through data? Do you know how to do a basic for loop? Do you know how to go through each piece of the data? And in NumPy, they have some cool controls for that. So put this as a markdown. There we go, and run it. And it's called the ND-iter. I'm not sure what the ND stands for, but ND-iter for iterator. So before we do that, though, let's create an array or something we can actually iterate through. We'll call it a equals np a range. Let's do something a little funny here, or funky. And we'll do 0, 45, 5. I'm not sure why the guys in the back picked this particular one, but it's kind of a fun one. And if I run that, we do this, you can see we get 0, 5, 10, 15, 20, 25, 30, 35, 40. That's what this array looks like. And that's just from our slice. This is just a slice. That's all that is we created a slice of 0 to 45, step 5. And so we can do it. So if we run that, whoops, missed something there. That is the A. That really helps. So if we do the A reshape, and we'll go ahead and print that out. We get 0, 5, 10, 15, 20, 25, 30, 35, 40. And then we simply do 4xn, our NumPy nd iter of a colon, and we'll just go ahead and print x. And let's see what happens here when we run through this and we print each one of those. It goes all the way through the whole array, so it's the same thing we just saw before. We got 0, 5, 10, 15, 20, 25, 30, 35, 40. So it prints out each object in the array, so you can go through and view each one of these. And certainly if you remember, you could also flatten the array and just do for a and that also and get the same result. There's a lot of ways to do this, but this is the proper way with the nd iterator because it'll minimize the amount of resources needed to go through each of the different objects in the NumPy array. And hopefully you asked this question when I just did that. And the question is, how can I change this instead of doing each object? So first of all, let's go ahead and take my cell type and we're going to mark that down and run it. And so we're going to work on iteration order C style and F style. Remember C because it came from the C programming and F because it came from the old Fortran programming. So let's give us a reminder. We'll do a print A and we'll do 4xn np iterate A. But we also want to do this in a specific order. And you know what? I'm a really lazy typer, so let's go back up here. This is the nd iterator. I knew I was missing the nd part of A. And let's do order equals C. We'll print X on there. And let's do that again. And this time order equals F. There we go. Order equals F. And let's go ahead and run this and see what happens here. And the first thing you're going to notice, our original array, 0, 5, 10, 15, 20, 25, 30, 35, 40. When we do order C, that's the default, 0, 5, 10, 15, 20, and so on. And then when you come down here, you'll see F, order F, is 0, 15, 30. So it takes the first digit of each of the subarrays, or the second dimension, and then it goes into the second one, 5, 20, 35, 10, 25, 40. So slightly different order for iterating through it if you need to do that. So we've covered reshaping, we've covered math, we've covered iteration, we've covered a number of things. The next section we want to go ahead and go over is going to be joining arrays. So we need to bring them together. Let me go ahead and take the cell and make it a markdown. Cell type markdown. There we go. And run that. So let's work on joining arrays so we can bring them together and what different options we have. And let's do, we'll do an NP array 1, 2, 3, 4. We'll go ahead and print. Let's do, oops, first. Well, these arrays aren't that big, so let's just go ahead and keep it all on one line, A. So if we run this, first array 1, 2, 3, 4. Whoops, I forgot that it automatically wraps it when you do it this way. So we'll go ahead and keep it separate and print A. There we go. And let's go ahead and do a B. And we'll do 5, 6, 7, 8. And notice I'm keeping the same shape on these two arrays. Depending on what you're doing, those shapes have to match. And let's go ahead and print second array. Do a print B. We'll go ahead and run that. Oops. Missed something up there. Let me fix that real quick. When I was reformatting it to go on separate lines, I messed that up. There we go, run. All right, so we have first array 1, 2, 3, 4, second array 5, 6, 7, 8. And we'll put a carried return on there. And the key word we use is concatenate. And if you're familiar with Linux, it usually means you're adding it to the end on there. And we're going to do what they call along axis 0. So we have concatenate AB along axis 0. Let's go ahead and run that and see what that looks like. And so we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have an array that is 4 by 2. Has a nice shape of 4 by 2 on here. And if we're going to do it along the axis 0, you should guess what the next one is. We're going to do it along the 1 axis. And let's see how those differ from each other. Let's just go ahead and run that. And again, all we're doing is adding in the axes equals 1. So we have our concatenate, we have AB, and then axes 1. Remember a couple things. One, these are the same shape. So we have a 2 by 2, same dimensions going in there. You're going to get an error if you're concatenating and they're not. If you have something that instead of 1, 2 is 1, 2, 3, 4, 5, 6 with a 5, 6, 7, 8. They'll give you an error on there. In fact, let's take a look and see what happens when we do that. Let me just take this. 1, 2, 3, 3, 4, 5. And let's run that. And if we come down here, oh, we got there. It says all the input array dimensions except for the concatenation axes M must match exactly. So it'll let you know if you mess up. That's always a good thing. Let's go ahead and take this back here, and let's go ahead and run that. And so we have our 0 axes, which is 1, 2, 3, 4, 5, 6, 7, 8. And we bring them together. And you'll see a very different setup here when we do it along the axes 1. We end up with, instead of 4 by 2, we end up with a 2 by 4. 1, 2, 5, 6, 3, 4, 7, 8. And that's just changing which axes we're going to go ahead and concatenate on. What I find is when you're talking about the concatenate or the joining arrays, you really got to play with these for a while to make sure you understand what you mean by the axes. It looks very intuitive when you're looking at it. Axes 0, 1, 2, 3, 4, 5, 6, 7, 8. Axes 1 is then splitting it a different way, 1, 2, 5, 6, 3, 4, 7, 8. When you're actually using real data, you start to really get a feel for what this means and what this does. So if we're going to do that, let's go ahead and look at splitting the array. And do that under Markdown and run it. There we go. So you have a nice little title there. And we'll go ahead and create an array of 9. Let's do NP split. We'll do A, and we're going to split it by 3. Let's just see what that looks like. So if we split it, we get an array 0, 1, 2, 3, 4, 5. We get 3 separate arrays on here. Now remember, we're looking at, let me just print A up here. So we're looking at 0, 1, 2, 3, 4, 5, 6, 7, 8, and then we can split it into 3 separate arrays. And let's take this, we're going to do this right down here. I'm just going to move the A split down here. Instead of the 3, let's do 4, 5. And put that in brackets. And so when we do it this way, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And that's kind of interesting. I wasn't sure what to expect on that, but we get, when you split an A by 4, 5, you get a totally different setup on here as far as the way it split the array. And to understand how this works, I'm going to change the 5 to a 7. And this will visually make this a little bit more clear. So we had 4 and 5, it went 0, 1, 2, 3, 4, 5, 6, 7, 8. And you see the markers 4 and 5. When we do 4 and 7, I get 0, 1, 2, 3, 4, 5, 6, 7, 8. And so what you're looking at here is the first marker is this is going to go to 4. So there's our first split at the 4, the marker at 4, and then the second split is going to be at position 7. And this is the same thing here. 4, position 5. That's why we're splitting it in those 2 sections. We could also do it 7. Let's just see what that looks like. Run. And you can see I now have 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can split it in all kinds of different ways and create a different set of multiple arrays on here and split it all kinds of different ways. And before we get into the graphs and other miscellaneous stuff, let's go ahead and look at resizing the array. We'll go ahead and take this cell and set the cell as a markdown and run it. Give us a nice title there. And we'll do an array, an NP array of 1, 2, 3, and 4, 5, 6 here. And let's go ahead and just print. Let's go print a dot shape. And we'll go ahead and run that. Whoops, hit a wrong button there. Hit the comma instead of the dot. So we have a shape of 2, 3 here. And this is important to note because when we start resizing it, it's going to mess with different aspects of the shape. And so we'll go ahead and do a print. Scoop in for a blank line. There we go. And let's do B equals np.resize. We're going to resize A, and let's resize it with 3 by 2. And then we'll just go ahead and print B. and print b period shape, not a comma. We'll run that. Oops, forgot the quotation marks around the end. We'll go ahead and run that, and let's just see what that looks like. So we have 1, 2, 3, 4, 5, 6, our original array, with a shape of 2, 3. And then we want to go ahead and resize it by 3, 2. And we end up with 1, 2, 3, 4, 5, 6, and we end up with a shape of 3, 2. That shouldn't be too much of a surprise. You know, we got 6 elements in there. We can resize it by 2, 3 was the original one, and then we're actually just reshaping it is how that kind of comes out as when you resize it like that. But what happens if we do something a little different? And let's go ahead and just take this whole thing and copy it down here so we can see what that looks like. And instead of doing 3, 2, remember last time I did the, to reshape it, I messed with the numbers and it gave me an error. Well, when you resize it, you don't have to match the numbers. They don't have to be the same dimensions. So we can, instead of going from a 2, 3 to a 3, 2, we can resize it to a 3, 3. So let's take a look and see how it handles that. And when we come down here to 3, 3, we end up with 1, 2, 3, 4, 5, 6, and it repeats 1, 2, 3. So it actually takes the data and just adds a whole other block in there based on the original data and repeating it. All right, now at this point, we've been looking at tons of numbers and moving stuff around. What we want to go ahead and do is get a little visual here, because that certainly you can picture all the different numbers on there, but let's look at histogram. Let's put this into a histogram. Let me go ahead and run that. And to do that, we're going to use the Matplotlib library. So from Matplotlib library, we're going to import pyplot as PLT. And that's usually the notation you see for pyplot. So if you ever see PLT in a code, it's probably pyplot in the Matplotlib library. And then the guys in the back did a nice job, and gals too, guys and gals back there. Our team over at Simplilearn put together a nice array for me, 20, 87, 4, 40, 53, with a bunch of numbers. That way we had something to play with. And what we want to do is we want to plot the histogram. Now remember, a histogram says how many times different numbers come in. And then we're going to put them in bins. And we have bins 0 to 20 to 40 to 60 to 80 to 100. You might, in here with the Matplotlib library, they call them bins. You might hear the term buckets, or they put them in buckets. That's a really common term. And then we want to give it a title. So the way it works is you do your plt.hist for histogram, your plt title, and your plt show. And we're doing just a single array in here in the NumPy array of A. And let's go ahead and run this piece of code. Take it a moment to come out there. It says figure size, so it's generating the graph. And you can see we have, and let's just take a look at this. Let me go down a size. There we go. Okay, so now we can see we're taking a look at here. So between 0 and 20, we have 3 values. So we have a 20 here, we have a 4, and a 11, and a 15. 0, 1, 2, 3. It's actually 4 values, but they start at 0. So remember, we always count from 0 up. And from 20 to 40, we got 20. So it's 1, 42, 3, 4, 5, 6. And so you can see in the histogram, it shows that the most common numbers coming up is going to be between the 40 and 60 range, least common between the 80 and 100. This looks like an age demographics is what this looks like to me. And you can see where they would have put it in the buckets of different age groups, which would be a nice way of looking at this. Histograms are so important and so powerful when you're doing demos and explaining your data. So being able to quickly put a histogram up that shows what's common and how it's trending is really important. And using that with a NumPy is really easy. And you know what, let's take the same data, and I want to show you why we do bins, or why we have buckets of data. I'm used to calling them buckets. Why we have bins. Let's do it instead of by 20, let's do it by tens and see what happens. And what happens when you do it by tens is you miss out on you can see a nice curve here on the first one, and on the second one it looks like a ladder going up and a plummet, a ladder going up and a plummet, and a ladder going down. So the first would be more indicative of an age group, and the second one would be what you would get if you divided incorrectly. You wouldn't see the natural trend of I don't know what this would be. Maybe how much food they eat. Hopefully not, because I'm in 50, so I'm right in the middle there, which means I eat a ton of food compared to everybody else. But it's some kind of demographic. Maybe it's mental. Maybe it's knowledge, because we hit a certain point and then we start losing, our marbles start leaking out or something. So you start off knowing something, and then as you get older, you grow more. But you can see here where you lose that. You lose that continuity in the thing if you split the histogram into too many bins or too many buckets. And if you actually plotted this by the individual numbers, it would just be a bunch of dots on the graph and wouldn't mean a whole lot. And we've looked at graphs. There turns out are a ton of useful functions in NumPy. I'm sure there's even new ones that aren't going to be in here. But let's just cover some important ones you really need to know about if you're using the NumPy framework. One of them is line space function. This is generating data. So you have a line space, we have 1, 3, 10, and when we do that, we end up with 10 numbers. So if you count them, there's 10 numbers. They're between 1 and 3, and they're evenly spaced. We get 1, 1.222. But these are all, there's a total of 10 here, and it's right between the 1 and 3 range. That can be, there's a lot of uses for that, but they're probably more obscure than a lot of the other common NumPy arrays set up. Then a real common one is to do summation. So we'll do summation where you do, in this case, we create a NumPy array of two different arrays, 1, 2, 3, or two different dimensions, 1, 2, 3, 3, 4, 5. And we're going to sum them up under axes 0, which is your columns. And if you remember correctly, columns is the 1 plus 3, 2 plus 4, 3 plus 5, so we have 3 columns. And if we change this, we'll just flip this to 1. We get 2 numbers. So we get 1, 2, 3 all added together, which equals 6, and 3 plus 4 plus 5, which equals 12. We'll set this back to 0. There we go, since we're looking at axis 0. And these probably could have been, some of these could be underneath our math section. Square root and standard deviation, 2 very important tools we use throughout the machine learning process and data science. And simply we take the NP array, we have again the 1, 2, 3, 4, 5, 6, 3, 4, 5. I don't know why I need to keep recreating it, I probably could have just kept it. But we can take the square root of A. So it goes through and it takes the square root of all the different terms in A. And we can also take the standard deviation, how much they deviate in value on there. And there's a rabble function. We can run that. And NP array is x, we're going to do x equals, hey, we changed it from A to x. X equals rabble. And this sets it up as columns. So we have 1, 2, 3, 4, 5. This is all columns on here. Very similar to the flatten function. So they kind of look almost identical. But we also have the option of doing a rabble by column. And then another one is log. So you can do mathematical log on your array. In this case, we have 1, 2, 3. And we'll find the log base 10 for each of those 3 numbers. And there's a couple of them. You can't just do any number here after log, but there is also log base 2. Log base 10 is pretty commonly used on here. We'll go and run that. There we go. Before we go, let's have a little fun. Let's do a little practice session here on some more challenging questions. So you start to think how this stuff fits together. Right now we just looked at all the basics and all the basic tools you have. So let's do some NumPy practice examples. And let's start by figuring out how do you plot, say, a sine wave in NumPy. What would that look like? And so in this project we wouldn't have to do this because I've already run these. But we'd want to go ahead and import our NumPy as NP and import our Matplotlib library pyplot as PLT. So we get our tools going here. And then we'll break it into 2 sections because we need our XY coordinates in here. So first off, let's create our x coordinates. And our x coordinates we're going to set to an A range. And we want this A range, since we're doing sine and cosine, it's going to be between 0 and 0.1. And then we use our NP, and we actually can look up NumPy stores pi. So you have the option of just pulling pi in there directly from NumPy. It has a few other variables that it stores in there that you can pull from there. But we have NumPy pi. And we generate a nice range here. And let's go ahead and run this. And just out of curiosity, let's see what x looks like. I always like to do that. So we have 0.1, 0.2, 0.3, 0.4. So we're going 0 to, in this case, 9.4, 3 times NumPy pi. Remember that pi is like 3 point something, something, something. So that makes sense. It should be about 9. and we're doing intervals of 0.1. So we create a nice range of data. And then we need to create our y variable. And so y is going to simply equal np or numpy.sign of x. And then once we have our x and y, and if we print, let's go ahead and just print y. See how that, we'll do this. Let's do this so it looks print x, print y. So we basically have two arrays of data. So we have like our x-axis and our y-axis going on there. And this is simply a plt.plot because we're going to plot the points, and we'll do x comma y, and then we want to actually see the graph, so we'll do plot.show. And we'll go ahead and run that. And you see we get a nice sine wave. And here's our numbers 0 through 9. And here's our sine value, which oscillates between -1 and 1 like we'd expect it to. Then for the next challenge, let's create a 6x6 two-dimensional array and let 1 and 0 be placed alternatively across the diagonals. Oh, that's a little confusing. So let's think about that. We're going to create a 6x6 two-dimensional, so the shape is 6x6, two-dimensional array, and let 1 and 0 be placed alternatively across the diagonals. Now, if you remember from lesson 1, we can fill a whole NumPy array with zeros or ones or whatever. So we're going to do np, create a NumPy zeros, and we're going to do a 6x6, and we'll go ahead and make sure it knows it's an integer, even though it's usually the default. And just real quick, let's take a look and see what that looks like. So if I run this, you can see I get 6x6 grid, so 6x6, 0, 0, 0, 0, 0. Now, if I understand this correctly, when they say 1s and 0 placed alternatively across the diagonals, they want the center diagonal, maybe that's going to stay 0 all the way down, and then the next diagonal will be 1s all the way across diagonally, and then the next one zeros, the next one ones, and the next one zeros, and so on. Hopefully you can see my mouse lit up there and highlighting it. So let's take a little piece of code here, and we'll do z1 : 2, comma : 2 equals 1. And wow, that's a mouthful right there. So let's go ahead and run this and see what that's doing. And so what we're doing is we're saying, hey, let's look at, in this case, row 1. There's 1. And then we're going to go every other row 2, so we're going to skip a row. So skip here, skip here, skip here. So we're going down this way, and we're going every other row going this way. It's hard to highlight columns. So you can see right here where we're not touching each row, like this row right here is not being touched. Okay, so we're going to start with row 1, and then we're going to skip a row and another one, and so we're going every 2 rows. And then in every 2 rows, we're looking at every 2, starting with the beginning. That's what this thing blank means. So we're going to start with the beginning, and we're going to look at all of them, but we're going to skip every 2. So starting with row 1, we look at all the rows, but we do it by 2 steps. So we go 1, skip 1, 1, skip 1, 1, skip 1, 1. If you left this out, it'd do every 1. This would just be 1s. In fact, let's see what this looks like. If I go like this and run it, you can see that I just get 1s. So this notation allows us to go down each row, row by row, and we're going to do every other row set up on there. And so if we're going to start with row 1, we also, Control Z, try that. There we go. We'll start with row 0. Again, we're going to go each row, step 2. So we'll start with row 0, and we'll go every other row. And this time we'll start with 1, column 1. And again, we go every other one going down. That's what that step 2 is. Skipping every other one. We're going to set that equal to 1. So let's see what that looks like. And you can see here we get our answer. We get 0, 1, 0, 0. But it has the 1s going in diagonals on every other diagonal and 0 on every other one. A little bit of a brain teaser, that one, trying to get that one to work out. So you can see how you can arrange your rows, and here's your step and your different access on there. And then the next one is find the total number and locations of missing values in the array. The first challenge is to create some missing numbers. So let's create our array Z. we're going to do numpy.random.rand 10, 10. And before we do the second part, let me just take this second part out. And let's just see what that looks like. So let's run that. And there we go. So we have a 10 by 10 random array. It randomly is picking out numbers. And next, we want to go ahead and take our random integer size equals 5. And then we're going to do a random 10 size equals 5. So in the Z, we're going to select a number of random spaces here and set them equal to null value. And let's go ahead and run that so you can see what that looks like. And if we look at the array, we've created 1, 2, 3, 4. There should be a fifth one in here. My eyes may be failing me. So we've created a series of, because 0 to 5, 0, 1, 2, 3, 4. So we got 5, there are different null values on here. And this is kind of a neat notation to notice that we can generate random integers, size equals 5. So this generates 5 by 5 miniature grid inside of this to tell it where to put the nands at. So that's kind of a cool little thing you can do. And then we want to look up and see how many null values are in there. And this is simply just np is nan of z. Simple. So if it is nan, then we want to sum it up. So we're going to sum up all of the different null values on there. And let's do one more feature in here, which is really cool. Let's go ahead and print the indexes. So np argware np is nan of z. So we're going to create our own another np array. And let's run this, and we'll see here that it comes up with the 4 indexes. So we did count 4 of them up there. It tells you where they are, 1, 9, 2, 0, 4, 6, 5, 4. And then let's go ahead and run this again. Run, there we go. This time I got 5. That's what we get for random numbers. Another fun one that I always like to do, it's very similar because we have np is nanz.sum. So we're summing the number of nands. And we can get the indexes and you can reshape the indexes. But you can also just do, we'll do an INDS where np is nan of z. And let's just print that. Print INDS. Let's see what that looks like. And it's very similar. We have 0, 1, 3, 0, 6, 3, 8, 6, 9, 3. But I've split it into 2 different arrays. So we have our x and our y kind of coordinates going there. And what I can now do is I can now do z INDS equals, and at this point you can also, instead of getting the sum, you can get the means or the all the numbers and that kind of thing, or the average as it is. So that'd be one thing you could do, and you can pick out the average. That's very common in data science to get the average and just use that for a value. But we'll go ahead and just set it to 0, and then let's go ahead and print our z and run that. And you can see when we come down here, we have wherever there was a null value, it is now 0. And you can set this to whatever you want. This is another way to replace data or help clean data up, depending on what it is you're doing. So, wow, we covered a lot of stuff. So quick rehash going over everything. We went into there, we looked at array manipulation, changing the shape, how to switch that around. We even had the flatten down there, which remember we have another command lower that's similar. We could change the order by F. Remember, F stands for Fortran, very strange connotation, but there's C and F. C is the standard, and F switches it to a different order. To be honest, I usually have to look it up because I almost never use F, but when you need it, you're like, oh my gosh, what was the other order? Just do a quick Google. So we talked about reshape, making sure that the dimensions are the same. You don't want to have like something that has 12 objects in it and reshape it to 11 and 5 because it doesn't work. It doesn't divide into 12. We can transpose, so we can switch them. So we can go from a 4 by 3 to a 3 by 4. Oops, I did that the other way around. 3 by 4 to 4 by 3. We covered reshaping the array. We did the roll the axes. You can do some weird things with swapping and rolling axes and transposing the numbers. We dug a little bit into the arithmetic. So we talked about adding, we talked about subtracting, multiplying, dividing. And at this point it's so important we just look up the NumPy mathematics. And you can see here they have just about everything. Your trigonometry, your hyperbolic functions, rounding, sums, products, differences. There are so many, all your different miscellaneous mathematical connotations. So, Google it, go to the main NumPy page and look at the different setups you can do on there. So we covered that, and we did slicing, how to break it apart. We did iterating over the array. We covered joining arrays and how to concatenate. Remember, concatenate just means add on to it. So in this case, how are you adding B onto A is how you'd read that. From Linux, you should catch the concatenate because that's used regularly there. Splitting the array, we talked about how to split the array in different ways. So you can split it in array of arrays, all kinds of different ways to split the array up. How to resize it. And remember, resize does not have to have the same shape, but if you resize it, it will take the data and begin at the beginning and add new rows on if the size is bigger. If it's smaller, it truncates it. It just cuts the end off. We looked at how to do a histogram and how to plot that. We mentioned buckets or bins, as they call them in PyPlot. And then we covered a lot of other useful functions in NumPy. We talked about the line space setup for doing numbers in a series. How to sum the axes up. Again, that's part of the mathematical formulas there that we looked at. There's a sum, there's also means and median. All of those you can compute in NumPy. And you can also do the square root and standard deviation. The ravel function, very similar to the flatten. To be honest, I almost always just use the flatten, but the ravel has its own kind of functionality that it does. And then we went into some NumPy practice examples. We challenged you to create a sine wave in NumPy and how to do that. We're kind of looking for that A range. Remember how we do the A range, and you can have your beginning value, your end value, which they did as 3 times pi, NumPy pi, and we're going to do intervals of 0.1, and then y just equals the NumPy sine of x. There's our math from the math page we were just looking at. Remember that? It's right at the top. And finally, we went down here. We had this kind of a little brain teaser, how to do diagonal zeros and ones, playing with the different connotations of the NumPy array. And then we did a random size, and we played a little bit with with the null values, playing with null values. If you're doing any data science, null values are like a headache. What do you do with them? Big sets of data, you get rid of them. Small sets of data, you have to factor something in there, like figure out the average or the median there, and then replace it with that. Pandas really is a core Python module you need for doing data science and data processing. There's so many other modules that come off of it. It actually sits kind of on NumPy, so if you've already had our NumPy array, hopefully you've already gone through the NumPy tutorial 1 and 2. So today we're going to cover what is Pandas. We'll discuss series. We'll discuss basic operations on series. And then we'll get into a data frame itself, basic operations on the data frame, file-related operations on a data frame, visualization, and then some practice examples. Roll up our sleeves and get some coding underneath there. And let's start with just some real general, what is Pandas? Pandas is a tool for data processing which helps in data analysis. It provides functions and methods to efficiently manipulate large data sets. Now, this is a step down from, say, using Spark or Hadoop in big data. So we're not talking about big data here, but we are talking about Pandas, and there is some connections. There's like an interface going on with that, so there is availability. But you really should know your Pandas, because if you're working in big data, you'll know there's data frames. Well, Pandas is a data frame primarily. It has a couple different pieces we'll look at here. And if you've never worked with data frames before, a data frame is basically like an Excel spreadsheet. You have rows and columns. You can access your data either by the row or the column, and you have an index and that kind of setup. And we'll dig more into that as we get deeper into Pandas. But think of it as like a giant Excel spreadsheet that's optimized to run on larger data on your computer. And then I said that it's a data frame. So the data structures in Pandas are series, one-dimensional arrays, and then we have data frame, two-dimensional array. And it really centers around the data frame. The series just happens to be part of that data frame. And here's a closer look at a Pandas series. Series is a one-dimensional array with labels. It can contain any data type, including integers, strings, floats, Python objects, and more. So it's very diverse. If you remember from NumPy we studied, they had to be all uniform. Not in Pandas. In Pandas we can do a lot more. And Pandas actually kind of sits on NumPy, so you really need to know both of those if you haven't done the NumPy tutorials. And you can see here we have our index 1, 2, 3, 4, 5, and then our data A, B, C, D, and E. Very straightforward. It's just 2 columns, and we have a nice index label and a column label for the data. And then a data frame is a 2-dimensional data structure with labels. We can use labels to locate data. And you can see here we had, if we go back one, we had our index 1, 2, 3, 4, 5. So in each one of these series, they would share the same index over there, the row index. So you have your row index df.index, and then you have a column index df.columns. And this would look, like I said, this would be really familiar if you've done any work with spreadsheets, Excel. So it kind of resembles that. This does make it a lot easier to manipulate data and add columns, delete columns, move them around. Same thing with the rows. So you have a lot of control over all of this. Now, we're of course going to do this in our Jupyter Notebook. You can use any of your Python editors, but I highly suggest if you haven't installed Jupyter and haven't worked with it, it is probably one of the best ways for easily displaying a project you're working on. I skip between a lot of different user interfaces or IDEs for editing my Python, and it's just simply jupyter.org, jupyter.org, and then I always let mine sit on Anaconda, anaconda.com. And just real quick, we'll open that up for you. Oops, offline mode. Don't show me that again. But you can see here that I have different tools that I can actually install in my Anaconda, including the Jupyter Notebook, which comes by default. And then I have access to the environments. And again, that's anaconda.com, named after the very large, one of the world's largest snakes, and then Jupyter Notebook. In this case, jupyter.org. And when we're in our I'm going to go in here to our Jupyter Notebook, and we're going to go ahead and just do new and a Python 3, and this will open up a Python 3 untitled folder. So diving right in, let's go ahead and give this a title, Pandas Tutorial, and we'll go up to Cell, and we'll change the cell type to Markdown so it doesn't execute it as actual code. One of those wonderful tools when you have Jupyter Notebook so you can do demos with this. And let's go ahead and import Pandas. And usually people just call it PD. That has become such a standard in the industry. So we'll go ahead and run that. Now we have our Pandas has been imported into our Jupyter Notebook. And then, we can go ahead and let me do the Control Plus. Since it's Internet Explorer, I can enlarge it very easily so you have a nice pretty view. Oops, too big. There we go. And whenever you're working with a new module, it's good to check your version of the module. In Pandas, you just use the, in this case, pd.__version__. That's actually pretty common in most of our Python modules. There's different ways to look up the version, but that's one of the more common ones. And we'll go ahead and run that. We get 0.23.4, and if we go to the Pandas site, we see 0.23.4 is the latest release. And of course, a reminder that if you're going to your environment, you need to install it. So you'll need to do pip install pandas if you're using the pip installer. We'll go and close out of that. And the first thing we want to do is we're going to work with series. A lot of the stuff you do in series you can then do on the whole data set. We need to do what? Create one. We need to manipulate it, take pieces of it, so query it, delete, so you can delete different parts of it. So we want to do all those things with the series. And we'll start with the series, and then almost all the code, in fact all the code does transfer right into the actual data table. So we go from a series of a single list of one column, and then we'll take that and we'll transfer that over to the whole table. And we'll start by creating, there we go, creating a series from list. And let's just call this ARR equals, and we'll do 0, 1, 2, 3, 4. If you remember from our last one, we could easily do R equals range of 5, which would be 0 to 4. But we'll do R equals 0 to 4, and we'll call this S1, and we'll go PD, and series is capitalized. This one always throws me, is which letters do you capitalize on these modules? They're getting more and more uniform, but you got to watch that with Python. And we're just going to go ahead and do ARR. So we're just going to take this Python list, and we're going to turn it into a series. And then because we're in Jupyter, we don't have to put the print statement. We can just put S1, and it'll print out this series for us. And let's go ahead and run that and take a look. And you'll see we have 2 rows of numbers. So the first one is the index. Now it automatically creates the index starting with 0 unless you tell it to do differently. So we get 0, index row 0 is 0, 1, 1, 2, 2, 3, 3, 4, 4. And because it's a series, it doesn't need a title for the column. There's only one column, so why title it? And this also lets you know that it's a data type of integer 64. So we print this out. This is our series, our basic series we've just created. And let's do a second series, PD, and we'll use the same data list. And let's go ahead and do order. We'll give it an order equals, let's do it this way. Let's go index equals order. And it helps if we actually give it an order. So we'll do order equals, and let's do 1, 2, 3, 4, 5. So instead of starting with 0, we're going to give it an order starting with 1. We're going to run that, and we'll go ahead and print it out down here, S2. And we'll see that we now have an index of 1, 2, 3, 4, 5, and that represents 0, 1, 2, 3, 4 in the series. And we're still data type integer 64. And very common as you're messing with NumPy arrays is we can import our NumPy as NP. Remember that from our NumPy tutorials. We can go ahead and create a NumPy out of random with the random numbers of 5. And let's just see what that n looks like, so we can see what our NumPy looks like. So we have some nice random float values here, 2.33, so on. And that's from our last tutorial, the NumPy tutorial 1 and 2. And instead of calling it order, let's call it index. And we're going to set our index equal to A, B, C, D, and E. I want to show you that the index doesn't have to be an integer, so it can be something very different here. And then let's go ahead and create we'll just use S2 again. And here's our NP for NumPy, series, capital S, and N is our NP for NumPy. PD for Pandas, there we go, switching my anachronisms. So we have PD.series of N, and we want to do our index equals our index we just created. And then let's go ahead and see what that looks like. S2 is to print it, and let's run that. And we can see here we have a nice series going on. A, B, C, D, and E for our indexes. So instead of it being 0, 1, 2, 3, or 4, we can make this index whatever we want. And you can see the numbers here going down that we randomly generated from the NumPy array. So we used NumPy to create our Pandas series right here. And so continuing on with creating our series, this one I use so often, we create a series from a dictionary. So we have our dictionary. In this case, we went ahead and did A of 1, B is 2, C of 3, D 4, E of 5. So each one of those is a key and then a value. And then we're going to use, let's use S3 equals PD for Pandas, series, and then we want to go ahead and just do D in here. Print out S3 here, and let's go ahead and run this. And you can see we got A is 1, B is 2, C is 3, D is 4, E is 5. And it's still of integer 64 because the actual data is 1, 2, 3, 4, 5, and it's all integer 64, type 64. And the last thing we want to do in the creating section of our series is to go ahead and modify the index, because we're going to start modifying all this data. So let's start with modifying the index of the series. And if you remember, let's do a print this time, S1. I'll go ahead and run this. And the reason I did print is because it only prints out the last variable. So if I put S1 up here and we're going to do another variable back down lower, it won't print the first one, just the last one. And we're going to go ahead and take S1, the index, and we're just going to set it equal to a new index. And obviously, the number of objects in our index has to equal the number of objects in our data. And then because it's the last variable, we can go ahead and just do an S1. And let's run that, and you can see how we went from 0 to 0, 0, 1, 2, 3, 4 as our index. We've now altered it to A, B, C, D, and E. So this would be much more readable or might be representational of a larger database you're working with. So cool tools. We've covered creating a database based on a basic array, Python array. We've showed you how to reset the index. Then we showed you how to use a NumPy array. So you can put a NumPy array in there. It's all the same, pd.series, a NumPy array, and then we can set the index on there. And the same thing with the dictionary. So it's very versatile how it pulls in data. And you can pull in data from different sources and different setups and create a new series very easily in the Pandas. And then we looked on changing your index. So now we have a new index on here. And then we want to go ahead and do some selection. Let's do some basic slicing, most common thing you'll probably do on here. And we'll just do S1 This notation should start to look really familiar. Again, this is going to put an output, so it doesn't change S1. This just selects it. So we might do A equals S1 and then print A. And you'll see that it just looks at the first three, 0, 1, 2. Well, we can do the same thing by not having the A in there. I'll go ahead and take that out, but it's just a reminder that it's not actually changing S1, it's just viewing S1. So simple slicing on here. And we can likewise do an append. Oops, before we do append, let's just do a quick kind of fun one. We'll do to -1, and you'll see it covers everything but the E. Of course, you can do -2 on this side. So another way to select it is to go how far from the end, and likewise we can do a 2 here, a CDE to the end, so it starts at the second one. And another way we can do this is we can do a -2 over here, and that looks at just the last 2 in the slice. So you can see how easy it is to slice the data, and of course there's no reason to do this, but you could select all of them if you wanted to view all of them on there. Oops, 32. There's not 32, so it's just going to show the first 3. There we go. And then we can also append. So I can take and, let's create another series and append one to it. And if you remember, we had S3. There's our S3. And we have our S1. We'll go ahead and do S1. And let's go ahead and do, let's call it S4 equals S1 append S3. So we're just going to combine those two into S4. And if we go ahead and print S4 on here, you'll now see that we have A, B, C, D, E, A, B, C, D, E, 0, 1, 2, 3, 1, 2, 3, 4, 5, because we started the data at 1. So very easy to append one series to the next. And if we're going to append one series to the next, we need to go ahead and drop or delete one. And drop is the key word for that. And let's just do E, or index E. And so if I run this, you'll see that it'll print it out, and A, B, C, D, there's no E. And remember, all these changes, if I type in S4 again, you'll see that S4 still has E in it. So this change does not affect the series unless you tell it to. So I'd have to do like S4 equals S4.drop E. And there's another way to do that, which we'll show you later on. Let me just cut this one out. There we go. Alright, so we've covered all kinds of cool tools here. We have appending, we have slicing, we did all the creating stuff earlier. So you can see here on the setup how easy it is to manipulate the series. So next what we want to get into is we want to get into operations that happen on the series. So let me go ahead and change this cell to Markdown. There we go, and run that. So series operations, what can we do with the series? And let's start by creating a couple arrays. We'll call it array 1, and we'll do 0 through 7, and array 2, 6 through 6, 7, 8, 9, 5. I don't know why we threw the 5 on the end. Let's go ahead and run those so those load up into Jupyter. And we'll do this a little backwards. We're going to do S5 equals a Pandas series of array 2. So I'm doing this in reverse. And then when we do S5, you'll see that we have 0 to 4. It automatically assigned the index. 6, 7, 8, 9, 5 for our series. And let's go ahead and do the same, and we'll call this S6, and we'll set this equal to PD series for our first array. And if we do an S6 down here to print it out, we'll see something similar. I got 0 through 6, 0, 1, 2, 3, 4, 5, 7 for the data. So those are two series we just created, series 6, 5, and 6. And one of the first things we can do is we can add one series to the next. So I can do S5.add S6. And let's see what that generates. And just a quick thing, if you've never used Pandas, what do you think is going to happen with the fact that this only has 5 different values in it, and this one has 7 values? So let's see what that does. And we end up with 6, 8, 10, 12, 9, and it goes, oh, I can't add this. There's nothing there. So it gives us a null return. Very different than the NumPy that would have given you an error. This instead tells you there's no value here because we couldn't generate one. So we can easily add S5.add S6, and likewise we can do S5.sub for subtract S6, and we'll run that. And on the add, the subtract, and you guessed it, we're going to do multiply and divide next. Again, you can see there's null values where it can't subtract the two because there's no values there to subtract. We can also do S5 multiply, MUL. They're all 3 letters on these. That's one of the ways to remember how they figured out the code for this. So remember, these are all 3 letters, mul. We'll go ahead and run this. And you can see how they're multiplied together. And then we can also do the S5 div, 3 letters again, S6, and run that. And you'll see here, this goes to infinity because we have 0 in the wrong position. So it actually gives you a whole different answer here. That's important to notice. And then in the null values, because there's no data and it can't actually produce an answer off of missing data. And since we're in data science, let's do S6 median. So let's look up the median data, which is simply median. Sorry for those who are following the 3 letters, because median is not 3 letters. And you can see in S6 is 3.0. And let's do a print here. And we'll do median or average. S6. And let's print max, comma S6. And just like median, there's max value. And if we're going to have a max value, we should also have a minimum value. So let's pop in minimum. We'll go ahead and run this. And you're starting to see something that would be generated like, say, in R, where you're starting to get your different statistics. We have a median value of 3, max value of 7, and a minimum value of 0. And what it does when it hits these null values, if there is null values in there, because we could still do that, we could actually, you know what, let's go up here and do, let's pick this one where we multiplied. Let's go S7 equals, I'll go ahead and print the S7 just so I keep it nice and uniform, so I still have my S7 down there and run it. And then I want to take the S7, because S7 now has null values and an infinity value, and let's see what happens. This is going to be interesting, because I want to see what it does with infinity. And we end up with a median of 6, maximum of 27, and minimum of 0, which is correct. It drops those values. So when it gets to there and it doesn't know what to do with them, it just drops those values and then it computes it on the remaining data on there. So that's important to know when you're making these computations, you're looking at min and max and median, you're not going to know that there's null values unless you double check your data for the null values. That's a very important thing to note on there. So just a real quick review on there. We've created our PD series, and we've gone ahead and done addition, subtraction, multiplication, division. All of those are 3 letters, so sub, min, div, add. And then we looked at median, maximum, and minimum. So we're going to go ahead and jump into the next big topic, which is to create a data frame. So now we're going to go from series, and we're going to create a number of series and bundle them together to make a data frame. There we go, cell type, markdown. And we go ahead and run that. So we have a nice title on there. It's always good to have a good title. All right, so our first data frame, we'll jump in with some stuff that looks a little complicated. We'll break it down. First, I'm going to create some dates. And you know what? Let's just go ahead and do this. I want you to see what that looks like, what I'm creating here. I've created a series of dates, PD date range, and we're going to use these for the index. Okay, so when you look at this, you'll see that it's just, basically it comes out kind of like a basic Python list or NumPy array, however you want to look at it, with our different dates going down. And we've generated 6 of them. And it's going to have whatever time it is right now on the thing for the date for the time. That's that time stamp right there. And then you'll see we have 11/19, 2008, 11/20, 11/19, and looking into the future there. So that's all this is generating a series of dates that we're going to use as our index. And this is a Pandas command, so we have a date range, which is nice. That's one of the tools hidden in there in the Pandas that you can use. And next we're going to use NumPy to go ahead and generate some random numbers. In this case we'll do the np.random.random in 6, 4. You can look at this as rows and columns as we move it into the Pandas. And of course you could reshape this if you had those backwards on your data. But we want the 6 to match the rows, and we have 6 periods, so our indexes should match along with the rows on there. And then, you know, before we do the next one, let's go ahead and just print out our NumPy array so you can see what that looks like. Here we have it, 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 4 by 6. So it's a nice little setup on there. And since working with data frames can be very visual, let's give our columns, we have 4 columns, and we're going to give them names, A, B, C, and D. So now we have columns on there also. And then let's put this all together in a data frame, and we can actually, you know what, let's do this. Since I did it with everything else, let's go ahead and do columns. And you can see there's our columns on there. And we'll go ahead and do df1 equals pandas.dataframe. And note that the D and the F are capitalized. Series, it was just the S, and I always highlight this because you don't know how many times these things get retyped when you forget what's capitalized on there. It's a minor thing. You'll pick it up right away if you do a lot of it. And the first thing we want to do is we want to go ahead and take our NumPy array, because that's what we're going to create our data frame off of, is the NumPy array. And then we want our index equal to our dates. So there's our index in there. And then we also have columns equals columns. And then finally, let's see what that looks like. Now remember, we had all that different data that just looked like a jumble of data. We have our column names and everything else. Our NumPy array, kind of just a jumble array over there, 4 by 6. You could sort of read it. But look how nice this looks. I mean, this is, you come into a board meeting, you're working with your shareholders. This is pretty readable. This is, this is our date. This is our A, B, C, D, whatever it is. Maybe each one of these dates has your leads, closures, lost leads, total dollar made, whatever it is, if it's in a business. Maybe it's measurements on some scientific equipment, weather searching material, where this is like high of the temperature, low of the day, humidity of the day, whatever it is. So you can see that we can really create a nice clear chart, and it looks just like a spreadsheet. We have our rows, and we have our columns, and we have our data in there. Now this one I use all the time. If we're going to create, we can create it like you saw here with our NumPy array. Very easy to do that and reshape it. You can also create it with a dictionary array. So here we have some data, and let me just go down a notch so you can see all the data on there. We have an animal, in this case cat, cat, snake, dog, dog, cat, snake, cat, dog. We have the age, so we have an array of ages. We have the number of visits and the priority. Was it a high priority? Yes, no. And then we're going to take that, we're going to create some labels. We have A, B, C, D, E, F, G, H, I. And what I want you to notice on this is we have a title, animal, and then we have basically a Python list. And these lists, they don't necessarily have to be equal because we can have non-data, np.nan, NumPy array, null value. But we want to go ahead and create labels that are equal to the number in the list. So A, the first cat, B, the second cat, C, the snake, D, the dog, and so on. So we'll go ahead and create our labels, which we're going to use as an index. And we'll call this df, let's do it this way. We'll call this df2 equals PD for pandas data frame, and then we have our data just like we did before, and then we have our index equals labels. And if we're going to go from there, let's go ahead and print it out so we can see what that looks like. df2. So let's go ahead and run that. And again, you have a nice, very clean chart to look at. We've gone from this mess of data here to what looks like a very organized spreadsheet, very visual and easy to read. Animal, age, visits, priority, and then A through J, cats, and all your different animals, so on and so on. And then when you do programming, a lot of times it's important to know what the data types are. So we can simply do df2 dtypes. And if we run that, we can see that our animal is an object, because it's just a string, but it comes in as an object. Age is a float 64, integer 64, and then priority again is just an object. And exploring this one's very popular. Let's go df2 head, and if we print that out, the df2 head returns the first 5. And we can change this. You don't have to do 5. You might want to just look at the top 2. Maybe you want to look at, let's see, let's do 6. So maybe we want to look at just the top 6 in the database, in your data frame. And you can actually, this creates another data frame. So I could have a df3 equal to df2, and this now takes the df2 and just the first 6 values. So if we do df3, run, get the same answer. And if we do the head of the data, we can also do the tail. It's the same thing. df_tail, you can look at the last, we'll just do the tail, which by default does 5, the last 5. And of course you can just look at the last 3 of those real quick just to see what's at the end of the data. And this is, the tail, I love doing the tail of 1 because I'll have like the index or something like that, and it will just show me the last, whatever the last entry was. Looking at stock values, and I might want to look at just the last 5 days of the stock values. I can do that with the data frame tail. And some other key things to look up are the index. So we can do df2.index. And I want you to notice that this isn't a call function. So if I put the brackets on the end, it'll give me an error because index is not callable, it's just an object in there. So we do df2.index. There's also columns. So we can go ahead and let's print this. Remember, the first one's not going to show unless I print it, and then df2 columns. So now we can see that we have our indexes and we have our columns listed here, df2.columns, animal, age, visits, priority. It tells you what kind of object it is, or what kind of data type it is, and they're both object. And then finally df2.values. And again, there's no brackets on the end of df2.values because this is an actual object, it's not a callable function. So we'll go ahead and run that, and it just displays a nice array. A very easy way to convert this back to a NumPy array, basically. So before I go into the next section, let's just take a quick look at what we covered so far with the data frame. We came up here, we created our data frame. We did it from a NumPy array first, setting the columns and the index. The index setting it up is the same as when we set up the series, so that should look very familiar. So is the whole format, the NumPy array, the index dates, and the columns. And remember, in our NumPy array, we're looking at row, comma, column. So 6 rows, 4 columns is how that reads in the data frame. And we went ahead and also did that from a dictionary. In this case, animal was the column name with all the data underneath that column, and then age with that data, visits that data, priority that data. And then of course we added our labels in there for our index. So there's no difference in there, but it automatically pulled the column names. Important to know when you're dealing with a data frame and importing a data frame this way. And then we did looking up dtype. We looked at head and tail, looking at your data really quick. We also did index and columns and values. And note these don't have the brackets on the end. So the next thing we want to do is go ahead, since we're dealing with data science, is we want to go ahead and describe the data. So we have df2.describe to do that, and we're going to manipulate it in just a minute, but let's just see what this generates. And you can see right here we have age and visits. So looking at our data from up above, let me just go all the way up here. Animal, age, visits, priority. And it does a nice job generating your age versus visits, which has all the data. You have your count, your means, your standard deviation, your minimum value, 25% are in this group, 50%, 75, and your maximum value. So this will look familiar as a data science setup with your describe for a quick look at your data frame data. So let's start manipulating this data frame and moving stuff around, and we'll start with transposing. And it is simply capital T for transpose. And when we run that, it flips the columns and the indexes. So now the indexes are all column names and the columns are all indexes, animal, age, visits, priority. So if we had come in here with our data shaped wrong, up above where we had a 4x6, we can quickly just swap it if we had it backwards. Not a big deal. And we can also sort our data, something that you can't do, which is more difficult to do with a lot of other packages. In the data frame, it's really easy to do. Take our data frame df2, and we're going to sort underscore values by equals age. And so when we run this, you'll see the default is ascending. So we have 0.52, 2.53, and everything else is organized. So if you look at your indexes, they've been moved around because each index, it moves the whole row, not just the one piece of data is not being sorted. So a very quick way to sort by age our different data in the data frame. And in addition to sorting it, we can also slice the data frame. So I could do df2, and this should look familiar from earlier. We'll just do 1 to 3. So we're going to pull out, oops, it does help if I use a df instead of just d. And we're going to pull up just between 1 and 3. So we have not 0, which is A, but we have B, which is 2, or B, which is 1, and C, which is 2. So 1, 2, and then it does not include 3, which is the standard in Python. And we can even do something like this. We can combine them, which is always fun, because remember this returns a data frame. So if I take df2.sort values, and we'll do by equals age. This is just kind of fun. And then I'm going to slice it. There we go. Double check my typing and run it. And now you should see FA, because FA are now 1 and 2 on there. So you can very quickly create a whole string on here which narrows it, that you can sort it, then slice it, and do all kinds of fun things with your data frame. We'll just go back to the original one. Run. There we go. And if we can slice it by row, we can also query the data frame. So we can do df2. And this is a little different because I'm going to create an array within an array. And in this case, we're going to look at, let's do age, comma, visits. So look at the different format in here. We have 1 to 3. So we've done this by slicing by an integer value. And then on here, I've done df2 age, comma, visits in an array. And when I run this, you can see that we get just these 2 columns on here. We get age and visits. So it's a quick way to select just 2 columns or select number of columns you're working with. And if you saw up there, we did the slicing. Almost identical to slice is iLocation, which uses the integer location 1, 3. There's a push in Pandas to move to this particular setup instead of doing just a regular slice. And that's because this can be confusing when we slice 1 to 3 and then we select age and visits. So there is a push to go ahead and move to an iLocation, which does the same thing. You can see here BC, it's the same as up above. There's also a copy command, so we can do df3 equals df2 copy. We're just going to create a straight copy of it. And of course, if we do df3, it'll be the same as a df2 on there. So df3 equals df2.copy. And then let's do df3.isNull. So we're looking for null values. And this will return a nice map, and you'll see that everything is false, except when you go up here under the cat or H, they had a null there. And so if we go, they have a couple up here also underneath of, let's see, the dog. Okay, there's a bunch of nulls in here. There's D up here. So let's look at D down here, and you'll see false, true. There it is. There's our null value. So we can create a quick chart of null values. You can use this to do other things. We can leverage that null value to maybe take an average or something and fill those null spaces with data. And we can also modify the location. So here's our df3 location. And notice this is location, not iLocation. iLocation has I for integer. Location uses the, in this case, the variables on the left. And what we can do on here, and we'll go ahead and just set this equal to 1.5, and then let's pick a spot. Let's go back up here where we had, let's do F age. Let's see, what was we looking at? Oh, here we go. Let's do F and age. And up here, F is set to age of 2.0. And we find out that that's incorrect data, so we go ahead and switch to df3 equal, and then we go ahead and print out our df3. And if we go to F and age, it is now 1.5. So we're just changing the value in the df3. And this is changing the actual data frame. Remember, a lot of our stuff, we do a slice, and like it returns another data frame. This changes the actual data frame and that value in the data frame. So we've covered location and iLocation is null. Making a copy, here's our iLocation, which is equivalent of a slice, and also selecting columns. So now we want to just take a little detour here, and let's look at df3 means. And this is kind of nice because you can do this. You can either do this by, you can select a single column here, by the way. You can just add the column selection right here like we did before. So we could have age. Look up the mean, that just creates a series. If I run that, there's our age. But if I take that out, instead of selecting it, we can do the whole setup, and it has age and visits. So why doesn't it have priority or animal? Well, those are not integers, so it's really hard. They're non-numerical values. So what is the average? I guess you could do a histogram, which probably we'll look at that later on. But the only two things we can really look at is age and visits, and we have the average or the mean on the age is 3.375, and the mean on visits is 1.9. And let's do df3 visits. We'll go ahead and steal the visits again. And you remember all those different functions we looked at for a series? Well, we can do those here. We can do the sum. So if we run that, we'll see that these sum up to 19. We could also look up minimum. If you remember that from before, the minimum is 1, max. So all that functionality is here. I'll just go back to summing it up and adding it all together. So real quick, we've shown you how to take the series operations and put them into the data frame. And then we can actually, this is an interesting one, We can just do df3 sum, run, and you'll see the different summations on there. It just combines them. I like the way it just combines the strings on there for priority and animal. We've looked at is null. We've also looked at copying, along with the different slices which we talked about earlier. So let's talk about strings. Let's dive into the string setup on there. And let's go ahead and create a string series. String equals PD series. And we just put it right in there. We have A, C, D, AA, BA, CA, popped in a null value, cow and owl. I don't know why they picked cow and owl in the background. Someone must like those animals. And of course we can just do string. If we run that, you'll see, leave the R out, we'll get an error. But if we put it in there, you'll see that we have a simple series. 0A, 1C, 2D, and it automatically indexes it 0 to 8. And then we can go string dot lower. So when we're talking about our data frame, in this case, or our data series string, in this case, we use the string function, str, and we're going to make it lower. And if we go ahead and put the brackets on there, and you'll see that we've gone from capital A, capital C, so on to ABC, and baka, CBA, cow, owl, they were all lowercase already. And of course, if you want to go lower, you can also do upper. And we'll go ahead and run that. And you can see we now have ACD, AAA, baka. Everything's capitalized except for the null value, which is still null. All right, so we looked at a few basic string. You can see that string functions upper and lower. We're going to jump into a very important topic. I'm even going to give it its own header on here because it's such an important topic. What do you do with missing values? Panda has some great tools for that, so we'll dive into those. We'll work with df4, and if you remember the df copy from above, we're just going to make a copy of df3. And let's just take a quick look at the data we're working with. Oops, df3, forgot the 3 on there. There we go. So here we have our cats, snakes, and dogs. Hopefully not all in the same container, because that would be just probably mean to all of them. So we made a copy. We're going to be working with df4. And the reason we made a copy is we want to go ahead and fill the data. And we just simply do fill NA, and then we're going to give it the value we want to put in there. We'll give it the value 4. So I can run in here, and you'll see now that df4 now has where the NA was. It's filled with the value of 4. Same thing down here. A lot of times we'll compute the mean first. So I might do a mean age equals df4, and then we want to go ahead and do age and dot mean, and then I'll do something like this, df4. I only want to select the age, and I want to fill that with the mean age. And I run in there, and you'll see that our df4 age now has the means in there. Just a quick way of showing you how you can combine these. Let me go back to our original one. There we go. And run that. And keeping with good practices, df5 equals df3.copy. And then we'll print our df5, which should be the original one. And then on the df5, we can now drop our missing data. I'm going to simply drop NA, and we're going to use how equals any. So I'm going to drop any row that has missing data in it. And you'll see we had D here with missing data and H. And then let's go ahead and see what df5 looks like when we do that. There we go. And there it is. D is gone, and so is H. So we create a new data frame off of this, missing those values. Now, if you have a lot of data, dropping values is a good way to take care of it because you don't miss some data. If you have not a whole lot of data, you're working with like the iris data set or something like that, or something small, you want to start trying to find a way to fill that data in so you don't lose your computational power of the data you got. So just a quick look at processing null values or missing values. You can fill them, usually with the means. Some people use medium or the mode. There's different ways you can fill it. One way is means. And we can also just drop those rows. Those are the two main things we do with missing data. Here we go. We're going to cover next. I so love data frames for this. File operations. It saved me so much time because they have so many different tools for bringing data in and saving data. So when we're looking at the data frame file operations, it's really streamlined. I don't know how many times I'll go on to different data downloads and they'll have Panda download standard on there just because it's so widely used. So let's start with the most common file, is a CSV. So we have df3 to CSV or animal. And let me just show you the folders going into. Right now I have some untitled, a few things in here, but nothing labeled animal. So we go ahead and run this, and this has now saved the animal to my hard drive. And you can now see the animal folder up here, and if I, let's do edit with a notepad. Oh, let's open it up with just a regular notepad. There we go. Or WordPad. If I open that up, you can see it's comma separated. Our titles, they don't have an index on the categories on the top, and the index, comma, and then all the different data is separated by commas. Standard CSV file on there. And if we're going to send it to CSV, and notice the format is .to_CSV, and it's just the name of the file we're sending it to. You can also put the complete path. By default, it's going to go whatever the active directory this program's running on. That's why those other folders are in there. So we have our df3 to CSV, and then if we're going to put it in there, we want to also get it back out. And we'll call this one df_animal equals pd read_CSV. I always have to remember it's to_CSV and read_CSV. I always want to do like a capital in there and not the underscore. We're going in here again, it's the active directory. So if I now do print out my df animal, and let's just do the head. We only want to look at the first 3 lines. So if I go ahead and run this, we'll see the first 3 lines, and they should match up here what we saved to our CSV. So very easy to save and import from our CSV files on here. And it turns out df3 also has a to Excel. They actually have a lot of different formats, but old school Excel was real popular for so long, still is. We can go ahead and save it as animal.xlsx. We're going to call the sheet named sheet 1. And then I can also do df, we'll call it animal2, and this one's going to come from, and the same format on here. There we go. So we still have our animal xlsx, the sheet 1, that's where it's coming from. Index columns equals none. So we're going to suppress the indexing on the columns. NA values, and it'll just assign it's 0 on up on your indexes. So if it says index columns equals none, that's what it does. And then we've added null values, because there's null values in here. And we want to just make sure that they're marked as NA. And we'll go ahead and just print out the animal2, there we go. And let's run that. Let's make this, let's just do the whole thing. So we'll go ahead and run that. And it probably doesn't help that I completely forgot the read. So animal2 equals pd.read Excel. There we go, Excel. So now we go ahead and run it. And what we expect is happening here. We have the same data frame on here. And if I flick back to my folder, you can now see that we have the animal. One of these is in Excel, and one of these is a CSV on here. And so there's our 2 file types on there. And they have other formats. These are just the 2 most common ones used, and I don't know how many times I've had stuff from Excel I need to pull out. If you've ever played with Excel, it's a nightmare in the back end because of the way they do the indexing. So this just makes it quick and easy to pull in an Excel spreadsheet. So we looked at 2 different ways to bring data in and save it to files. We've looked at all kinds of different ways of manipulating our data set and slicing it and creating it for our data frame. Let's get in there for your visualization. Always the big thing at the end, because 1, it lets you check to see what you did, make sure it looks right. And then also, if you're going to show somebody else, it makes it very clear what's going on if they see something visual. So this is where a really important part of data science is. So let's go ahead and bring in our tools. We're going to do import NumPy as NP. We want to make sure we have our ampersand Matplotlib in line. This just lets Jupyter know that we're going to print it on this page. If you're using a different IDE, you don't really necessarily need that, but this does help it displays correctly in Jupyter Notebook. And if you remember for earlier, we could create a, we're going to call it TS. We're going to create a pandas, which are cute, cuddly creatures, versus a pandem, short for pandemonium? No. So we have TS equals PD series, and we're just going to create a random setup of 50. We'll do an index. We'll set it equal to the pandas date range today. Periods equals 50, so the 50 should match. And I want you to notice something here. I did not import the Matplotlib. Why? Because it's already in there. Pandas already has its built-in connection and interface with Matplotlib, so you don't have to import it. And we'll go ahead and do TS equals TS dot cumulative sum. We're going to do the cumulative sum. So a little reformatting there, and we'll go ahead and plot it. And let's take a look at what that looks like. So we have a nice graph here. We have the dates on the bottom. We've set this up so we have a nice range between, in this case, -4 to, looks like about 2 maybe, or 1, -4 and 1. So what we've done here, we plotted a basic series, just a single row of data, and we've set indexes on there. But we can also do the whole data frame on there, and let's see what that looks like. So first, let's go ahead and create the data frame. We have here random numbers, so we're going to do 50 by 4. And then we'll go ahead and create columns A, B, X, and Y, just because we can. Index is a ts.index on there, so we're going to use the same index as before, just to keep it nice and uniform. We've already generated the dates to go with it. And then we can do, just like we did with the series, we can also do with the data frame, df equals df cumulative sum. So we're going to sum the whole data frame. And then we'll do simply df plot. And let's push that in, and let's go ahead and run this. And look how easy and quick that was to generate a nice graph with all the different data on there. So we have our shared index, we have the shared columns, and then we have the different data from each one that we can easily look at and compare. So very quick way of displaying data. You can imagine if you were working in, I think I mentioned stock earlier because I've been doing some analysis of stock lately. So you'd have your date down here, and then you would have stock A, stock B, stock XY, whatever it is, and you can put them all on one chart and see how what they look like next to each other. And this isn't too far off from what some of those graphs look like, and this is just randomly generated. So stock has a lot of randomness in it, which is one of the reasons I actually play with it for doing some of my models for testing them out. Now, there are a lot of features in Pandas. So we're going to show you one more thing on here. There's some of the things, like I didn't go too deep. We looked at the top two for importing data from a CSV and from an Excel spreadsheet. Showed you how to quickly plot the data. There's more settings in there you can do. We're going to do one more thing down here, and this is kind of a fun one. Change this to a markdown and run that. So how would you remove repeated data using Pandas? And this is where you have a data set that comes in, and maybe it's feeding from one location, and instead of noting that it's repeated the date, like, let's go back to stocks. That's a good visual. We have the stocks from the 23rd, and it adds another row, and it's the same row. It's importing the 23rd again and again. So now you have that data repeated 3 times, and you need to go back and figure out how to get rid of it. How do you track that down? So let's start by creating a quick database, or data frame, not a database. I keep saying database, it's a data frame. And we'll just make this data frame using our dictionary going in. This data frame only has one data series in it, which is fine. So if we do df to print it out, you'll see A, 1, 2, 2, 2, 2, 4, 4, 4, 5, 6, 7, and so on. And so how would you remove that? Well, there is a neat feature in data frames called shift, along with another feature that lets us select just certain information. And we'll go with the location function. Put that in brackets. Remember that from above, location. And then in the location, let me just spread this out a little bit so it's real easy to read. In fact, I'm going to go upscale on that since we're doing a little bit more complicated here. What you can see on the location is I have dfa.shift. So this is going to shift up 1 by default. You can actually change this to 2 or 3. You can even do a -1 and it shifts the other way. But it's going to shift up by 1 by default. And it's going to say if that does not equal df of A, then we want that. And if you look down here, we had 1, 2, 2, 2, 2, 2. When we run this logic on here and we do the shift, it now gets rid of all the duplicates. So we went from 1, 2, 2, 2, 2, 4, 4, 5, whatever it was. Here it is, 1, 2, 2, 2, 4, 4, 4, 5, 5, 5, 6, 6, 6, to 1, 2, 4, 5, 6, 7, 8. And you'll see on the index, it just deletes them out of there so the index stays the same. Obviously, you don't want the dates to change if you're working with an index data setup. So it just deletes those duplicates out of there. This is just a quick way to introduce you to, 1, the fact that you can add logic gates into here. And 2, the iLocation allows you to use shift. So there's the shift function, and then the iLocation selects that based on true or false. Wow, so we've actually covered a lot today in Pandas. We've really covered into the basics of selecting your different series out of your column, out of your data frame, how to index rows, how to slice, how to plot. Hopefully you'll take this beyond that and start combining these different things, and you can create long strings and really explore your data, generate some nice graphs. If you're in Jupyter Notebook, it's a great demo to show others. And I didn't know this about Jupyter Notebook. You can do this in Jupyter Notebook, and then you can download, and I never really looked too closely at all the downloads, but you can download it as an HTML and post it to your blog. So it's got a neat feature in there. But any of this is really powerful tool. All of this is really powerful tools for doing your data science.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Today we're going to study the Matplotlib library and the Python code. So what's in it for you? What is Matplotlib library? Types of plots, plotting graphs and subgraphs, adding a graph inside a graph, graph parameters, title, label, legend, line graphs, line types, color and transparency, canvas, grid and axis range, 2D plots, scatter, step, bar, fill between, radar chart, histogram, contour image, 3D surface image, and then we'll hit a practice example pie chart. So let's start with what is Matplotlib library. Matplotlib library is an open source drawing library which supports rich drawing types. It is used to draw 2D and 3D graphics. And there are so many packages in the Matplotlib library, we're going to cover the basics. And there are so many packages that sit on top of the Matplotlib library that we can't even cover them all today. But we'll hit the main ones so that you have a good understanding of what the Matplotlib library is and what the basics can do. You can understand your data easily by visualizing it with the help of Matplotlib library. You can generate plots, histograms, bar charts, and many other charts with just a few lines of code. And here we have some basic types of plots that you can see here that we'll go into. We have the bar chart, the histogram. Boy, I use a lot of histograms in my stuff. A scatter plot, line chart, pie chart, and area graph. Let's start plotting them. And to do this, I'm going to be using Jupyter Notebook. You can use any of your Python interfaces for programming or scripting and running it. Of course, we here really like the Jupyter Notebook for doing a lot of basic stuff because it's so visual. And in our Jupyter Notebook, which opens up in this case, I'm using Google Chrome, you can go up here to New, and we'll create a new Python 3 and set that up. If you're not familiar with Jupyter Notebook, we do have a tutorial that covers some of the basics of that. And you'll look at any of our tutorials. I usually cover a number of them showing how to set up Jupyter and Anaconda. I myself use Jupyter through Anaconda. In fact, let's go ahead and open that up and just take a look at that, see what that looks like. You can see your Anaconda navigator. If you install it, it will automatically install the Jupyter Notebook. And that also installs a lot of other things. I know some people like the Qt console for doing Python or Spider. I've never used them. I actually use Notepad++ as one of my editors. And then I use the Jupyter Notebook a lot because it's so easy to have a visual while I'm programming. And even simple script in Python, I'll take it from the Jupyter Notebook and then do a save as. You can always go under File, and you can download as a Python program. So that'll download it as an actual Python versus the IPython that this saves it as. So let's go ahead and dive in and see what we got going here. And let's go ahead and put Matplotlib library tutorial. And I'm going to turn this cell into a markdown so it doesn't actually run it. You can see it has a nice little title there. That's all Jupyter Notebook. And then from Matplotlib library, let's import PyLab. Back one. And then let's go ahead and just print. We'll go PyLab and the version. Let's go ahead and run this. So we're going to import our PyLab module from the Matplotlib library. And we find out that we're in version 1.15.1. Always important to note the version you're in. Probably I was reading an article that said the number one thing that Python programmers struggle with is remembering what version they're working in and making sure that they're going from one platform to the other with the same version. And if we're going to graph things, I think we need some data to graph. So we're going to import NumPy as NP. Now, if you're not familiar with NumPy, definitely go back and check out our NumPy tutorial. There's so many different things you can do with it, dealing with reshaping the data and creating the data. We're just going to use it to create some data for us. And there is a lot of ways to create data, but we're going to use the np.linespace. So we're going to create a NumPy array, and the way you read this is we're going to create numbers between 0 and 10, and we're going to create 25 of these numbers. So we're just going to divide that equally up between 0 and 10. And if we have x coordinates, we should probably have some y coordinates. And we'll do something simple like x times x plus 2. And let's just take a look. We're going to print x and print y. Let me go ahead and run this. And let's see what we got going on here. So we have our x coordinates, which is 0, 0.4, 0.83, etc. And you can look at this as an xy plot. So where we have 0, we have 2. Where we have 0.416, we have 2.17. And just as a quick reminder, we're going to do print np array x comma y dot reshape 25 comma 2. And the reason I want to do this is I want to show you something here. A lot of times a program returns x comma y, and it's an array of x comma y, x comma y, x comma y. And so when you're working with the pie plot, you have to separate it out and reshape it. So if I start off with pairs like this, I can reshape them. If I know there's 25 pairs in there, I can switch the 2 and the 25, and this is kind of goofy, but we'll do it anyways. Reshape, so I'm going to reshape my 25 by 2 back to 2 by 25. And if I run that, you'll see I end up with the same output as the XY, the two different arrays in here. And this is important that we want X and Y separate. Again, that's all NumPy stuff, but it's important to understand that this is a format that Matplotlib works with. It works with an array of X's, and they should match your array of Y's. So each one has 25 different entities in it. And then for our basic plotting of this data, it only takes one command to draw a graph of this data. And so we use our, from up here where we imported PyLab, we take our PyLab, and the key under there is plot for plotting a line. And then we want our x coordinates and our y coordinates, and we'll throw in r. And the r simply means red, so we're going to draw the line in red. Let me go ahead and run that. You can actually switch this around if you wanted to do different. There's B for blue. We have a lot of fun. Yellow, hard to see yellow. There we go. But we'll go ahead and stick with red. Run. And when you're doing presentations with these, try to be consistent. You know, if the business and the shareholders send you a spreadsheet and they have losses in red, use red for losses in your graph. Try to be consistent. Use green for profit, for money. You don't have to necessarily use green, but it's whatever they're using, whatever the company's using. Try to mirror that. That way, people aren't going to be confused if you switch your data around and every time one graph has red for loss and one graph has blue for loss. It gets really confusing, so make sure you're consistent in your graphs and your coloring. And something to know, because we're going to cover this in a minute, this is your canvas size. So we have a canvas here, and what we're going to do next is we're going to look at subgraphs. Okay? So let's take our PyLab and create a subplot. And one of the things also to know when we're working with the Matplotlib library, I'm not setting, when I do this, this is my drawing canvas, the PyLab. So once I've imported the PyLab, I'm drawing my images on there. Very important to know. And with the subplot, we're going to give it some different values. And we're going to represent by rows, columns, and indexes. And let's do 1, 2, 1. So it's going to be the first row, second column, and the index is like you can stack your graphs and things like that. We don't worry too much about indexes, but rows and columns. We want to go ahead and use row 1 and column 2. And if we're going to have one object, we should probably have two, but before we do that, we have to plot data onto the subplot. So the order is very important, and we'll go ahead and stick with our x comma y, and let's do this. We're going to add in a third parameter here. Remember we did red? We're going to add shorthand dash dash for dashed lines. So this plots the data into row 1, column 2. And if we're going to do that, let's do another one, pylab.subplot. And if we're going to do row 1, let's do column 2 and index 2. And this time we're going to add G for green, and this denotes a style. And if we're going to set up our PyLab subplot, there we go, PyLab, we got to go ahead and plot that. PyLab plot. And instead of XY, we want Y comma X. Whoops, I messed up. This is in the wrong spot. There we go. We'll move that down here real quick because that goes in the plot part. So the subplot tells it the row, column, and index, and the PyPlot tells it what data. In this case, we switch them, and the color, and then the style shorthand. Now let's go ahead and run that. And you'll see it takes this canvas, splits it in two, and now we have two different graphs. And we have the red one with dashed lines, and we have the green one, which has the little stars going up. And if we take this, and let's just just for fun, let's change this and run that with an index of 1. It puts them both on the same index. It also gives me a warning because it's a strange way of doing two subplots. It's depreciated, there's another way to do it. But most people just ignore that warning because it's not going to go away anytime soon. Now that's using the same setup. What happens if we do, instead of this, let's change the column on here and find out what happens. And if we do the column, it didn't really like that on the setup, it just disappears. So let's keep our column as 2, and let's change the row on the second one to 2, and run that. And you'll see again it kind of squishes everything together and causes some issues. So let's take the index, so they each need a unique index. And you can see here where I made some changes. I said row 2, and look what happens when I change to column 2. So I now have row 2, column 2, index 2. It squished it up here, so you could put another graph underneath is what that does. And there's all kinds of different things. You really have to just play with these numbers till you get a handle on them, because you have to repeat it 164 times according to Cambridge University if it's completely new to you. And you can see right here where, there we go, 3, run. There we go. But you can see it takes a little bit sometimes to play with these and get the numbers right. Oops, I hit the wrong one, that's why. Let's go 3 there, run. There we go. Now it's overlapping, so I have this doubled over here on the right. For now, we'll just go ahead and leave this with the where we have column and row 2 and the 2 different indexes so they appear nice and neatly side by side. And then, as we just saw, as we were flashing through them, we can put them on top of each other. And let me just highlight that and copy it down here. Paste it down there. And here we have 1, 2, 1. And then we'll do 1, 2, 1 also for this one, and that puts the 2 subplots directly on top of each other. It gives us that warning, and you can see we now have 2 different sets of data graphed on top of each other. And you can also see how it did the indexes. Since one of them is from 0 to 10, that's the green one on the x-axis, and the other one is from 0 to 10 on the y-axis. So it took the greatest value of either one and then used those as a shared value. So let's next look at operator description, and we'll go ahead and turn this cell into a markdown and run that so it looks nice. So Fig, and you remember I talked about the canvas earlier. I briefly mentioned it. We're going to look a little bit more at the canvas later on, but that's what the figure is. Fig, we're going to add axes, so we're going to initialize a subplot, add the subplot, in rows, in columns, and all kinds of different things with this that you can do. Let's look at that code and see exactly what's going on. And I want you to notice that there's Fig, which is the actual canvas in the Matplotlib library, and AX is commonly used to refer to the subplots. So when we're creating subplots, you'll see AX equals PLT subplot. Earlier, we did the PyLab. So let's go ahead and import PyPlot from Matplotlib library, and we're going to do it as PLT. You'll see that a lot. That's really the standard in the industry, is to call it PLT, just like Pandas is PD and NumPy array is NP. Certainly you can import it as whatever you want, but I would stick to the standards. And we're going to do the same graph as we did above with the PyLab, but with the PLT. So if it looks familiar, there's a reason we're doing this, because we want to show you how the figure part works and working with the canvas goes. But we're going to do the same plot as we did before. And we'll call it Fig, and we're going to set that equal to plot figure. So there's our figure or our canvas on there. And let's create a variable called axes, and we're going to set that equal to fig.add axes. And in this, we're going to control the left, right, the width, the height of the canvas from 0 to 1. And so we can go ahead and I'm just going to put some stuff in there. I got 0.5, 0.1, 0.8, 0.8. So when you're looking at this is a 0 to 1, or you could say 50%, 10%, 80, 80%. But it's a control. It's going to control your left and your right, along with the width and the height. So the width and the height, we're going to use 80%, and we're going to have like a little indent on the left and the right. And this should look familiar from above, axes.plot, x comma y, and then let's give it a color. How about red? Since we're recreating the same graph, let's keep it uniform. Oops, and it helps if I use AXIS instead of AXES. I don't know where that came from. But this looks identical to the one we had up above. So here's our axes plot, x comma y of red. Same graph, same setup, but this time we've added a variable equal to the figure.addAxes. So our plot figure is our canvas, our axes is what we're working in, and then our axes.plot x comma y. And again, we can draw subgraphs. We put that down here. Just like we did before. And a little different notation here. We're going to have fig, comma, axes equal plt.subplots. And in here it's going to be the number of rows. We're going to do one row, and columns equals 2. So if you remember before, that's what we did. We had one row with 2 different graphs on it. We're going to do the same thing, but note how we did this. Here's our figure, or our canvas, and our axes. We're going to create actually 2 different axes. We're going to create row 1, column 2. And so axes is an array of information. So we can simply do let's do ax in axes. And this will now look familiar. Ax.plot. We're going to do x comma y. We'll go ahead and make it red. Keep everything looking the same. Remember, nice uniform graphs. Everything looks the same. And if we go ahead and run this, you'll see we get 2 nice side-by-side graphs. So just as we had before, the same look, the same setup. And just for fun, let's change in columns to 3. We'll run that. And now you'll see we'll have 3 on there. And let's see if we make it a little bit more interesting. We'll do in rows equals to 2. And you can see down here we're going to get an attribute error because it's trying to scrunch everything together. So it does have a limit how much stuff you can put in one small space. That's important to know. You can fix that by changing the canvas size, which we'll look at in just a minute. And there's other ways to change it on here. But here we go. We can do in rows 2 and columns equals 1. You can see 2 nice images right above each other. We'll go back to the original. 1 row, 2 columns, side by side, left to right. And we can also draw a picture or graph inside another graph. And that's kind of a fun thing to do. It's important to note that we can layer our stuff on top of each other, which makes for a really nice presentation. So let's start by fig. We'll create another figure. So we're going to start over again with our canvas. We set that equal to plt.figure. So there's our new canvas. And let's do axes. We'll call it axes 1 and 2. Axes 1 equals fig.add axes. Remember this from earlier? And this here, similar numbers we used before, saying how big this axis is, this figure in the axes is. So this is going to be the big axes. And let's do axes 2 equals another figure add axes, and then 0.2, 0.5, 0.4, 0.3. And if we're going to do this, they need data on them. So let's go ahead and plot some data on our axes. So axes1.plot. And we'll make this simply x comma y comma, make it red. And then let's go axes2.plot. And let's reverse them. Y comma x comma green. There we go. Doing what I told you not to do. You shouldn't be swapping axes around and plotting your data in 5 different directions because it's confusing. But let's go ahead and run this and see what this looks like. And then let's talk a little bit about this. We talked about the 0.2, 0.5, 0.4, 0.3. And let me just grab the annotation for that. That's left, right, width, and height. So we have in here that this is going to be left, right. So here's our left is 0.1 in, 0.5. And you know what? Let's just play with this a little bit. What happens when I change this to 0.1? Moves it way over to the left. So there's our 0.1. So we can make this 0.4. Run that. There we go. So you can see how you can move it around the branches on here. 0.2. 0.5 is the left, so that's our right. So let's see what happens when we do let's make this 0.1. And that actually is, they had it down as left, right. I thought this was wrong. It's actually how far from the bottom. Let me switch that on here. Bottom. There we go. So we had here on this. We can go ahead and put that back to 0.5 and run that. And this is 0.3. Let's make this 0.3 also. And that is the width. And then, of course, there's the height. We can make that really tiny. Actually, let's do 0.2. And let's run that. And you can see it changes the height on there. We can make it even smaller, 0.2 by 0.2. And as you can see, you can get stuck playing with this to make it look just right. It can sometimes take a little bit. Certainly, once you have the settings, if you're doing a presentation, you try to keep it uniform, unless it doesn't make sense for the graph you're working on. Try to keep the same colors, the same position, and the same look and feel. And I mentioned earlier we can adjust the canvas size. So this is from earlier. I just copied it down below. We're going to replot the same data we've been looking at. And what we can do is we can change the figure size to 16 by 9. And let me run that and show you what that looks like. So it fills the whole screen. And then if you are, normally when you're working on the screen, you don't worry too much about this. But we can set the DPI to 300. Run that. There it goes. This is your dots per inch. And if you are doing an output of this and you're printing a hard copy, you want the higher quality. I would suggest nothing under 300 if it's a professional print. You might get a little less than that, but whenever I'm doing professional graphics and printing them out on something, 300 dots per inch is kind of the minimal on there. You can go a lot higher too, but keep in mind the higher you get, the more memory it takes and the more lag time and the more resources you use. So usually 300 is a good solid number to use in your dots per inch. And you can see it draws a nice large canvas here, which is 16 by 9, and then the DPI is 300 on here, so it's a little higher quality. And just out of curiosity, I wonder how long it takes to draw something double that size, 600. And you can see here where at 600 DPI, it's going to take a while. There it goes, just because it's utilizing a lot more graphics on there. And let me just go back to the 300. Now let's do a 100. You're not going to see a difference on this because it is web-based graphics are pretty low. And up here you saw I did this with the plot figure. This works the same if I do figure axes subplot, figure size, and then we'll go ahead and do axes plot x comma y comma, we'll stick to red. Let's go ahead and run this. And you should get almost the same thing here. Here's our axes on the subplot on here with the fixed size and the DPI. Let me take this all out. Let me just remove all that real quick. Run it again. There we go. Now we're back to our original figure. And let's look at some of the other things you can do with this. One of the things we can do is we can set a title for the axes. So axes set title. You'll see right here, since I put this on the axes, it's the main title for the whole graph. And if you're going to have a title, you should also label. So we can label our X label, and we can set our Y label. In this case, we're just going to call it X and Y. Keep it nice and uniform, and if we run this, you'll see that we've added a nice X label and Y label. Whoops, where'd they go? And it turns out in this environment that you have to put it before the title. So let me go ahead and put it before the title. And there's our X, Y, and let me run that. And of course, we can also do up our size a little bit so you can see what's going on a little better. So here we have X label X. If you come down here, you'll see our X label and our Y label. We can, of course, change this to X label. You can change this to Y. It can be whatever you want on here, of course. And our title graph. There we go. Run. So here we have our title graph, our Y label, and our X label all set up on our nice little plot. And then before we move on to the next section, let's do one more thing on here. We have a thing called the legend. And we're going to set our AX legend, label 1, label 2 up here. That's the format for it, but let's go down here and actually use it. I'm going to do two different plots. We're going to have axes plot x by x times x squared and x cubed. And if I run this, you'll see it puts two nice graphs on the setup on there. But it's nice to have a legend telling you what's going on. So for the legend, we can actually do axes, since we have the two plots, legend. And on here, we've created an array, and we have y equals x squared, y equals x cubed. You can actually put this as whatever you want. Those are just strings. And then location 2. And let's go ahead and run this and see what that looks like. And you can see it puts a nice legend on the upper left-hand corner. Location 2. We can do location 3. And run it, and it drops it down to the bottom. Location 1, I can't remember where that's at. There we go, upper right. So each one of these is a number that refers to the different locations on the screen. 0, kind of have to play with them or look them up to remember where they're at, but they do work. It just kind of moves around depending on where you want your legend at on there. So on this section we cover the title of the graph, the Y labels, and legends. We're getting into starting to look really fancy here. So we now have something we can actually put out. You'll see the title of the graph looks a little fuzzy. So I might, in a web setup, put the DPI up a couple notches. Maybe put it at 200, 100 might work fine. Just so, that's something to notice on here when you're playing with these different things. We had our subplots DPI equals, let's do 200 and just see what that looks like. So you can see it now is a lot clearer. It's also larger, so it's a nice little feature you can throw in there with your DPI dots per inch. So the next section is let's look at some graph features. We're going to look at line color, transparency, size, and a few more things on here. And, oops, I forgot the main title. So we have our figure and our axes equals our plot and subplots. And I'm going to go ahead and do a DPI equals 150 so the graph comes out nice and large and easy for you to see. And let's go ahead and do 3 plots on here. We'll do x by x plus 1, so it's just going to be a straight line. Plot x plus 2, and axes.plot x plus 3. This looks like we're doing nearest neighbor setup, or showing how it located data and putting your lines on there between the nearest neighbors. There we go. So it draws a nice little graph with 3 lines on it. One of the things we can do is we can control the alpha on this. Oops, and you can actually see the when they did these lines, it automatically pulls in different colors for your setup. So there's some automatic things going on in there. And a lot of times we do that comma R, where we're going to do color equals red, another notation on here. Let's go ahead and run this. Now we have a bright red line down there. And with the Matplotlib library, you're not limited to red. You can also use one of the many different color references, as you see here, with the # 1155DD, which is just blue. And we can do the same thing with another color on here, which turns out to be green. And I can just as easily do this. Green, blue, oops, there we go, blue, and run that. And you'll see here we have red, blue, and green. And what I want to do is I want to make this, we're going to set what's called the alpha on this. And we're going to set this equal to 0.5. So this is halfway see-through when I run this. And it's almost going to look pink because you can see through it. And let's change this just a little bit, just to make this kind of fun. Let's square it. There we go, run it. So now we have this nice square that comes up. And you can see when it crosses it, because I plotted these 2 lines after it and they have no alpha, the red is behind those lines, or in this case pink, because we did the alpha halfway through. So let's go ahead and do this. Alpha equals 0.5. And, oh, you know what? Instead of squaring it, let's take it to the 0.5 power. That'll be kind of interesting to see what that does. We'll just go to keep it squared. There we go. And run that. And let's go back and look at this where it crosses over. And the first thing you'll see right here is on the blue, it's kind of light blue now. You can see how the 2 colors add together. You get almost a purple on there. So I can clearly see where the red crosses the blue line. And then the green just blanks it over because I didn't do any opaqueness, no alpha on there. So this is great if you have lots of data that crosses over and you need to be able to track those lines better. And we'll go ahead and do this 0.5, and we'll run that. Oops, I did equals 0.5. Let me go ahead and run that. And so you can see right here, now you can easily see the red line, how it crosses the green and the blue down here. And if we want to, we can do this as the default is 1, is solid, so we can change this all to 0.8. Let me just do that. Oops, 58.8. There we go. Run. Oops, I must have hit a wrong button there. Let me try that again. I accidentally got rid of a bracket. And let's go ahead and run that. And we come down here and look at this. You can still see where it passes behind them, but the green dominates and the blue dominates because we're now at 80% instead of 50%. And you can do less. That's kind of fun, although at some point the lanes kind of fade. So 0.5 is usually the best setting on there. We have a nice pastel here at 0.3, and you can easily see where they cross over. And just like you can play with the colors, we can play with line width. And let's try DPI 100 and see what that looks like on my screen. Equals 100. And we'll go ahead and just take our AX plot. Let's do 4 of these lines just so you can see how they look next to each other. Real quick here. There we go. And if I run this, they should all appear the same. It automatically does different colors on there. So let's do color equals blue. Forgot my quotation marks. There we go. And we'll go ahead and just make these all blue, just for purposes of being nice and uniform. And then what I want to do is I want to do the line width. Line width equals 0.25. And let's just copy and paste that down here. Let's do equals 1. About 1.5. And let's do just make this equal to 2. Let's see what that looks like. And when we do that, you can see it goes from a very thin line, a 0.5, a 1, our 1.5, and 2, which is twice the width of the 1. And if we're going to do different sizes, we had different colors, we had our alpha scheme. Let's take this whole thing here. Let's paste it down here and do another one. But instead of line width, let's look at styles. And something to note here, you can actually abbreviate this with LW. So line width can also be let's just do everything 0.2. And let's set up a line style. We'll do the first one dashes, and let me just paste that down here so I'm not doing a lot of extra typing. There we go. Take this out. So we have our dashed, We can do a dash dot. Oops, let's do the dash dot here. And a colon here. There we go. And there's a lot of different options. We'll look at a few more as we go down for different ways of highlighting data. But when you look at this, we have everything as a line width of 2, and now we have a straight line, we have a dash line, or a dot dash, and a dot 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 line. And then another thing we can add on here is we're going to do, here's our ax plot, and we did x, let's do x plus 4, so it goes right on the top. I'm going to do color black, line width 1.5, so it's a smaller line. And we're going to take the line and we're going to set dashes. So look how I've changed some of the notation here for my line and my ax plot. So I can set my line comma equal to ax plot, and then I can change the line settings this way. And when I run this, let me run that on here, you'll see the 5, 10, 15, 10 creates a series of dashes that are varied in length. In this case, they alternate between a short dash and a long dash. And we can play with these numbers. Curiosity always has me what happens when you play with the numbers. Just to see what they look like, let's do this. Let's paste this down here. I'll do 2 of these just because they're kind of fun to play with. And let's change this from 10 to 3. And we're going to change this one from 15 to 4. And let's run that. And you can see the differences in the lines. Oops, a little bit confusing on there because I forgot to change the lines are all on top of each other. So let me change that really quick here. And let's run that. And now you can see here's our original dash line alternating. When I change these numbers on the second one, the very end value to 3, you can see now we have dashes of 5. Let's see, I'm going to guess this is a dashes of 5, skip 10, dashes of 15, skip 3, and then it goes back to the beginning. Dashes, 5 dashes, skip 10, 15 dashes, skip 3. And of course the last one we just switched up a little bit. It looks a lot more uniform because I'm using 2 sets of 10. Or if I did something like this and changed it to 30, it really becomes pronounced as far as the distances between them. And instead of 4, let's go, let's put 30 here also. 30 by 30, there we go. Really pronounced on that one. And let's look at one more important group for plotting our data. And in this, here's our plot we started with the x plus 1, x plus 2, x plus 3, and did it in blue on this one, 3 or 4 different blue lines. And this property, we want to add the actual plots, so you can see where the plots are on the graph. And for that, we might have marker equals O. And if we run this, you'll see it puts a dot for each of these, and there's 25 dots because we have 25 x values. So we actually have 0, and each of the different values of x, y are then plotted here with the dots. And we don't want to just limit ourselves to dots. We can also do plus sign, that's another option. Dots is most common. I actually like the dots the best. If we do the plus sign, you can see it puts a nice crosshairs or plus sign on there. And we can do a marker. There's a number of different markers you can use. And I think this one was it. S is another one, which is a nice square. And that's actually a good one, S for square. O for period. Okay, that's just kind of weird. So you can see that probably on these markers, another one is number 1. So if we run that, you'll see we now have these little hatch marks. And let's just go with the O on this one. By the way, this works with square really nicely. Some of the stuff we're going to do here in just a second. Let's do marker size equals 2. And change that to 5 and run that. And you can see here it puts a nice little tiny dot versus this size dot here. And this is interesting because it said 2. I thought it would be bigger. But if you do 0.5, it gets even smaller. And let's just do 10 to see what that looks like. Run. That looks huge. So marker size, a lot of these are dependent on the DPI and the setups. There's things that switch around as far as the way the size shows up. You got to be a little careful when you change one setting, it can change all the other markers. And then let's take our square on here, and we had marker size, so we also have marker face. We'll set that equal to red. Of course, I may change so it's up 1 notch. We'll run that. Whoops, must have mistyped something on here. And I did, it's marker face color equals red. And so when I run that, you can now see I have the squares on there with the marker face color. Of course, we can mix and match these. Come down here and we'll make this, let's make this plus 7. And we'll make this size 15. Marker face color equals, and we'll do green, just because. There we go, run. Very hard to actually see what's going on there. Still 25 dots. They kind of overlap. As you can see, they print them over each other. And of course, if we really wanted to make it look horrible, we could just make that really huge. Generally, though, you'd want something a little bit smaller and cuter. We'll just try doing it this way. There we go. That's too small to even see the face. So 4. You can start to see the face on there around 4. And maybe on 8. 8 might be a good number for this. There we go, 8. Again, that all just depends on what you're trying to show and display. So we've covered a lot of stuff here as far as our lines. We've covered opaque with our alpha setting on there. Give us some nice pastels. You can see how they overlap and how they cross over. We covered the line width, different size on there, different formats for the line itself. And these are all, you can combine all these. So you can have our line width equals 2, line style equals dash. You can bring this down here also to the markers. And then we added markers in, just standard circle, a plus sign, the square, a little tick, which uses a 1. Then we add a marker size and a marker color face, and we combine those. You see we get a nice different series of representations. We also briefly mentioned color, where you didn't have to use, like in here we used color black. Someplace up here, I'd have to find it, we use the actual number for the color, as opposed to, I changed them to red and blue. So you can get very precise on the color if you have a very specific color set that you need to match your website or whatever you're working on. All of those are tools in the Matplotlib library. So we have one more piece to formatting the graph, so we want to show you, and then we have 2 big sections. We're going to go over the different graphs that they have along with a challenge problem. So let's go to the last section we're going to look at is limits. We're going to limit our data. So this first part I'm just going to paste in there. We're going to create our subplots 1, 2. So 1 row, 2 columns. We're going to do a figure size of 10, 5. This should all look familiar now since we've done a number of them. And we're going to go ahead and plot, and this is an interesting notation you should notice here. Our axes 0, so 1 we've used, instead of, you can just iterate through them, but they're just an array, so it's an array of 0 is still the axes of the first axes out of 2. And we're going to plot x squared, x cubed, line width 2. So we're going to go ahead and just plot 2 graphs right on top of each other without doing multiple plots on here. And we'll set the grid equal to true on here. Let's go ahead and run that. And you can see here are 2 plots with the x value going across. And I'm going to do something similar. And by the way, you can just, if you look at it, you can see the grid on there. That's all that is. Easier to spot the data going across. We're going to take the same data for axis 1. So we have our plot of x squared, x and x cubed, line width 2. And this time we're going to take our axis 1 and do y limit. It's actually set underscore y limit. This is the y-axis, so it's going to be an array of two values. And we'll do 0, 60. I'm just making these numbers up. The guys in the back actually made them up. I'm just using their numbers. And we're going to set the x limit, and we'll set the x limit as, don't forget our brackets there, 2, 5. So it's the same data going in, but we're setting a limit on it. And let's go ahead and run that. And let's see what it comes out of. And here we have the y limit 0 to 60. So we're looking at just the lower part of this curve here up to here. And we have the x limit 2 to 5. So that starts right here at 2, and you can see very different graphs. This is kind of nice because you could actually put one of these on top of the other if you wanted to draw focus to one part of a graph. Remember how we did that earlier, one inside the other? But just a quick note, you can easily limit your graph and kind of reshape the way it looks quite easily. And we can also add that grid down there if you want a grid. We'll run that and add the grid in there. Oops, I guess you have to do the grid beforehand. Switch that. There we go. Sometimes the order on this is really important, so you may double check your order when you're printing these things out. It also helps if I change it to 1. So in this case, it might not be the order. I wonder if we'll go back here as 1. There we go. So it doesn't matter the order on grid. But you can set the grid for easy viewing here. Nice setup on there. But you can see how we can limit the data. So let's start looking at some other 2D graphs and make this cell a markdown. So when we run it, it has a nice pretty title to it. And let's go ahead and create some data with an NP array. We'll do 0 to 5 on here. There we go. And let's look at 4 common graphs. We'll put them side by side. So we'll do a figure. Our axes equals plot, subplots, 1, 4 columns, and then figure size. Hopefully it'll fit nicely on here. It seems to do pretty good on here. And I'll go ahead and just run that since we're in there. Run. You'll see I have 4 blank plots on here. And we'll start with axes of 0. Let's set title. And we want this to be a scatter plot. A scatter plot just means it has a bunch of dots on it. So here's our axes of 0 dot scatter. Easy to remember. Scatter a bunch of plots on there. We'll do our N, or we can do X or N. There we go. And let's go ahead and do axes set title scatter. Oh, already did that. We're just going to do scatter. That's how you do it on there. That is how you create a scatter plot, simply with the scatter control. And we'll do, let's do the variable X plus, let's throw some randomness in here. Usually scatter plots have a lot of random numbers connected to them. That's why they do them on there. And so the bigger the X gets, the bigger the randomness, so 0.25 times the randomness. And what we should end up down here is with the scatter plot. And you can see as you go up, it just kind of has some random numbers and moves up and down the line. But plots just the points. So if you remember from back up here where we did marker, this is plotting basically just the marker. So it's a scatter plot. Probably less used is a step plot. So for axes 1, we'll go ahead and do a step plot so you can see what that looks like. And this time I'll use our n value instead of x. We generated that n value up here. And so for this we have n times 2, our n squared, n times 2, n squared. Line width equals 2, and if we run that, it creates a nice step up. Let's see, so we've got a scatter plot, we've got a steps plot. Let's do a bar plot. And we'll use the same formula, n squared, alignment centered, because you can have them to the left or right, width 0.5, and alpha, if you remember correctly, that's how opaque it is. Let's see what that looks like on there. So we have some nice, you can see here a nice bar plot. It should look very similar to the step plot, but colored in. And we can change the width. Let's see what happens if we do 0.9, run. And if we take width out completely, run that, you can see it starts coming together on there. And we can change the alpha. We can take the alpha out too and run that. So now you have the solid colors. And if we take out the center and run that, everything, you really can't see the shift on here because that's actually the default on this. But these are common settings for the bar graph. Let me just put them back in there. There we go. Alignment, center, and alpha. Now, I can't say I've used the step graph very much. There's certain, I guess, domains of expertise that require a step graph. But the scatter plot and the bar graph, very common, especially the bar graph. And we'll look at histograms here in just a minute. So I use histograms a lot, especially in data science. But this is nice if you have very concrete objects. How many people are wearing yellow hats? That kind of thing. But if we're going to do that, let's go ahead and do the last one, which I see a lot more in the sciences. I'm certainly using the data science, but more like for mapping. I saw a publication on solar flares, and they were discussing the energy. And so filling in the graph gives it a very different look. So we're going to do the fill between. And it's just like you think it'd be. It's fill between, but with a underscore between them. And we'll do x and x squared and x cubed. And we'll do color green and alpha again, in case you had other data you wanted to plot on there. You can see it forms a nice squared coming up here. And also, if you look at the bottom one is your squared value, the upper line is your cubed value, and then it fills in everything in between. If you remember from calculus, this would be if you had like a motor and efficiency, they would talk about the efficiency going up and the loss, and you're looking for the space or the area between the two lines. So it gives you a nice visual of that. And let's look at a few more basic two-dimensionals. So we're going to have our figure size on here. We're going to do a radar chart. To be honest, I've never used a radar chart in business or in data science. I have to find a reason to use one now. So the first line for doing a radar chart, we have to add axes and the figure. And with this actually creates our, let's run it so you can see what it creates. It creates a nice, looks like you're on a submarine and you're tracking the hunt for red October or something like that. And it needs all of these. The polar is the fact that we're doing polar coordinates. 0, 0, 0.6 has to do with the size. If you take out any of these things and run them, you get just a box. If you take out the other half, you pretty much get nothing in there. And if you change these numbers, change them a little bit, you can see it gets bigger. They had 0.6 on here. I'll go ahead and leave it as 1 because that's just kind of fun. That's all about the size on here, the height and the width. And then let's create some data. T equals NP line space, and this is 0 to 2 times NP times pi. So if you remember, that is the distance across, and we're going to generate 100 points. So this is just a thing of data we're putting together. Then we can simply do an ax.plot, and in this case let's do t comma t, which would be a diagonal line on a regular chart, and we'll give it a nice color equals blue, and line width equals 3. Let's see what that looks like. And we can see here a spiral coming out. And remember, this would be just a diagonal line on a regular chart. What happens if we take this and instead of t times 0.5, there we go. And you can see it slightly alters the way it spirals out. We could do t times 2. Spirals out a little quicker. So it's kind of just a fun. Like I said, I've never used a radar chart. It's a column. But you can always think of radar in a submarine. Kind of looks like one of those, or in an airplane. And none of this would be complete if we didn't discuss histograms. Oh my gosh, do I use a histogram so much. And we'll use our NumPy that we have set as NP to generate, it looks like we have 100,000 variables we're going to set equal to n. And of course we create our figure and our axes. Subplots 1, 2, figure size 12, 14. So we're going to look at 2 different variations of the histogram. And we'll set a title, default histogram, set our title there. And then this is simply hist for histogram, and we'll just go ahead and put in our n in there, and let me run this and see what that looks like. And let's talk about what is going on here. So we generated an array here of data, 1,000 random arrays. It looks like they're mostly between -4 and 4, and then it adds up each one. It says 0, you have 35,000 that are 0, so that's what's most common on here. And we have 20,000 that are somewhere in this range right here between the -2 and, well, it looks like 1 and -2. And somewhere between 0 and 1, there's 30,000 numbers. So all this is saying is this is how common these variables are. And this will point you in so many directions when you're looking at data science to go ahead and run your histogram. So you should always have your histogram, and you can always put limits and all the other different things on your array, just like you did on the other graphs on there. And then we're going to do a cumulative detailed histogram. And all it is a histogram. Let me just do that. And we set cumulative equal to true, and bins equal 50. And I really want to highlight the cumulative equals true is important, but we can now choose how many bins we have. In the first one, it kind of selected them for us. In this case, let me go ahead and run this, and you'll see it prints the data out for us. And here's our, whoops, must have missed, oh, there we go. It doesn't help that I put it over the old one. There we go, okay. So now you have your default histogram, and then we have a cumulative histogram, and we should have 50 steps in there. And let's just find out if that's true, not so much by counting them. I'm not going to count them. If you want to, you can count them. Let's just change it to 10 and see what happens. And we see here we have now 10 counts of that. And we could set that for 5 and run that. And then we have our 5 on there. And we go ahead and take the cumulative equals true out, just so you can see what that looks like. And let me run that on here too. That looks just like it did before. I think there's 1, 2, 3, 4, 5, 6, 7, 8. They have 8 different bins on here. Is what the default came out of. Put that back in there. Run. And so now it should look almost identical, and it does. And then we can put the cumulative back in, see what that looks like with the cumulative. And run that. And we can see how that shifts everything over and has a slightly different look. Wait, it shifts it all to the right? No, it doesn't actually shift it to the right. It's cumulative, so it's the total of the different occurrences. And so what that means is, like, if you consider this like for the year of rainfall, we have like day 1, you had a little bit of rain. Day 2, we have more rain. And so if you look at the number, this is 100,000, 35,000. So it's a cumulative detailed histogram of the occurrence as it grows. And rainfall is a good one, because that would be a cumulative histogram of how much rain occurred throughout the year. And we're going to look at 2 more graphs. We've already looked at a bunch of them. We looked at our radar graph. We've looked at scatter, step, bar, fill in, basic plots. We've looked at different ways of showing the data. We can increase the size of the line, the look, the color, the alpha setting. So let's look at contour maps. Just put that in there. There we go. Draw a contour map. And before we draw a contour map, we need to go ahead and create data for it. And if you have contours, your data is all going to have 3 different values. So let's go ahead and create the data here. We have our, you'd import your Matplot library, your NumPy, so we have our numbers array. And we'll import matplot.cm, and that's your color maps. So you have all these different color maps you can look at. There's like hundreds of color maps. So if you don't want to do your own color, you can even do your own color map. They're pretty diverse. And of course our PLT, our PyPlot. And to generate our different data, we're going to create a delta 0.025. And we'll start with X, and we're going to create an array between -3 and 3 in delta increments of 0.025. And we'll have our Y, we'll do something similar, and then we'll create our XY into a mesh grid. Again, these are all NumPy commands, so if you're not familiar with these, you'll want to go back and review our NumPy tutorial. And we'll do an exponential on here, -x² minus y squared for our Z1. We'll do a Z2, so we have two different areas, and Z equals Z of 1 minus Z2 times 2. So we've created a number of values here. And let me go ahead and run this, and let's plug that in so you can see where those values are going. So once we've set these, we're going to create our figure and our X from our PLT subplots. We're going to create the variable CS, and this is going to be our contour. So right here, CS is our contour surface, and we're feeding it X, Y, and Z. And if you remember, X, Y we created as our X and Y components using our mesh grid. And you know what? Let's do this just because it's kind of good to see this. Let's go ahead and print X, and let's print Y. And I always like to do this when I'm working with something that's either is really complicated, in this case is what we're looking at, or you don't understand yet. So we've created a mesh grid. We have X, Y, and when we're done with this, we end up with, here's our X, and this set of values, and our Y. So these are X and Y coordinates. And then we've also created Z based on our X and Y. So we have X, capital Y, and capital Z as our three components. X and Y being the coordinates, while Z is going to be our actual height, since we're doing a contour map. So we created our contour map from our X, Y, and Z coordinates. We want to go ahead and put in a C label. Maybe we want to go ahead and do a title on here. We'll put that in our set title, and this is a contour. There we go, contour map. And let's go ahead and run this and see what that looks like. And you'll see we generated a nice little contour map. There's different settings you can play with on this, but you can picture this being you're on a mountain climb, and here we have a line that represents 0, maybe that's sea level. And then moving on up, you have your contours of 0.5 and then -1 and different setups, little hills. I guess if it's minus, that's like a pit. So I guess you're going down into a pit at -5 and -1. But on the other side, you can see you're going up in levels. So here's a mountaintop, and here's like a basin of some kind. And in data science, this could represent a lot of things. This could also be representing two different values and maybe profits and loss. I don't know if I'd ever really do that as a contour map, but I'm sure you can be creative and find something fun to do with a contour map. And then we're going to look at one last map, which is the 3D map. And those can be really important as a final product because they can show so much additional information that you can't fit on two-dimensional graphs. There we go. Draw a 3D image. And so we're going to import from our MPL toolkits the mplot 3D and the axes 3D. We're going to import axes 3D. This is what's going to let us work with the 3D image. And this should look familiar. We're going to create another figure just like we did before. Figure size 14 by 6. That's a good fit on the screen. We'll go ahead and run that. So we have our figure, and let's go ahead and take our X, and we're going to set that equal to fig.add subplot. That should also be familiar from earlier. And we're going to work with, this sets the settings for the projection. And we're going to use 1, 2, 1 projection 3D. And we'll see what that looks like in just a minute. And we just created some three-dimensional data here before, where we had X, Y, and Z, capital X, Y, and Z. So we're going to reuse that data. We're just going to use that since this is also a three-dimensional image. So let's use that for a three-dimensional graph. And we simply do AX plot underscore surface, and our capital X, capital Y, capital Z. So there's our data coming in. And we're going to add some settings in here. We're going to do R stride 4, C stride 4, and line width 0. And I'll show you what that is here in just a minute. Let's go ahead and run that so we can see our graph. And of course it helps if I don't add an extra comma in there. And you can see it generates this really beautiful three-dimensional graph. So let's take a little bit time to explore some of these numbers we have going in here. We have the R stride 4, the C stride 4. And the projection 3D. Projection 3D is the important one because that's telling us that this is a 3D graph here. So what are these first numbers? 1, 2, 1. Let's just change one of these. I'm going to change this to 5. And it's going to give me an error. Let's change it to 1. And oops, that didn't work. Let's change this middle one to 3 instead. And you're going to see how it starts reshaping the size and how it fits on the screen. And we'll change the first one to 2. We'll run that one. And again, it's changed the dimensions and the size and how it fits on here. Play with these numbers till you get a nice look and feel for it. Part of it is the tilt and the angle. I'll do 7 on this one. There we go. You can see it really shifted it there. But again, that changes the size and how it fits on the canvas. But we'll leave it at the 1, 2. And just so you get a good look at what we're talking about here, this is column width and index from before. If we do 1, 1, 1, you can see that it now spreads it out all the way across. It uses the whole setup on there. So this has to do with the size and how big you want it to be. Now, there's one term that we didn't cover in this yet, but we've used it throughout the whole setup. And I'm just going to type that down here, even though we're not going to go into detail. And that's the term heat map. You might see that is kind of starting to lose ground as far as a common reference, but there sure are a lot of people who still talk about heat maps. What is a heat map? Well, it is simply a color map. That's all it is. So if you ever see the term heat map, that refers to the fact this is in different colors representing different heights. That one isn't a heat map, but you can see up here we switched into, let me go back up here, here we go. This one has different colors for the different values. A lot of times you'll use, like instead of X and Y, you might do a heat map where you have a fourth value, and the fourth value represents the color. And so you'll see this 3D image in a nice colors represented by a heat map. That's all it is. So if you see the term heat map, that only means we're plotting some of the data in color to make it stand out or to give it a fourth dimension in this case. So we've covered a lot of things on Matplot, and that brings us, covered all the basics, so that brings us to practice example. And this is going to be the challenge for you. And let me go ahead and change our cell type markdown and run that so it looks pretty. Practice example, write a Python program to create a pie chart of the popularity of programming languages. Okay, excellent. And if you're going to have a challenge, we need some data. And I'll just throw in import our Matplot library at the beginning. You should do that automatically. And so for our data to plot, we're going to have our languages. We're going to have Python, we're going to have Java, PHP, JavaScript, C#, C++. So those are 6 categories. And then we have our popularity. Oops, misspelling there. Popularity. We'll give the first one 22.2%, Java 17.6%. And I don't know if these are real numbers they pulled. My guess is that they might have just been made up because I don't know if Python's really that much more popular than the other ones. Maybe specific to data science, because Python's very popular in data science right now because it has so many options. The only other program that's highly used and exclusively for data science is R. So Python's big, and Python also does a lot more. It's a full programming language, where R is primarily for data science. They didn't even put R in here. So we have Python, we have Java, we have our PHP, and you can see the different values they've given it or different percentages. And I did add these up. It does not add up to 100%. It adds up to 71% or something like that. And then we're going to give colors. And we've chosen, these guys in the back brought in these colors. I'm not sure what these colors are. We'll find out in a minute, so it'll be exciting. But you can see they're using the actual color values you can pull off of a color wheel or something like that. You could have just as easily done blue, red, green if you're too lazy to pick the exact colors. And then let's go ahead and solve this and see what we got here. We're going to do something a little fancy just because we can. The first thing we're going to do is we're going to use a variable called explode. And you'll notice that there's 6 variables in here, so that matches our 6 different categories. And the first one we've done is 0.1 and then 0, 0, 0, 0, 0. 0.1, when we put this in here under the explode in the plot, it will actually push that square out. So it's a really cool feature to highlight certain information on a pie chart. And this is simply plt.py. And we're plotting popularity. There we go. And before we add in all the really cool settings for this, let's go ahead and run it. And you'll see we generate a nice flat pie. Not too exciting there. And then we'll go ahead and put in all the extras. I talked about explode, where we can explode one of the values out. So here's our explode equals explode. Labels is languages, because we want to know what the different colors mean. Here's our colors equals colors, our auto picture. And this is standard print format. So that's a Python setup on there. And that's just going to put the value on the pie slice. And then we're going to add shadow, because it just looks cooler with a shadow, gives it a little 3D look. And we'll do a start angle of 140. Let's go ahead and run this and take a look and see what comes out of that. And look how that changes the whole setup. So here's our labels. There's our value we put on there. There's our slice that's pushed out. There's our shadow, a 3D effect. And then we started at 140. We could also rotate this. Let's just do this angle 90. And if we run it, you'll see the blue pie slices moved up a little bit. We could actually let's just take the whole starting triangle out and run. It'll default to 0. And this is what it looks like if it defaulted to 0. So depending on where you want the highlighted slice to appear, usually you want that to appear on the left because people read left to right. And so it draws a focus onto, in this case, Python and how great Python is. I'm a little biased. We're teaching a Python tutorial, so it should be understandable that we're looking at Python. And one last reference before we close. You can go over to the Matplotlib.pyplot setup, and if you go underneath the different functions on there, you can look this up on their website. You'll see a full list, and this is why it's so important to go through a tutorial like this, because this list is just so massive. I'm trying to figure out, like, here's our bar plot. There's a bar H. You can add barbs. There's a box plot we didn't cover. C labels, a totally different kind of, for your contour plot you can set up in there. If you go down here, we have our figures we used on there. We showed you the basics of how to do the figure. You'll see some closer references on those. There's a histogram down here, HIST. There's also the hist2d, makes a 2D histogram plot. H-lines, all of this, these are all the different commands that are underneath of here. And you can see it's pretty extensive. We've covered all the basic ones so that you now have a solid ground to look at these different options. So when you come to these functions, some of them are going to look a little off, or not off, will look unfamiliar, but you'll still have the availability to probably understand most of this and have a basic understanding of your Matplotlib library.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Let's go ahead and open up another Python 3 setup in here. And so we want to explore what happens when you want to display this. This is where it starts getting, in my opinion, a little fun because you're actually playing with it and you have something to show people. And we'll go ahead and rename this. We're going to call this Pandas and PyPlot. So Pandas PyPlot, just so I can remember for next time. And we want to go ahead and import the necessary libraries. We're going to import Pandas as PD. Now remember, this is a data frame, so we're talking rows and columns, and you'll see how Pandas work so nicely when you're actually showing data to people. And then we're going to have NumPy in the background. NumPy works with Pandas, so a lot of times you just import them by default. Seaborn sits on top of the Matplot library. So sometimes we use the Seaborn because it kind of extends. It's one of the 100 packages that extends the Matplot library. Probably the most common used because it has a lot of built-in functionality. Almost by default, I usually just put Seaborn in there in case I need it. And of course we have Matplot library as PyPlot, as PLT. And note we have as PD, as NP, as SNS, as PLT. Those are pretty standard. So when you're doing your imports, I would probably keep those just so other people can read your code and it makes sense to them. That's pretty much a standard nowadays. And then we have the strange line here. It says ampersand Matplot library inline. That is for Jupyter Notebook only. So if you're running this in a different package, it'll have a pop-up when it goes to display the Matplot library. You can, with the most current version of Jupyter, usually leave that out and it will still display it right on the page as we go. And we'll see what that looks like. And then we're going to go ahead and just do the Seaborn, the SNS.set, and we're going to set the color codes equals true. Let them just keep the default one so we don't have to think about it too much. And we of course have to run this. The reason we run this is because these values are all set. If we don't run this and I access one of these afterward, it'll crash. The cool thing about Jupyter Notebooks is if you forgot to import one of these, you forgot to install it, because you do have to install this under your Anaconda setup or whatever setup you're in, you can flip over to Anaconda and run your install for these. And then just come back and run it. You don't have to close anything out. And we'll go ahead and paste this one in here real quick, where we have car equals pd.read_CSV. And then we have the actual path. This path, of course, will vary depending on what you are working with. So it's wherever you save the file at. And you can see here I have like my OneDrive documents, Simplilearn, Python, data analytics, using Python, / car CSV. It's quite a long file. When we open that up, what we get is we get a CSV file, and we have the make, the model, the year, the engine, fuel type, engine horsepower, cylinders, and so on. And this is just a comma separated file. So each row is like a row of data. Think of it as a spreadsheet. And then each one is a column of data on here. And as you can see right here, it has the make, model. So it has columns for a header on here. Now, your Pandas just does an excellent job of automatically pulling a lot of this in. So when you start seeing the Pandas on here, you realize that you are already like halfway done with getting your data in. I just love Pandas for that reason. NumPy also has it. You can load a CSV directly into NumPy, but we're working with Pandas, and this is where it really gets cool, is I can come down here and I can print, you remember our print statement, we can actually get rid of it. And we're just going to do car head, because it's going to print that out. The head is going to print the top values of that data file we just ran in. And so you can see right here, it does a nice printout. It's all nice and inline because we're in Jupyter Notebook. I can scroll back and forth and look at the different data. And just like we expected, we have our column, and it brought the header right in. One thing to note is the index. It automatically created an index 0, 1, 2, 3, 4, and so on. And we're just looking at the head. So we got 0, 1, 2, 3, 4. You can change this. You might want to just look at the top two. We can run that. There's our top two BMWs. Another thing we can do is instead of head, we can do tail. And look at the last three values that are in that data file. And you can see right here, it numbered them all the way up to 11,913. Oh my goodness, they put a lot of data in this file. I didn't even look to see how big the file was. So you can really easily get through and view the different data in here. When you're talking about big data, you almost never just print out car. In fact, let's see what happens when we do. If we run this and we just run the car, it's huge. In fact, it's so big that the Pandas automatically truncates it and just does head plus tail, so you can see the two. So we really don't want to look at the whole thing. We'll go and go back to, let's stick with the head, displaying our data. There we go. So there's the head of our data. It gives us a quick look to see what's actually in there. I can zoom out if we want, so you can actually get a better view. Although we'll keep it zoomed in so you can see the code I'm working on. And then from the data standpoint, we of course want to look at data types. What's going on with our data? What does it look like? Now this, you show when you're talking to your shareholders, they like to see these nice, easy to read charts. They look like a spreadsheet. So it's a nice way of displaying pieces of the chart. When we talk about the data types, now we're getting into the data science side of it. What are we working with? Well, we have make, model, we have an integer 64 for the year. Engine fuel type is an object. If we go up here, you can see that most of them are it's a set manual, rear wheel drive. So they might be very limited number of types in there. And so forth. And it's either going to be a float 64, an integer, or an object is the way it's going to read it on here. And the next thing you're going to know is like your columns. And since it loaded the columns automatically, we have here the make, the model, the year, the engine, the size, all the way up to the MSRP. And just out of something you'll see come up a lot is whenever you're in Pandas and you type in .values, it converts it from a Pandas list to a NumPy array. And that's true of any of these. So then you end up in a NumPy array. So you'll see a little switch in there in the way that the data is actually stored. And that's true of any of these. In this case, we want car.columns. You have a total list of your car columns. And like any good data scientist, we want to start looking at analytical summary of the data set. What's going on with our data? So we can start trying to piecemeal it together. So we can do car, describe, and then what we'll do include equals all. So a nice Panda command is to describe your data. If you're working with R, this should start looking familiar. And we come down here and you can see count. There's the make, the model, the year, how many of each one, how many unique values of each one, the top value of each one, what's most common, the frequency, the mean. Clearly on some of these it's an object, so it really can't tell you what the average is. It'd just be the top one's the average, I guess. The year, what's the average year on there? All this stuff comes down here. Your standard deviation, your minimum value, your maximum value, what's in the lower quarter, 50% mark, where's that line at, and what's in the upper 75%, the top 25% going into the max. Now, this next part is just cool. This is what we always wanted computers to be back like in the 90s, instead of 5,000 lines of code to do this. Maybe not 5,000. All right, I built my own plot library back in 95, and the amount of code for doing a simple plot was, I don't know, probably about 100 lines of code. This is being done in one line of code. We have our car, which is our pandas. We generated that. It's our data frame. And we have .hist for histogram. That is the power of Seaborn. Now, it's still going to generate a NumPy graph, but Seaborn sits on top, and then we can do the figure size. This is just so it fits nicely on the paper on here. And we do something simple like this, and you can see here where it comes up, and it does say Matplotlib and does subplots and everything. But we're looking at a histogram of all the different pieces in our database. And we have our engine cylinders. That's always a good one because you can see like they have some that they had a null on there, so they came out as 0. Maybe one of them had a 2-cylinder engine way back when. 4 is a common, 6 a little less common, and then you see the 8-cylinder, 12-cylinder engines. Boy, that's got to be a speedster or something. But you can see right here, it just breaks it down. So now you have how many cars with how many, whatever it is, cylinders, horsepower, and so on. And it does a nice job displaying it. You can see if you're working with your, you're going into your demo, it's really nice just to be able to type that in and boom, there it is. It can see it all the way across. And we might want to zero in and use like a box plot. And this time we'll go ahead and call the Seaborn, SNS, box plot. And we're going to go ahead and do vehicle size versus engine horsepower XY plot. And the data comes from the car. So if we run this, we end up with a nice box plot. You see our mid-size, compact, and large. You can see the variation. There's our outlier showing up there on the compact. That must be a high-end sports car. Large car might have a couple engines, and again we have all these outliers and then your deviation on them. Very powerful and quick way to zero in on one small piece of data and display it for people who need to have it reduced to something they can see and look at and understand. And that's our Seaborn box plot, or our SNS.boxplot. And then if we're going to back out and we want a quick look at what they call pair plotting, we can run that, and you can see with the Seaborn it just does all the work for you. It takes it just a moment for it to pull the data in and compile it. And once it does, it creates a nice grid. And this grid, if you look at this one space here, which is, you might not be able to see the small number, it says engine horsepower. This is engine horsepower to the year it was built, and it's just flipped. So everything to the right of the middle diagonal is just the rotation of what's on the left. And as you expect, the engine horsepower gets bigger and bigger and bigger as time goes on. So the year it was built, the further up in the year, the more likely you are to have a heavy horsepower engine. And you can quickly look at trends with our pair plot coming up. And look how fast that was. It took it a couple, moment to process. But right away, I get a nice view of all these different information, which I can look at visually and kind of see how things group and look. Now, if I was doing a meeting, I probably wouldn't show all the data. One of the things I've learned over the years is people, myself included, love to show all our work. We were taught in school, show all your work, prove what you know. The CEO doesn't want to see a huge grid of graphs, I guarantee it. So what we want to do is we want to go ahead and drop the stuff that might not be interested in. And I'm not really a car person. Our guy in the back is, obviously. So you have your engine fuel type. We're going to drop that. We're going to drop market category, vehicle style, popularity, number of doors, vehicle size. And we have the axes in here. If you remember from NumPy, we have to include that axes to make it clear what we're working on. That's also true with Pandas. And then we'll look at just what it looks like from the head. And you can see that we dropped out those categories, and now we have the make, model, year, and so forth. And we took out the engine fuel type, market category, etc. And this should look familiar to you now. When you start working with Pandas, I just love Pandas for this reason. Look how easy it is. It just displays it as a nice spreadsheet for you. You can just look at it and view it very easily. It's also the same kind of view you're going to get if you're working in Spark or PySpark, which is Python for Spark across big data. This is the kind of thing that they come up with, and this is why Pandas is so powerful. And we may look at this and decide we don't like these columns. And so you can go in here and we can actually rename the columns. Simple command, car equals car, rename. Columns equals engine horsepower equals horsepower. This is just your standard Python dictionary. So it just maps them out. And instead of having like the lengthy, if here we had engine horsepower, we just want horsepower. We don't need to know it's the engine horsepower. Engine cylinders, we don't need to know that it's for the engine, because there's only one thing we're describing if we're talking about cars, and that's cylinders. And we'll go ahead and just run this. And again, here's our car head, and you can see how that changed. We have model year and horsepower versus model year, engine horsepower, engine cylinders, and just cylinders. Again, we want to keep reducing this so it's more and more readable. The more readable you get it, the better. And of course, we can also adjust the size a little bit, so that when it prints out, instead of splitting it on two lines, we get like a single line. We can do that also. That's just your control mouse up or plus sign you use in Chrome. That's a Chrome command. And if you remember from NumPy, we had shape. Well, Pandas works the same way. We can look at the shape of the data. So we now have 11,914 rows and 10 columns. So you see some similarities because Pandas is built on NumPy. And questions that come up just like you did in NumPy, we might want to know duplicate rows. And so we can do car. And look at this switch here. We're doing a selection. This is a Pandas selection with the brackets. But we want to select it based on car.duplicated. So how many duplicates on there. So it's starting to look a little bit different as far as how we access some of the data on here. This can be a logical statement. And we get the number of duplicate rows. We have 989 rows by 10 columns again. And this is one of those troubleshooting things that we end up doing a lot, more than we really feel like we should. We might go ahead and do like a car count just to see how many rows we're dealing with. And then right after that, we might want to go ahead and say, hey, let's drop duplicates. So remember we did all the duplicates on there. So car equals car.drop duplicates. And then we can print the head again. We'll just do car head here. And you can see the data on there looks the same as before. And just note that we did car equals car.drop duplicates. There are commands in here where you can do, where it changes the actual value. And it works on some of them and not on others depending on what you're doing. But by default, it always returns a copy. So when we do this, we're reassigning it to car. And you can see it's the same header, but we want to go ahead and do count. and see how the count changes. Let's go ahead and run this. And you can see here, instead of 11,914, we have 10,925. So we removed about 100 cars that were duplicated, just slightly under 100 there. And then as we're prepping our data, we might want to know car is null. So it's going to count the values of null, and then we want to sum that up. And when we do that, we do the car is null function.sum. We end up with HP, the horsepower is 69 have null values, and 30 have cylinders have null values. Now, if you don't put the sum at the end, it's just going to return a mask with the true false of is it null or is it not, by 0 and 1. So you're summing up the ones underneath each column. And this, of course, then you have to decide what you're going to do with the null values. There's a lot of different options. It might be that you need to put in the average or means. Maybe you want to put in the median value. There's a lot of different ways to fill it. Usually when you first start out with the data, a lot of them you just drop your null values. And you can see here car.drop NA, which is equal to all. And then we're going to go ahead and count it. And you can see that we've dropped almost another 100 values. So from 10,925 to 10,827, maybe 75 or so values. So we cleaned this is really a big part of cleaning data. You need to know how to get rid of your null values, or at least count them, and what to do with them. And of course, if we go back to counting our null values, we should now have null values. There we go. And you'll see there's 0 null values. I don't know how many times I've been running a model that doesn't take null values and it crashes, and I just sit there and look at it trying to get, why did that crash? It should have worked. It's because I forgot to remove the null values. So we've been jumping around a lot. We're going to go back to finding outliers, and let's go ahead and bring that back into our Seaborn. And if you remember, we did a box plot earlier. This time we're going to do a box plot just on the price. And you can see here our price value, and we have the deviation with the 2 thinner bars on each side of the main value. And then as we get up here, we have all these outliers. In fact, we have one way out here that's probably a really expensive high-end car is what we're looking at. If you were doing fraud analysis, you would be jumping on all over these outliers. Why are these deviation from the standard? What are these people doing? Again, this is probably, like I said, a really high-end expensive car out here. That's what we're looking at. And we can also look at the box plot for the horsepower. And we'll put that in down here and run that. And you can see again, here's our horsepower, and it just jumps. And there's these really odd, huge muscle cars out here that are outliers. And we're going to jump into making this a little bit more, as you start displaying your data or your information to your shareholders. We're going to look at plotting a histogram for the number of cars per brand. And the first thing we want to go ahead and do is we have with our car, go back over here, here we go. We have our make value counts, largest plot, and we want to do a kind equals bar, figure size 10.5. And right off the bat, we jump up here and we see Chevrolet, it's going against, what was it? It's figure resizing, the value counts, and we want the largest value. So here's our value counts and compared to what the different cars are. Chevrolet puts out a lot of different kinds of cars. I didn't realize that they made that many cars or different types. And then for readability, let's go ahead and add a title, number of cars by make, number of cars, and make. If you had looked at this the first time, you would have been like, well, what the heck am I looking at? Well, we're looking at the number of cars by make. And then you can see here, now we're talking about the type of cars and the different ones were put out. Lotus, I guess, only had a few different kinds of cars over there. Very high-end cars. And then as doing data analytics and as a data scientist, one of the things I am most interested in is the relationship between the variables. So this is always a place to start. We want to know what's going on with our variables and how they connect with each other. So the first thing we're going to do is we're going to go ahead and set a figure size because we want to make sure it fits our graph. We'll just go ahead and set this one plot figure set to figure size 2010. If you never used the Matplotlib library, which is sitting behind Seaborn, whatever is in the PLT, this is what's loaded. It's like a canvas you're painting on. So the second you load that PyPlot as PLT, anything you do to that is affecting everything on it. And then we want to go ahead, since we're using Seaborn, we'll go ahead and create a variable C for relationships or correspondence, and car.corr. That's a correlation in Seaborn on top of Pandas. Again, one line and you get the whole correlation on there. And because we're working with Seaborn, let's put it into a nice heat map. If you're not familiar with heat maps, that means we're just using color as part of our setup. So we have a nice visual. And we can see here that the Seaborn connected to the Pandas prints out a nice chart. We'll talk a little bit about the color here in a second. It prints out a nice chart. This is a chart I look at. As a data scientist, these are the numbers I want to look at. And we'll just highlight one of them. Here's cylinders versus horsepower. The closer to 1, the higher the correlation. So 0.788. Pretty high correlation between the number of cylinders and how heavy the horsepower is. I'm betting if you looked at the year versus horsepower, we can just look at that one. Here's year and horsepower. 0.314, not as so much, but if you combine them, you don't actually add them. But if you combine them, you'll start to see an increase in horsepower per year and cylinders. You could probably get a correlation there. And just like 0.78 is a positive correlation, you might notice if we look at cylinders, or let's look at horsepower and mileage. So if we go here to horsepower to mileage, you get a nice negative. We'll do cylinders, that's a bigger number. With cylinders to the miles per gallon, it's a minus 0.6. So it's a negative correlation. The closer to -1, the more the negative correlation is. And then the chart you would actually show people is a nice heat map. This is all our colors, and it's just those numbers put into a heat map. The darker the color, the higher the correlation. You can see straight down the middle, obviously the year correlates directly with the year, horsepower with horsepower, and so on. That's why it's a 1. The closer to the 1, the higher the correlation between the two pieces of data. Now, this is a good introduction. Pandas goes way beyond this. Most of the functionality in NumPy, since Pandas sits on it, is also in Pandas, and then it even has additional features in it. And we use Seaborn pretty extensively sitting on top over our PyPlot. So keep in mind that our PyPlot has a ton of other features in it that we didn't even touch on in here. We couldn't, even if you had a sole course in it, there's just so many things hidden in there depending on what your domain you're working on. But you can see here, here's our Seaborn and here's our Matplotlib library. That's all our graphics that we did. And then the Seaborn worked really nicely with the Pandas. We really like that.
In this video, we are going to perform a really interesting data analysis using Python on the Spotify music streaming service platform dataset. I'll also be asking you a few questions related to Spotify during our discussion. Please make sure to answer them in the comment section of the video. So now let's get started. Spotify is a Swedish audio streaming and media services provider founded in April 2006. It is the world's largest music streaming service provider and has over 381 million monthly active users, which also includes 172 million paid subscribers. The total number of downloads on the Spotify app in the Android store exceeded 1 billion in May 2021. So millions of people listen to music all day. Even I am hooked to music. As an analyst, what's better than exploring and quantifying data about music and drawing valuable insights? Before I move ahead, I have a quiz question for you people. The name Spotify comes from a combination of two words. So which are those two words? Please let us know your thoughts in the comment section below. I would like to repeat the question again. The name Spotify comes from a combination of two words. So what are those two words? We would love to hear from you. So please put your answers in the comment section below. Now, let's use Python libraries and functions to analyze and visualize our dataset. First, I'll show you the two datasets that we'll be using. So here is the first dataset that we'll be using for our demo. And then I have my second dataset called Spotify features, which is essentially about the genres of the different soundtracks. Now these datasets have been downloaded from kaggle.com. Now the links to the datasets have been provided in the description box. Please go ahead and download them. Now let me just go ahead and brief you about the columns that are present in our first dataset, which is about tracks. We have our column A, which is ID. This is the unique ID for each of the songs. Then we have the name column, which is essentially the name of the song. Then we have a column for popularity. So the popularity ranges from 0 to 100. Then we have duration in milliseconds. This is the duration of the track in milliseconds. Next, we have a column called explicit. Now we are not bothered about this column because we are not going to use it in our analysis. Then we have artist. So the name of the artist who has composed or sung the song. Then we have ID of the artist. Then we have a column for release date, which is basically the date on which the song was released. Then we have a column for danceability. So this describes how suitable a track is for dancing based on a combination of musical elements such as tempo, rhythm stability, beat, strength, and overall regularity. The value ranges between 0 and 1. Next, we have a column for energy. So the energy is a measure between 0.0 to 1.0 and represents a perceptual measure of intensity and activity. Typically, the energetic tracks feel fast, loud, and noisy. Higher the value, the more energetic is the song. Then we have a column for key. So key is the pitch, notes or scale of song that forms the basis of a song. There are 12 keys ranging from 0 to 11. Moving ahead, we have loudness. So the overall loudness of the track in decibels, it ranges from -60 to 0 decibels. Then we have mode. So songs can be classified as major and minor. 1.0 represents major or 1 represents major and 0 represents minor. Next, we have speechiness. So speechiness recognizes the presence of spoken words in a track. More exclusive speech like the recording, example talk show, audiobook, or poetry, the closer to 1.0 the attribute value. Then we have a column for acousticness. So a confidence measure of 0 to 1 of whether the track is acoustic or not. So 1.0 represents high confidence the track is acoustic. Then we have other information about instrumentalness. Then we also have a column for liveness. So liveness detects the presence of an audience in the recording. Then we have a column for valence. So valence is a measure between 0.0 to 1.0 and describes the musical positiveness conveyed by a track or a song. And finally, we have the columns for tempo and time signature. Now, even in the second dataset, we have almost the same columns, just that we have an additional column that is about the genre of the songs present in the dataset. Cool. Now let's head over to our Jupyter notebook and we'll start with our analysis. Okay, so one more thing to remember. Our data has information from 1922 onwards. So all the songs from 1922 till 2021. Cool. Okay, so I'm on my Jupyter notebook. So you can see I have a few cells that have already been filled up. So we'll start with our analysis. First of all, let's go ahead and import the necessary libraries. So I'm importing NumPy, Pandas, Matplotlib, and Seaborn for my analysis and visualization. I'll hit Shift Enter to import the libraries. Alright. And in the next cell, I'm going to load my dataset using the Pandas read_csv function. I have my location already put here. Let me show you the location where the data files or the data sets are located. So this is my location under Chrome downloads. I have a folder called Spotify datasets. Okay, so let's import and check the first 5 rows in the dataset. So for that I've used the head function. There you go. So here you can see I have my first 5 rows of information from the dataset, and on the top you can see the different columns. You have ID, name, popularity, artist, then we have the release date, danceability, energy, key, loudness, liveliness or liveness, balance, tempo, and other information. Cool. Now let's check for null values in the dataset. I'll just give a comment as null values. Every time when you download a dataset from an open repository, there are chances that the dataset would contain null values, so it's better to check them beforehand. So I'm going to use the isNull function present in the Pandas library. PD I'm using because I had imported Pandas as PD. So pd.isNull. Then I'm going to use the variable name df_tracks because I imported my dataset and stored it in the variable df_tracks. So I have my data frame under df_tracks variable, and then I'll use the sum function to check the total number of null values present in the dataset for each of the columns. If I run it, there you go. So here you can see my name column has 71 missing values or null values, and we don't have any null values for the rest of the columns. Okay. Now let's use the info method that will give us the total number of rows and columns in the dataset, and we'll also check the data types and the memory usage. So I'll say my data frame name, that is df_tracks.info. If I run it, you can see here. Now if you mark, there are total 5,86,601 names or the names of the songs present in the dataset, while the rest all have 5,86,672. So clearly there are total 71 song names or soundtracks missing from our dataset. And below you can see the data types. We have float, integer, and object, and then you can see the memory usage. Cool. Now before I move ahead with our next analysis, I have another question for you. Which artist or musician has the most number of followers on Spotify? I repeat, which artist or musician has the most number of followers on Spotify? Please put your answers in the comment section below. We would be happy to hear from you. Now let's move ahead and do our first major analysis in this demo. We are going to find the 10 least popular songs present in the Spotify dataset. So I'll create a variable called sorted_df that will be equal to my data frame name, that is df_tracks dot. I'm going to use the sort_values function and say my column name is popularity. So I'm going to sort the values based on the popularity and then say ascending equal to true, since I want only the least popular songs. And then I'm going to say head of 10, which means I want the top 10 least popular songs. Now let's go ahead and print sorted_df. If I run it, you can see we have the list of 10 least popular songs on Spotify. You can see that popularity is 0, and you can see the names of the songs. Some of them are songs which are not in English language, and you can see the artist names as well. Cool. Now moving ahead, let's see some descriptive statistics for the numerical variables that are present in our column. So I'll say df_tracks dot describe, which is the function to get some descriptive statistics, and I'm going to use the transpose function after that. If I run it, there you go. So we have the statistics about count, mean, standard deviation, minimum value, 25th percentile, 50th percentile, 75th percentile, and the maximum value for these columns like popularity, duration in milliseconds. Then we have energy, key, loudness, mode. Cool. Now if you see this popularity column, the minimum value is 0 and the maximum value is 100, and you can see the 50th percentile is 27, which is essentially the median. You have the standard deviation as 18.37. Then similarly you can check for the other features as well. Cool. Now we'll see the 10 most popular songs which are greater than 90. So we are going to check for the top 10 songs with popularity greater than 90. Let me show you how to do it. So in this cell, I am going to create a new variable called most popular, and I'll say df underscore tracks dot. This time I'm going to use the query function that is part of Pandas library again. I'll use the column that is popularity, and we'll set the condition popularity should be greater than 90. I'll give a comma and say in place equal to false, because I don't want to change my original data frame. And then I'll say sort underscore values, and I'm going to sort it based on popularity in descending order. So I'll say ascending equal to false, and then let's take only the top 10 popular songs. So I'll say most popular, use square brackets, and we'll then pass the slicing operator and say :10. Now if I run this, there you go. So here you can see the 10 most popular songs that is present in our Spotify dataset. So first we have Peaches by Justin Bieber, Daniel Caesar and Gibbon. Then we also have a song name called Driver's License, Astronaut in the Ocean, Save Your Tears. We also have The Business, Streets and Heartbreak Anniversary. So these are the most popular songs that are present in our dataset based on their popularity. You can see Peaches has the highest popularity with 100. Alright, now moving to the next cell. So here we are going to set the index to be release date column in the main data frame. So I am setting my index using the set underscore index function. I have passed in my column name as release date, and I'm saying in place equal to true, which means I want to change it in my original data frame. And then I'm changing the value to date time format, and let's print the head of the dataset. So you can see here we have successfully changed our index. Now here you can see instead of 0, 1, 2, 3 we have the release date column, and the rest of the columns are intact. Cool. Now let's move ahead. So suppose you want to check the artist at the 18th row in our dataset. You can use the index location method for that. Let me show you how to filter only specific rows of information from the dataset. I'll use my data frame df underscore tracks, and using double square brackets I'll say my column name, which is artist, and I'll use the index location method and say, let's say I want to check the artist who is present in the 18th row in my dataset. So I'll use iloc18. If I run it, the artist's name is Victor Boucher. Cool. Now let's move ahead. We are going to convert the duration in milliseconds to just seconds. So if you see our dataset, we have a column called duration in milliseconds. So all our songs are present in milliseconds. Let's convert them into just seconds. So for that I'm using the lambda function and dividing the values in milliseconds by 1000 so that they get converted into just seconds. I have used in place equal to true, so I want to change it in my original data frame. Let's run it and do the necessary changes. Alright, now we'll print the head of the dataset just to check the duration column. So I'll say df underscore tracks dot duration dot head. If I run it, there you go. So you can see the values have now been changed to just seconds. Cool. I have the final quiz question for you. Who has the most monthly listeners on Spotify? Please put your answers in the comment section below. We'd be glad to hear from you. Now coming to the next cell. So here we are going to create our first visualization that is going to be a correlation map. We are going to drop 3 unwanted columns, and those are key, mode and explicit, and then we are going to apply Pearson correlation method. Now I have set my figure size to 14,6, and then we are using the Seaborn heat map function to create our correlation map. I have put the variable that is correlation underscore df. You can see above we had created this, and then I'm setting annotation equal to true. So this will write the data value in each cell. I have set fmt equal to .1g. So this is a string formatting code to use when adding annotations. Then I have set my vmin and vmax. So these are the values to anchor the color map. Otherwise they are inferred from the data and other keyword arguments. CMap here stands for color map. You can just search for SNS CMap. You will get the documentation. So you can choose whichever color palette or the color map you want. Here I have used Inferno, and I have set my line widths and line color. Finally I am giving a title to my correlation map, and I have set the Xtick labels. Let's go ahead and run this to get our first visualization. If I scroll down, there you go. We have got a nice correlation map. So here on the right side you can see the scale. It ranges from -1 to +1. -1 means the variables have least or negative correlation, while the values which are above 0.0 means that the variables have a positive correlation. Now here you can see there are values like -0.7 for energy and acousticness, which means if the energy is high, the acousticness is really low. Again, for loudness and say speechiness, if the song is loud, the speechiness is low, so there is negative correlation. But if you see for energy and loudness, there is really high correlation between these two variables. You can see the value is 0.8. So if the song is loud, this implies the song has really high energy, and vice versa. Now if you see for a few other variables, there is negative correlation between acousticness and danceability. There is negative correlation again between valence and acousticness. Similarly, there is positive correlation between energy and valence, which is 0.4, and even for danceability and valence, there is positive correlation, which is 0.5. Cool. So from the correlation heat map, you can note that acousticness appears to have a strong negative correlation with energy. So if you see for acousticness and energy, there is a strong negative correlation, and there is a moderately strong positive relation between loudness and popularity. So if you see for popularity and loudness, the color is orange, which means it lies in this positive region. And there is also a moderately strong positive relation between danceability and valence. So if you check for danceability and valence here, there is a moderately strong positive correlation. Alright, now let's move ahead. We are going to sample our data and take just 0.4% of the total data, and we'll create 2 regression plots using this data. So let me first sample my data. So I'll create a sample data frame using my original data frame, which is df underscore tracks, and say sample, I'm going to use the int function and say 0.004 multiplied by the length of my original data frame, which is df underscore tracks. Alright, now let's run this and we'll print the length of my sample data frame. If I run it, you can see 0.4% of my total data set is 2346 rows. Cool. Now we are going to create a regression plot between loudness and energy. Now in our correlation map, we saw there was a positive correlation between loudness and energy, which was 0.8. Let's plot it in the form of a regression line. So I'll use plt.figure. I'll set my figure size equal to, let's say, 10,6. I'll say SNS dot regression plot. So I'm using the function called regplot, and I'll use my data as sample underscore df, give a comma, and say in my y-axis I'll have my column loudness, and in the x-axis we'll have energy. I'll give a color to my data variable. Let's say the color is C. Then I'll set my title to loudness versus energy. Let's say correlation. Alright. Let's make sure everything is fine. Now we'll run and see our result. There you go. So you can see here clearly there is a very high positive correlation between loudness and energy. On the y-axis we have loudness, and on the x-axis we have energy, and you can see all the data points or the songs are in one direction. So if the energy increases, the loudness of the song also increases, and similarly if the loudness of the song decreases, your energy of the song or the track also decreases. So there is a very high positive correlation, and you can see the regression line here. It has gone and is increasing gradually. Cool. Now similarly, I'll just copy this code, and we are going to see another regression plot, this time for two different features. Let's say we have popularity in the y-axis. So I'll say popularity, and then in the x-axis we have, let's say, acousticness. I'll change the color to, let's say, B, which stands for blue, and will set the title to popularity versus, I'll have acousticness correlation. Just scroll down and we'll run it to see the result. There you go. So I have the different points for the songs, and here you can see the regression line is downwards, which means if the acousticness of the song increases, the popularity decreases, and similarly if the popularity increases, acousticness decreases. You can see the downward trend of the regression line. Alright. Now in the next cell, we are going to create a new column called year from our release date column. And I have changed this to date time format. Let me just run it. Cool. Now after that, we are going to create a distribution plot to visualize the total number of songs in each year since 1922 that is available on the Spotify streaming app. So I have used my Seaborn library and dist plot function. Now one thing to remember, you need to update your Seaborn library to this version if you haven't done it. So use this command pip install --user Seaborn and the version. So here in the distribution plot, we are going to plot a histogram. So I have used kind equal to hist, which stands for histogram. Let's run and see the result. Okay, so here you can see I have my distribution plot. So the plot tells us that the number of songs for each year in the dataset according to their release date have increased in the recent years since music became more accessible to people globally with technological advancements. So earlier you can see there were very few songs available in the 1920s. Later on the number of songs increased rapidly, and now you can see we have a lot more songs available for people to listen. Cool. Now we are going to see the duration of songs over the years. For that, again, we are going to create a bar plot. So I'll first create a variable called total duration equal to df underscore tracks dot, I'll use the duration column that we created with seconds, and then I'm going to set my figure dimensions. So I'll use figure underscore dims for dimensions equal to 18,7. After that, I'll have my figure axis defined. So I'll use the Matplotlib subplots function, and I'll set the figure size equal to my figure dimensions, and then I'll say figure equal to sns dot, I'll use the bar plot function and say my x-axis to be years, my y-axis will be total duration or total underscore dr that we created here. I'll set my axis equal to ax, and then I'll set error width equal to false. Let's set the title for my plot as title equal to year versus duration, and finally I'll say plt dot xtix, I'll rotate it by, let's say, 90 degrees. Alright, let me just recheck once if everything is fine, and then we'll go ahead and run it. My axis, error width, title. Okay, let me just run it. We'll see the result in a moment. If I scroll down, you can see we have the bar plot for the different years and the duration of the songs in seconds in the y-axis. So earlier in the 1920s, you can see the duration of the songs were less, and later it increased around late 1930s, and this remained consistent until 2010, where the duration was high. but after 2010 you can see the duration of the songs have started decreasing. Now in the next cell, I'm going to create a line plot to analyze the average duration of the songs over the years. It is going to be similar to our bar plot, just that now we are going to visualize it in terms of a line. So I have my code ready. You can see here I've used my Seaborn library and the line plot function. In the x-axis I have years and in the y-axis I have total duration. I've set my title to year versus duration and I'm rotating my x labels by 60 degrees. Let's run it and we'll see the output. There you go. Now if I scroll down, you can see we have a nice line plot, and on the x-axis you have the years and on the y-axis we have the duration. You can see that the songs from 1920s to 1960s have comparatively shorter duration, since most of the songs tended to be more singing based rather than instrument based. After 1960s, you can see the duration of the songs started increasing until I would say 2010, and in the present day the duration of the songs have started declining, since the attention span of the average listener is also declining. Alright, now let's move to our second data analysis project, which is based on genres of the songs. So I am importing my dataset using the Pandas read_csv function. I have given my location and here I have my dataset name followed by the extension of the type. So this is a CSV dataset. Let's go ahead and run it. Okay, now let's print the first 5 rows of the dataset. I have stored my dataset in a data frame called df_genre. I'll use the head function to get the first 5 rows of information. I'll hit shift enter to run it. There you go. You can see here I have my genre column, artist name, track ID, popularity, acousticness, duration in milliseconds again, and we have the rest of the other columns that we saw in our first dataset. Just one thing to note, here key is present in terms of C, D, E, C minor, F minor, and not in terms of numbers between 0 to 11. Now we'll see the duration of the songs for different genres. For that I'm going to create a bar plot. So I'll start with setting the title for my plot as duration of the songs in different genres. I'll use the Seaborn library and I'll set my color palette to, let's say, rocket. I'll give a comma and say as CMap equal to true. This would be color palette. Now I'll say SNS dot bar plot. In the y-axis I'll have genre and in the x-axis I'll have my duration column, which is in milliseconds, so duration underscore ms, and then I pass my data frame using the data argument. So I'll say data equal to df dot genre. Next we'll set the x labels, so I'll say plt dot x label. Let's say my x label is duration in milliseconds, and then I'll say plt dot ylabel as genres. Now let's go ahead and run this. There you go. So here you can see we have the different genres on the y-axis, and on the x-axis you have the duration in milliseconds. And if you see the graph for classical genre and for songs that belong to world genre, the duration of the songs are more compared to other genres. Now if you check for children's music genre, the duration is less or the least. Cool. And finally we'll move to our last demo where we'll see the top 5 genres by popularity. So I'll say sns dot set underscore style. I'll set my style to dark grid, which will be my background, and then I'll say plt dot figure. I'll set my figure size to 10,5. Then I'll create a variable called famous, since I want to take only the most popular songs based on the genre. So I have created a variable called famous, and I'll pass my data frame name, that is df underscore genre, and I'll sort the values based on my popularity column. So I'll say popularity, and I want to sort it in descending order. So I'll say ascending equal to false, and I'll take the first 10 values. I'll tell you the reason why I'm taking the first 10 values and not 5. Then I'll say sns dot bar plot, and in the y-axis I'll have genre, in the x-axis we'll have popularity, and I'll give a comma, and using the data argument I'll say my data to be famous, which is this variable that we created, and then I'll set my title as top 5 genres by popularity. Alright, now the reason why I took head of 10 is because there are a few genres which are repetitive. So if you see this, we have children's music appearing twice, so hence we have taken 10 instead of 5. Let me just go ahead and run it. There you go. So here if I scroll down, you can see I have my top 5 genres based on the popularity. So we have dance, pop, rap, hip hop and reggaeton. So these are the 5 genres which are most popular based on the data that we have collected from Spotify. Alright.
Welcome to this really interesting video on data analysis of the 2021 World Happiness Report using Python. So today we will perform some exploratory data analysis using Python libraries to analyze, visualize and draw insights from 2021 World Happiness data. Before I begin, make sure to subscribe to the Simplilearn channel and hit the bell icon to never miss an update. First, let's understand what the World Happiness Report 2021 is all about. The International Happiness Day is celebrated every year since 2013 on 20th of March to emphasize the importance of happiness in the daily lives of people. So the United Nations Sustainable Development Solutions Network published the World Happiness Report on 19th of March 2021 that ranks the world's 149 countries on how happy the citizens perceive themselves to be based on various indicators. The happiness study ranks the countries on the basis of questions from the Gallup World Poll. The results are then equated with other factors such as GDP, life expectancy, generosity, etc. This year it focused on the effects of the COVID-19 pandemic and how people all over the world have managed to survive and prosper. So using this 2021 data, we will answer critical questions such as the top 10 most corrupt countries. We will plot a graph to understand how the happiness score is related to the freedom of making life choices. We'll look at the life expectancy of 10 happiest and 10 least happy nations. So these are a few examples, but we will explore more about the data in detail in our demo session. Let's get started. So first I'll show you the data set we'll be using in this demo. So this data has been collected from Kaggle. Let me show you that. So this is the CSV dataset that we have downloaded from Kaggle.com. So you can see here World Happiness Report 2021, and we will share the dataset link in the description of the video. You can click on the link to download the dataset. Now we have information about 149 countries. You can see it here. Count is 149. Let me go to the top and I'll run through the columns that are there in this dataset. So the first column is the country name. So we have 149 different countries, and then we have something called as regional indicator. We can call this as just the region. So you can see we have different regions. I've applied a filter. We have Central and Eastern Europe. Then we have Commonwealth of Independent States. So these include countries such as Russia. Then we have East Asia, Latin America and Caribbean. We also have South Asia, Southeast Asia, Sub-Saharan Africa, Western Europe and other regions. I'll just cancel this. And then we have the happiness score column that has been sorted in descending order. So we have Finland, Denmark and Switzerland, who are the top 3 happiest nations. Now if I scroll down, we have countries like Rwanda, Zimbabwe and Afghanistan, which are the least 3 happy countries. Now there are a few columns that we won't be using in our analysis, so we will learn how to exclude those columns and keep only the relevant ones. So columns such as standard error of ladder score, then we have upper whiskers and lower whisker column. So we are going to ignore these columns. We are only concerned about the GDP column, which is this one. Then we have the social support or the social status column. Then we have the health life expectancy, freedom to make life choices, generosity and perceptions of corruption. And there are a few other columns you can see to the right, and these columns are not of our interest, so we are going to ignore them. Now let's head over to our Jupyter notebook and we'll start by importing all the necessary libraries for analysis and data visualization. Okay, so I am on my Jupyter notebook. So first step, I'll just rename this notebook to, let's say, happiness report data analysis. I'll click on rename. Alright, now we'll start by importing our libraries. So first library I'm going to import is NumPy as NP. Then I have import Pandas as PD. Then I'll import 2 data visualization libraries, Seaborn and Matplotlib. So I'll say import Seaborn as SNS and then import Matplotlib dot pyplot, which is the module name, as PLT, and I'll say percentage Matplotlib inline. Okay, now let me just go ahead and run this. Alright. Well, now let's set the parameters that control the general style of the plots. The style parameters control properties like the color of the background and whether a grid is enabled by default or not. So for that, I'll say SNS dot set underscore style. I'll give it as dark grid Next, I'll say plt.rc params, which stands for runtime configuration parameters. I'm going to set my font size to, let's say, 15. Then I'll say plt.rc params. Now I'm going to set the figure size, so I'll say figure.fig size, let's say 10,7. Next, I just copy this, paste it here. Now we are going to set the face color, so I'll say figure dot face color. I want to set it to peach color, so I'm going to pass in my RGB values for peach. I'm going to set it in terms of hex code. So for peach, the value is FF E 5B and 4. Now let me run it. Okay. Now it's time to load our data set. So for that, I'll create a variable called data, and I'll use the Pandas library followed by the read_CSV function, because our data set that we saw is a CSV data set, which is this one. Now inside the parenthesis, I'll pass in the location of my data file. So I have my data here, World Happiness Report 2021. I'll just copy this location and will paste it here, and make sure the location is within quotes, and you need to change it to either / or double backslash. So here I'm using double backslash, so let me just include one more backslash, and then I'm going to pass in the file name, which is world happiness report 2021.csv, which is the extension of the file. Now let me run it. Alright, now to display the first 5 rows of information, you can use the head function. So I'm writing data, which is my variable that holds the data frame. So data.head, there you go. You can see here we have printed the first 5 rows from the data set. You have the country name, regional indicator, happiness score, then we have information about the GDP, life expectancy, generosity, then we have corruption data, and these are some of the columns that we are not bothered about, so we are going to drop these columns from our analysis. Now we are going to do that, so I'll create a variable called data columns, which are of our interest. So I am going to take only specific columns. I need the country name, so I have taken country name. Make sure the column names are within single quotes. So I have my country name. Next, I want the second column, which is regional indicator. Give a comma. We also need the happiness score. Next, I need the logged GDP per capita data. So I'll take that column. I'll say logged GDP per capita. Give a comma. My next column would be social support. Give a comma here. My next column would be health life expectancy. So I'll write health life expectancy. Let's give another comma, and we'll take the next column as well, which is freedom to make life choices. So I'll write that column name, freedom to make life choices. And finally, we'll take the next two columns, that is generosity and perceptions of corruption. So within single quotes, I'll say generosity, give a comma, and we're going to include the final column which is of our interest, that is perceptions of corruption. Let me have a recheck to ensure that I have put the column names correctly, otherwise it will throw an error. Now let me go ahead and run this cell. I'll hit Shift Enter. Alright, so we have successfully taken the columns that we'll be using for an analysis. Now I'm going to say data equal to data. I'll pass in my new variable, that is data underscore columns, and I'm going to copy all the data. So I'll say dot copy. Let's run it. Okay, this should be data underscore columns. Alright, now let's rename all these columns. We'll make it more simpler and easy to understand. So I'll say, let's say my new variable is happy underscore df, which stands for data frame, equal to, I'll say data dot, we'll use the rename function, and using a dictionary we will rename our columns. So I have used a curly bracket. I'm going to pass in my first column, which is country name. I'll just paste it here. Then I'm going to give a colon, and again within single quotes I'll say country underscore name. So this is going to be my new column name. I'll give a comma. We'll take the next column, which is regional indicator. I'll paste it here, give a colon, and the new column would be small r regional underscore indicator. Now similarly we'll do this for all the remaining columns in the dataset. Okay, now I have renamed all my columns. You can see it here. Let's run it. Now we are going to display the head of the dataset again. So I'll say happy underscore df dot head. There you go. So we have only those columns that are of our interest. So I have the country name, regional indicator, happiness score, GDP, social support, life expectancy, freedom to make life choices. Then I have generosity and perceptions of corruption. Cool. Now we are going to check whether any of the columns have any null values. So for that I'll say happy underscore df dot, I'm going to use the isNull function. I'll give another dot, and we are going to find the sum for each of the columns. You can see from the data we do not have any null values in any of the columns in the dataset. It is all 0. Okay, now let's get started with our first visualization, that is we'll create a plot between happiness score and the GDP for different regions. So for that I'll give a comment as plot between happiness and GDP. I'll just scroll down. Cool. First I'm going to set the RC parameters. So I'll say plt dot RC params within square brackets I'm going to give my figure size. So I'll say figure dot fig size equal to, let's say my figure size is 15, 7. I'll set the title, that is plt dot title of my plot, to, let's say, plot between happiness score and GDP. Next, I'm going to say SNS dot, let's create a scatter plot. So I'll say SNS dot scatter plot. I'm going to define my x-axis and the y-axis for the plot. Let's say in the x-axis we have my data frame happy underscore df dot, this should be an underscore. I'll say a column name as happiness underscore score, give a comma, and in the y-axis we'll have my data frame name, that is happy underscore df dot, we'll have the GDP column, that is logged underscore GDP underscore per underscore capita. Let's give a comma and we'll pass in hue for the color. Let's say for hue I'm going to use the regional column or the regional indicator column. So I'll say happy underscore df dot regional underscore indicator. And then I'm going to give the size of the dots as, let's say, 200. Then I'll give a semicolon. Come to the next line. I'll say plt dot, let me just scroll down. Now we are going to define the legend. So I'll say plt dot legend, and in legend we'll have the location. Let's say I want to put the legend at upper left corner. So I'll say LOC, which is for location, equal to upper left, give a comma, and then say font size of my legend, let's say be 10. Make sure this is within quotes. Then I'm going to pass my x-axis labels and the y-axis labels. So I'll say plt.x label. Let's say the x label is happiness score and my y label is GDP per capita. So I'll say plt.y label, within single quotes I'll say GDP per capita. There's an error here, there should be plot. Alright, so I have written my code to create a scatter plot. Let's run it and see the result. There is some error here. Okay, this should be regional indicator and not indicatory. There's a spelling mistake. Let's run it again. Alright, so here you can see we have a nice scatter plot. On the top you can see we have the title of the plot, that is plot between happiness score and GDP. On the x-axis we have the happiness score from 0 to 8 and above, and on the y-axis you have the GDP per capita. And if you see here, in this region we have countries from Western Europe which have the highest happiness score and the GDP per capita is also the highest. Around this region you can see here, which is for green, and in the legend you can see green is for sub-Saharan Africa. So all these countries have low happiness score and even the GDP per capita is also low. And if you see the countries for Latin America and Caribbean, you see a lot of the values lie here. So they are all within the range of 5.5 to 7 in happiness score. and even the GDP per capita is more than 9 for most of them. Now even the happiness score is high for the countries that lie in the North America and ANZ region, and even their GDP per capita is also the highest. I can name a few countries such as Australia, New Zealand, we have Canada and United States of America, which belong to the North America and ANZ region. Cool. Now there is one country which you see here. This seems to be like an outlier, which means that this is the country which has the lowest happiness score, and even the GDP per capita is also low, but it is not the lowest, because you can see here there are a few countries up here from the sub-Saharan Africa which have the lowest GDP per capita, but the happiness score is higher than this value or this country. So we can assume that this country is Afghanistan, which has the lowest happiness score as per the 2021 happiness report data. Cool. Now we'll plot a pie plot to understand the GDP by region. So by this we can know which region has the highest percentage contribution to the world's GDP as per our data. So for that I'll create a variable GDP underscore region equal to, we'll use our data frame that is happy underscore df dot, I'm going to use the group by function, and after that I'm going to use my column that is region. So we have named the column as regional underscore indicator, so I'm going to group it by this region column, and I'm going to sum the values of GDP. So I'm going to use the logged underscore GDP underscore per capita column, and after that I'm going to use the sum function, and let me just print GDP underscore region. You can see it here, we have the sum of all the countries for different regions and their GDP all total. Now this data we are going to plot it in the form of a pie plot. So I'll say GDP underscore region dot plot dot pie. We are going to plot it in terms of percentage, so I'm going to use a parameter called AutoPCT equal to, then I'm going to pass in my format. So I'll say percentage 1.1 f percentage, then I'll say plt dot title. Let's see, the title of my pie plot is going to be GDP by region, and I'll say plt dot by label, which is going to be blank. Let's run it. Okay, so here you can see we have the peach background at the back because we had assigned a peach face color. You can see it here. So for the first scatter plot also we had the peach color at the back, and now you can see we have sub-Saharan Africa contributing 20.7% to the world's GDP. The reason being we have around 34 countries in the sub-Saharan Africa, and we have the Western European countries contributing to 16.2% of the GDP. To check the least, we have North America and ANZ region because we only have 4 countries: America, Australia, Canada and New Zealand. So hence they are contributing only 3.1% to the world's GDP. Okay, now moving ahead, let's find the total number of countries in each region. So for this we are going to use the group by function that is part of the Pandas library, and we'll count the total number of countries in each region. So I'll just give a comment as total countries. Alright, I'll just scroll down. So I'll create a variable called total_country. I'm going to use my data frame, that is happy_df dot. I'm going to use the group by function. I'll group the values based on the region column. So within single quotes I'll say regional_indicator, and then I'm going to find the total count of country names. So I'm using the column country_name, and after that I'll just use dot count. Now let's go ahead and print my variable, that is total_country. Alright, now let me hit shift enter. Okay, so here you can see. Alright, so for sub-Saharan Africa there are total 36 countries and not 34 as I mentioned earlier. So hence you can see, because it has the highest number of countries, it is contributing the most to the world's GDP, that is 20.7%. Then we have the least number of countries in North America and ANZ, that is only 4. We have 6 countries in East Asia, and then we have 20 countries in Latin America and Caribbean, 12 countries in Commonwealth of Independent States, then we have 17 countries in Central and Eastern Europe. Cool. Now I'm going to show you how to create a correlation map so that we can see the relationship that exists between each of the variables that are present in our dataset. I'll just run through the code and we'll see the output. Okay, so here I have my code written for the correlation map that I want to create. So first of all, I'm going to compute the correlation matrix. So I have used the CORR function, which stands for correlation, and the method I'm going to use is Pearson method. Now here I have a Wikipedia page opened for Pearson correlation coefficient. So this is a nice article where you can understand what the Pearson correlation is all about. And then I'm going to set up the Matplotlib figures. So I have used the subplots function and I have given the figure size as 10,5, and after that we are going to draw the heat map with the mask. So I'm using the heat map function present in the Seaborn library, and then I have passed in my variable, that is COR, which essentially stands for correlation. And then I have used mask, which is a Boolean array, or it can be a data frame, and it is an optional parameter. If it is passed, the data will not be shown in cells where the mask is true, and the cells with missing values are automatically masked. After that, I have used the CMap parameter, which stands for color map, so you can customize the colors in your heat map. And I'm going to create a heat map which is in square shape, so I have said square equal to true, and the axis I am going to pass it as AX, which I have defined here. So this is the Matplotlib axis and it is optional. So axis in which you want to draw the plot, otherwise you can use the current active axis. Now let me just go ahead and run this and we'll see the heat map. There you go. So if I scroll down, here we have the correlation matrix, and since I had given my CMap as blue, and here you can see it is mostly blue, and we have the scale here. Now I'll tell you how to read this correlation matrix. So wherever the cells are in blue or dark blue color, this means that the variables have very high correlation, and all these cells where you see light blue color or grayish and white color, this indicates that the variables have very low correlation. For example, there is very low or almost negative correlation between happiness score and perceptions of corruption. So obviously if the citizens of a country feel that there is a lot of corruption in the country, their happiness score would obviously be less or low. And if you see, there is also low correlation between happiness score and generosity. There is again low correlation between health life expectancy and perceptions of corruption. And if you see these places, there is really high correlation between the happiness score and GDP per capita. Again, for social support also there is very high correlation. Now if you see, even for social support and healthy life expectancy, there is very high correlation, but there is low correlation between making life choices and generosity, and there is negative correlation between corruption and freedom of making life choices. You can see it is almost white color, which means it falls around this region, so negative correlation. Similarly, for logged GDP per capita and corruption, there is negative correlation. Alright. Okay, now we are going to visualize a bar plot that will tell us the corruption in different regions. So I'll just give a comment, corruption in regions. Let me just scroll down. Okay, so I'll create a variable called corruption, which will be equal to my data frame, that is happy_df. Now first of all, I'm going to use the group by function to group all my regions. So I'll say regional_indicator, which is my column name present in the data set. And after this, I'm going to find the average of the corruption, that is perceptions of corruption. So I'm going to pass in my variable name, that is perceptions of corruption, and I'm going to use the mean function to find the average corruption in each of these regions. Now let me just go ahead and print my variable, that is corruption. If I run it, you can see here I have the values for the different regions, and from here you can see that Central and Eastern Europe has the highest perceptions of corruption as per the questions answered in the poll. And if you see the table, we have Western Europe and the North America region with the least perceptions of corruption. Now we are going to visualize this using a bar plot now. So first of all, I'll set my parameters by giving the figure size. I'll say fig size. It's rather figure.fig size. I'll just add figure here. Okay, and now let's say I'll assign it as 12,8. Now I'll give a title to my plot. So I'll say plt.title, and my title of the plot is going to be perception of corruption in various regions. Alright, then I'm going to define my X label. So I'll say X label will be regions, and we'll set the font size of the X label to, let's say, 13, or let it be 15. Then we are going to set the Y label. In Y label, I'll have corruption index as the label name. Again, we are going to set the font size to 15. Now I'm going to use X ticks parameter, since I want to rotate the axis labels in the x-axis by 30 degrees. So I'll say rotation equal to 30, and I'll say HA, which stands for horizontal alignment equal to right. Make sure this right should be within single quotes. And finally, I'll say plt dot bar, because I'm going to plot a bar graph. I'll say corruption dot index, comma, and then I'll say corruption dot perceptions of corruption, which is my column name. Alright, so I have my code ready for the bar plot. Now let me just go ahead and print the bar plot. Make sure everything is correct. I'll just hit shift enter. Okay, there is one mistake here. It says, okay, this should be x ticks and not x tick. Let me run it again. There you go. So if I scroll down, on the top you have the title, which is perception of corruption in various regions. On the x-axis you have the regions label, on the y-axis you have the corruption index. And if you see this, as per our table that we created, we have least corruption in North America and ANZ region. Then we have the next least corruption in Western Europe, but we have the highest corruption in Central and Eastern Europe as per their citizens' perception. Similarly, we have the second and third highest corruption in Latin America and Caribbean as well as South Asia. Cool. Now moving ahead, I'm going to show you how you can find the life expectancy of the top 10 happiest countries and bottom 10 happy countries. So for that, I'm going to run you through the code and we'll see the visualization side by side. Okay, so I have my code written in these two cells. So first I'm going to find out the top 10 happiest countries, and then I'm going to find the bottom 10 happiest countries. So for that I'm using the head function and I have passed in 10 since I want the top 10 country names. And to get the bottom 10 countries as per their happiness score, I am using the tail function. So let me just run it. So we have saved the result in two variables, top underscore 10 and bottom underscore 10. And to create the bar plots, we are using two different codes. So here you can see I have set my figure size and axis, and then I have my X label as country name. After that, I am setting my title of the bar plot to top 10 happiest countries life expectancy. I've used my X tick labels and I'm rotating it by 45 degrees, and I have my horizontal alignment as right. You can see it here. We have used the bar plot function. I have the x-axis as country name and y-axis as healthy life expectancy column, and I have set my axis. Then I am using the X labels and Y labels as country name and life expectancy. And similarly, I have my bar plot for the bottom 10 least happy countries life expectancy. Let's just run it and we'll see the result. There you go. Now if I scroll down, you can see we have two different bar plots. The first one is for the 10 happiest countries, and then we have the bottom 10 least happy countries. So if you see, on an average, the top 10 happiest countries life expectancy is above 70 years. So if you are from one of these countries, you are expected to live for more than 70 years. Now if you check the bottom 10 least happy countries, you see here Lesotho has less than 50 life expectancy age, and most of them are less than 60 years. So if you are from one of the top 10 happiest countries, you are expected to live 10 years more than these countries that lie in the bottom 10 region. Cool. Now moving ahead, Alright, so now we are going to see the plot between freedom to make life choices and the happiness score. For this I'm going to use a scatter plot. So I'll first define my figure size. So I'll say plt dot rcparams, which stands for parameters. I'm going to pass in my figure size. So I'll say figure dot fig size equal to, let's say 15,7. Then using the Seaborn library and the scatterplot function, we'll pass in the x-axis. Let's say the x-axis is my data frame name happy_df, and I'll have the freedom to make life choices in the x-axis. So the column name is freedom_to_make_life and choices. I'll give a comma and we'll pass in the y-axis. Again I'm going to use my data frame name dot, and I'll have the happiness score. I'm also going to pass in a hue parameter to differentiate the different regions. So I'll say df dot regional_indicator, and I'll give the size of the dots or the bubbles as, let's say, 200. Now I'll say plt dot legend. I'll place the legend at upper left corner, so I'm giving the location, which is LOC equal to upper left, and font size, let it be 12. I'll say plt dot xlabel as freedom to make life choices, and my y label would be happiness score. Alright, now we have the code written for the scatter plot that I want to create. Let me just run it. There you go. So here we have the legend for the different regions, and we have the different colors for each of these regions. And you can see here I have on the x-axis freedom to make life choices, and on the y-axis we have the happiness score. So you can see it very clearly. For the countries that lie in the Western Europe region, the blue dots, the freedom to make life choices is more, and so is the happiness score. Then if you see the values in the green region, which is for Middle East and North Africa, the freedom to make life choices is lower, and hence the happiness score is also low. And for all these countries that are part of the sub-Saharan Africa, some of them have decent score for freedom to make life choices, but the happiness score is low again. Now if you focus on the pink dots, which is for the Southeast Asian countries, the happiness score is comparatively lower, but the freedom to make life choices is more than 0.8. Cool. And again we have one data point which is lying at the bottom. We can assume this is Afghanistan. So in Afghanistan the freedom to make life choices is very low, and even the happiness score is really low. Cool. Now moving to our next analysis, we are going to see the top 10 most corrupt countries. So first I am going to sort the perceptions of corruption column and find out the top 10 countries in the list. So for that I'm going to create a variable called country. I'll have my data frame name, that is happy underscore df dot sort underscore values by, I'm going to sort by column, that is perceptions of corruption dot head, and I want to find the top 10 most corrupt countries as per the poll. And then I'm going to pass in the figure size, so I'll say plt dot rc params, and then I'm going to set the figure size, so I'll say figure dot fig size. Make sure there is no spelling mistake. Let's say the figure size is 12,6. I'll pass in the title, so I'll say plt dot title. Let's say the title of my plot is going to be countries with most perception of corruption. After that I'll say plt dot x label. In the x label I'll have country, and I'll set the font size to 13. Then I'll say plt dot y label. In y label I'll have the corruption index. Next I'll pass in the font size for the y label. Again it is going to be 13. Now I'll say plt dot x ticks. I'm going to rotate it by 30, and I'll say horizontal alignment equal to right, and then I'll have my bar function or the bar plot function. So I'll say plt dot bar. I'm going to pass in country dot country underscore name, and then we'll have a variable country dot the column name, that is perceptions of corruption. Alright, now if I run it, you can see here, so these are the countries with the least perceptions of corruption. So Singapore has the lowest corruption index, and then we have Rwanda, Denmark, Finland. Now if you want to see the countries with the highest perceptions of corruption, you need to change this head to tail of 10, since we are sorting it in ascending order. So we would want to know the bottom 10 countries. If I run it, there you go. So these are the countries with the most perception of corruption. You have Slovakia, Lesotho, Kosovo, there's Ukraine, Afghanistan, Bulgaria, Romania and Croatia. All of these countries have a corruption index of more than 0.85. Cool. Now coming to the final section of this interesting video on happiness report data analysis for 2021, I want to visualize a scatter plot that will tell us how the corruption varies in terms of happiness score. So I'll just say a comment as corruption versus happiness. Okay, so first of all I'll set my figure size, so I'll say plt dot rc params. Within single quotes I'll give the figure size as 15, 7. Then I'm going to use the scatterplot function that is part of the Seaborn library. In the x-axis I'll have my column that is corruption, or rather we'll have the happiness score in the x-axis. So I'll say happy_df dot column name that is happiness score. Let me give a comma, and in the y-axis we'll have the corruption column. So I'll say happy_df dot perceptions of corruption, and then in hue we'll have the region that is regional_indicator. So I'll say happy_df dot regional indicator, and I'm going to give the size of the dots. So I'll say s equal to 200. Then I'm going to say plt dot legend. I'm going to put it at lower left corner this time. So I'm giving my location as lower left, and the font size of the legend I want is 14. After that I'll just say plt dot xlabel as corruption and plt dot ylabel as happiness score. Now this should rather be the opposite, since in the x-axis we have taken happiness score. So we'll put the happiness score label in x and I'll have corruption in y. Alright, so I have my scatterplot code ready. Let me just run it. There you go. So here you can see on the lower left I have the different regions, and on the x-axis I have the happiness score. On the y-axis I have the corruption index. Now you can see the general trend as per the scatter plot, that the countries with greater happiness score have lower corruption index. So you can see these countries which are from the Western European regions have highest happiness score, and their corruption is also really low. So all these blue countries, you can name a few: Finland, we have Sweden, we have Belgium, France, Netherlands lying in these regions. We also have a few countries from North America and ANZ, which are essentially Australia. Then we also have Canada, US and New Zealand. Okay, now if you focus on these green region, this region, now these are the countries from the sub-Saharan Africa, and most of the countries from these regions have a very low or less than 5 happiness score, but the corruption is also really high. You can see here they have almost more than 0.7 in the corruption index. Now you also have a country here which is from the Southeast Asia. We would like to give you a task. It would be really great if you can tell us in the comment section which country is this. It has more than 6 happiness score, but the corruption index is really low, which is less than 0.2. Now if you consider Middle East and North African regions, the darker green countries, here also if you see the happiness score is less than 5 and the corruption index is also high. Now there are a few countries, the Commonwealth of Independent States, for example countries such as Uzbekistan, then you also have Kazakhstan, we have Russia, Armenia belonging to these gray color dots. You also have Georgia and Ukraine as part of Commonwealth of Independent States. So here you see the corruption is below 0.6 for these countries and the happiness score is more than 5. Alright, so with that we have come to the end of this demo session on World Happiness Report 2021 data analysis using Python. In the next project, we'll understand how to perform data analysis using Uber dataset from New York City. So let me show you the dataset first. So this is the dataset that we'll be using for our analysis. You can see this dataset has around 5,64,516 rows. It has information about Uber bookings in the New York City. You have the date and time column when the booking was done, or you can say when the pickup or the trip was made. Next, we have the latitude and longitude information, basically defining the location from where the Uber was booked. The last column is the base column. It has data regarding TLC base company code affiliated with the Uber pickup, that is the base that dispatched the Uber. Now let me take you straight to my Jupyter notebook where I have implemented this project. So I have my code ready. I'll run through each cell of code and tell you what it does. In the process, we'll also learn some of the functionalities of Python 2. First, let's start by importing the libraries. So first, we are importing NumPy library as NP, Pandas as PD. Now NumPy is used for numerical computation. Pandas is used for pre-processing and data manipulation. Finally, we have Matplotlib and Seaborn for data visualization and exploratory data analysis. So let me hit Shift Enter to run this cell. Okay. Now let's go ahead and import our Uber dataset. So it's a CSV file. For that, I'm using the Pandas library and read_CSV function. And inside this function, I provided the location where the data file is. You can see this is my location, followed by the dataset name. This is the name of my dataset, and the extension as well, that is .csv. Let me hit Shift Enter to run this cell. Now we have successfully imported our dataset. Now to display the head of the dataset, I'll write uber.head. This is the function which is used to display the head of the dataset. Now the .head function will display the top 5 rows from this dataset. There you go. So we have our first 5 rows from the dataset. Now if you want to display some additional information about the dataset, you can use info function. So let me hit Shift Enter to run this cell. You can see the info function gives you the total number of rows and columns in the dataset. You can see we have 5,64,516 entries, that is rows, and now we have a total of 4 columns, and you can see all the columns listed here: date, time, latitude, longitude, base, and we also have the data type for each of these columns. Now moving ahead, in the following cell, we'll check if there are any missing values or null values in all the columns. For that, I have defined a function called numMissing, and it has one argument, that is x. I'm using the isNull function to return the total sum of null values. In the final print statement, I have used Pandas library and apply method. Now this apply method takes a function and applies it to all the values of Pandas series. Now let's run this cell. You can see none of the columns have any missing values. It says 0, 0, 0 and 0, which means there are no missing values in any of the columns. Next, there's another method to find null values where you can use isAny function. So let me show you how to do that. I'll write Uber, which is my data frame, dot isAny is my function, and I'll use the sum function. Let me run this. There you go. It has returned the same results, indicating there are no null values or missing values. Now we are interested to extract some additional information from the data. So I'm converting the datetime column into a data frame using to_datetime function, and I have my format specified. You can see it here. Next, I'm finding the day of week num, which means I want to know a particular day falls on which week number. So 0 for Monday, 1 for Tuesday, 2 for Wednesday, and so on. You can see I have used dt.dayofweek method. Similarly, you can also find the weekday name, that is if a particular day is a Monday or a Tuesday or a Sunday or anything. And for that I have used dt.weekday_name. Now let me extract two more information, that is the day number and the hour of the day at which the trip was made. So I'll write Uber, which is my data frame name. I'll give square brackets, and inside that I pass in my column names, say day num, and that will be equal to my data frame, that is Uber, followed by my column name, that is date/time, and I'll use the method dt.day. Similarly, to find the hour, I'll write Uber, within square brackets I give my column name hour of day, that will be equal to Uber followed by the original column name date/time, and the method I'll use is dt.hour. Let's run this. Okay. Now let me display the head of the dataset once again. So I'll write Uber.head. You can see towards the right we have our new columns added that did not exist in our original dataset. Now you can also display the shape of the dataset. Now the shape will return the total number of rows and columns present. So I'll use Uber.shape. You can see we have 5,64,516 rows and 8 columns now. Earlier, if I go on top, we had 4 columns. Now there are 8 columns in total. You can also find out all the unique base code names from where the Uber was dispatched. So let me show you how to do that. I'll write Uber, and inside square brackets I'll give my column as base and give the unique function. If I run this, you can see we have 5 different base code names. Now coming to our first visualization of the project, here we'll see the total count of Uber trips from each base. For that I've used the Seaborn library and catplot function. In the x-axis I have my base column defined. I have passed my data frame name, that is Uber, and kind I have given as count, that is I want to count the number of bookings at each base. So let me run it. This might take some time. There you go. You can see on the screen we have a nice bar graph here. The x-axis shows the count of trips for each base code. So base 02682 had the highest number of trips or bookings in April 2014, and base 02764 had the lowest number of bookings. In the next cell, let's explore another feature of Pandas library, that is to create a pivot table. For that I have used pivot_table function. For index I'm using the column names day of week num and day of week. Values I have passed my base column, and the aggregate function I have used is count. Now the cell of code will create a table to understand the total number of trips for each day of the week. Let me run this. you can see in April 2014, Wednesdays had the highest number of trips, which is around 1,08,000, while Sundays had the lowest, 51,251. Now that makes sense because Sunday is a holiday in New York and people would like to spend time at home. Now let's visualize the pivot table in the form of a bar plot. So I'll write Uber underscore week underscore data dot, I'll use the plot function. Inside plot function I'll give kind is bar, so I want a bar plot, and I'll define my figure size and I'll give equal to, let's say 8,6. Run this cell. There you go. As we saw above, Wednesday had the highest number of Uber pickups while Sunday had the lowest. Similarly, let's visualize the bookings based on hour of the day. So I have created a pivot table and then I'm trying to plot a line graph. Let's run this. Okay. You can see the trend. At midnight, the number of trips are less. It slowly increases early in the morning, and during the evening time, Uber bookings are higher. So you can see around 4 in the afternoon to 7 in the evening, Uber trips attain a peak and trips gradually decrease after 8 p.m. in the evening. Moving ahead, let's now analyze the number of Uber bookings based on each day in the April month of 2014. So I have created my pivot table and then I'm trying to plot a bar graph. You can see I have kind equal to bar. Let's run this. Okay. We have our bar graph ready. Now this bar graph depicts 30th of April had the highest number of Uber bookings, followed by 4th of April, that is this one. Now I can show you in the next two cells of code. Now in the current cell, we are basically counting the number of trips for each day in April month. I have grouped each day number using the group by function and used the apply function to count rows. Let's run it. So I have all the day numbers listed and the total number of trips that were made for each day of the month. Now let me sort the bookings for each day in ascending order. So I'll write by underscore date underscore sorted equal to by underscore date dot, I'll use the function sort underscore values. Now to display, I'll again use by underscore date underscore sorted. Let me run it. Now we have arranged this in ascending order. The results tell us that 20th of April had the lowest number of trips, while 30th of April had the highest, followed by 4th of April. Now you can also create a histogram to analyze the pickups by hours. Let's run this cell. I've used the hist function for this. Okay, so we have our histogram ready. Now this histogram is similar to the line graph that we plotted above, this one. Now let's create a cross table to analyze Uber bookings based on day of week num and hour of day. So here I have used group by function, split function, apply, as well as unstack function. Let me run this. There you go. So this is my cross table ready. On the top we have day of week num, that is 0 for Monday, 1 for Tuesday, 2 for Wednesday, 5 for Saturday, 6 for Sunday, and then Here we have the hour of day. Now let me tell you how to read this table. For example, at 11 a.m. on Tuesday there were 2,949 trips. If I scroll down, let's consider this one. At 2 p.m. on Sundays there were 2,934 trips. Let's move on to our final section of the demo. Here we'll create a heat map to analyze bookings in terms of hour of day and day of week number. For this I'm using sns.heatmap function. The brightest spot will tell the day or the hour with the highest frequency of trips. Let's run this. There you go. We have a nice heat map ready. The dark regions depict the frequency of trips were less, while the bright regions show the highest number of trips. So if I come down, these are the bright regions. So if we look at this heat map, we can conclude that 5 p.m. on Wednesdays had the maximum number of trips because this region is the brightest. Welcome to this exciting video on Olympics dataset analysis using Python by Simplilearn. This is going to be a very interesting and interactive session where I'll give you a brief about the history of Olympics and throw some light into the recently held Tokyo Olympics. But we'll focus more on using Olympics dataset that is available on Kaggle and perform some exploratory data analysis. You will understand how to use different functions in Python to analyze and extract meaningful information. During the course of our discussion, I'll be asking you a few general questions related to the Olympics. Try to answer them in the comment section of the video. So let's begin. The Olympics is one of the biggest sporting events on the planet. It is held every 4 years. The first modern Olympics took place in Athens, Greece in 1896. As per National Geographic, the original Olympics took place in 776 BC. So they began as part of an ancient Greek festival which celebrated Zeus, the Greek god of sky and weather. The rings in the Olympics logo represent the 5 continents: Europe, Africa, Asia, the Americas and Oceania. From 1924 to 1992, the Winter and the Summer Olympics took place in the same year, but now they alternate every 2 years. Before I move on, here is an interesting question for you. Only 2 people have ever won gold medals at both the Summer and the Winter Olympics. Who are those 2 people? Please share your answers in the comment section of the video. We would like to know from you. The Summer Olympics in Tokyo began on the 23rd of July and recently concluded on the 8th of August. We got to witness some thriller matches that went down to the wire, some amazing victories, and sadly there were a lot of heartbreaks as well. Winning and losing are part and parcel of any game. Fans across the world were really happy to see this global event happen this year following last year's postponement due to the coronavirus pandemic. With our Olympic fever high, let's take this opportunity to work around a project to perform exploratory data analysis using Python to analyze and visualize past Olympics data and answer specific questions. In this video, we will be using specific Python libraries such as NumPy, Pandas, Matplotlib and Seaborn to make sense of our data and extract meaningful information. We are going to visualize our results with different charts and graphs. Before I show you the dataset that we are going to use for our analysis, I have another general question for you. Which is the first Olympics where all the participating countries sent female athletes? I repeat, which is the first Olympics where all the participating countries sent female athletes? Put the year and the city name where the Olympics was held in the comment section of the video. We'll be more than happy to hear from you. Now, let me go ahead and show you the datasets that we'll be using in this video. So here you can see I have my Olympics dataset folder that has 2 datasets. These are CSV files. One is called the athlete_events and the other one is called NOC_regions. So we'll be using these 2 datasets. These datasets can be downloaded from Kaggle. We will post the dataset links in the description of the video. Please go ahead and download them. These datasets have been directly taken from the internet. Now I'll show you the datasets. So this is my first data set. You can see on the top athlete underscore events. So I have around 15 columns. You can see the count here, and there are nearly 2,71,116 rows of information. So this is a huge data set that we are going to use. The other data set we are going to use in this demo is called NOC underscore regions. Now here one thing to note is NOC stands for National Olympic Committee. This is a 3-letter code that is given by the Olympic Committee. You have the region names, so AFG is for Afghanistan, you have ALB for Albania, ALG for Algeria. We have also a column called notes. You find some notes about the region. For example, here Antigua is actually Antigua and Barbuda. Alright, let's move to the first dataset that I showed you. This is our primary dataset for our demo. So these datasets have been directly taken from the internet and were not validated. So the results that you will see in the demo is purely based on the data that we have collected. So the file athlete underscore events.csv contains nearly 2,71,116 rows of information, and there are 15 columns. So each row corresponds to an individual athlete competing in an individual Olympic event. So here ID is actually a unique number for each athlete. Then we have the name, which is basically the athlete's name. We have the sex or the gender, which is male or F for female. Then we have the age of the athlete, which is in terms of integers. We have the height in centimeters of the athletes. Then we have the weight in kilograms. We have the team name. These are the country names. You have China, Denmark, Netherlands. There are around 200 country names. Then we have the NOC. As I said, NOC is a 3-letter code that stands for National Olympic Committee. We have the games. This games contains the year and the season. You can see here 1992 summer. You also have the Winter Olympic information. Alright. Then we have a specific year column to tell you in which year this event had occurred. Now the year column is also an integer column. We have the season, so whether it was Summer Olympics or Winter Olympics. Then we have the city name. This is the host city. Then we have the sport name. You can see here we have basketball, judo, football, tug of war, speed skating. There are so many. Then we have another column called event, which is the complete event name. As you can see, the sport name is basketball, but the event name is basketball, men's basketball, to be very specific. Again, for speed skating, you have different categories like women's 1000 meters, 500 meters. Alright. Now the final column is the medal column. So it has the information about the athlete, whether the athlete had won a medal, be it gold, silver, bronze, and NA means the athlete did not win any medals. So we'll use these two data sets. Now let's get started with the demo. We'll be using Jupyter Notebook for our analysis. So I'll take you to my Jupyter Notebook right away. I have opened it on Chrome. So this is my Jupyter Notebook that we are going to use. You can see here Olympics dataset analysis. I have already have a few cells that have been filled with some piece of code, and you can see there are some comments written as well. We are going to use this dataset. So let's get started. First and foremost, we'll import the datasets. So we are going to use NumPy, Pandas, Matplotlib, and Seaborn. Let me hit Shift Enter to import all the libraries. Alright. Now the next thing is to load the datasets using Pandas read underscore CSV function. So I'll create a variable called athletes. I'll say equal to pd dot. I'll use the read underscore CSV function, and inside this function we'll give the location of the files. So I'll copy this location and here I'll paste. Make sure this is within quotations, and these are all /. I'll give another forward slash, and after that I'll give the file name, that is athlete underscore events dot csv. I'll close the quotation. Let's run it. Okay. Similarly, we will load the second data set. I'll create another variable called regions. So it will have my data frame. I'll use the same function pd.read underscore csv. I'll just copy this file path till here. We'll paste it, and I'll give my second file name, which is noc underscore regions dot csv. You can verify here. The first one is athlete underscore events, the second one is noc underscore regions. Okay, I'll close the quotation and we'll run it again. Okay, there seems to be some error. I think this is the regions. Cool. Now moving ahead, let's see the first few rows of both the datasets. I'll use the head function for that. I'll say athletes dot head. So this will print the first 5 rows from my dataset athletes. You can see here from 0 to 4 you have 5 rows of information: the ID, name, sex or the gender, age, height, weight. If I go to the right, you have games, year, season, sport, event and medal. Now let's see the second dataset that we imported or loaded. I'll say regions dot head. It says regions is not defined. Let me cross check it. Okay, I have taken it as region. Let's make it regions. Cool. Now let's run it. There you go. So these are the first 5 rows from our second dataset. You have NOC, region and some notes. Alright. Now the next step is to combine both the datasets. So we'll join the data frames using the Pandas merge function. Let me show you how to do it. So this is going to be a horizontal join. I'll create a variable called athletes underscore df. Then I'll use my first variable, which is athletes. I'll say dot merge, which is my function name. I'm going to merge the regions data frame. I'll use the how parameter. In how, I'll give my value as I want to do a left join, and my common column in both the datasets is actually NOC. So I'm going to use the NOC column as my common column to merge both the datasets. Now let's go ahead and print the merged data frame. I'll say athletes underscore df dot head. Let's run it. There you go. So if you see clearly, if I move to the right, you can see here we have added 2 more columns that were present in the second dataset, which was regions. So we have regions and notes added to my first dataset, that is athletes underscore events. Cool. Now one thing to note here is, see, the column names are not consistent. If you see here, the rest of the columns start with a capital letter, but if you see the last 2 columns that we just added now start with a lowercase letter. So we'll use the rename function to make the column names consistent. But before that, let's see the shape of the data frame. So I'll print the shape of the data frame to know the total number of rows and columns. I'll say athletes. If I hit tab, you will see it will give me the prompt. I'll select athletes underscore df. I'll use the shape attribute. Let's run it and see the result. You can see here it gives me the total number of rows, so 2,71,116 rows, and earlier we had 15 columns in the first data set, and now that we have added 2 more columns, so the total number of columns becomes 17 now. Cool. So now it's time to make the column names consistent. So I'll show you how to do it. I'll say athletes underscore df dot, I'll use the rename function, and then I'll say columns equal to, I'll use curly braces, my first column, that is region, I want to change it to region, but the R should be capital now or uppercase. I'll give a comma and then say my second column, this should be region actually, my second column, that is notes, I want to change the first letter to uppercase, so I'll say capital N, the rest all remains same. I'll give a comma here and say in place equal to true, so it will change the column names and will reflect in this athletes underscore df data frame. Let's run it. Now to verify, you can again use the head function. I'll run this again. Let me scroll down and move to the right. You can see the difference. There you go. So we have successfully renamed the last 2 columns, region and notes. Alright. Now moving ahead. Now I'll show you how you can use the info method to print information about a data frame, including the index data type, the column data types, non-null values, and memory usage. So for that you just need to use the info function. So I'll write athletes underscore df dot info. Let's run it. There you go. So here we have the data columns. You can see total 17 columns. You have 2,71,116 rows or entries. Then you have the different column names, and it says non-null and the data type of the column. Below you can see some information about the memory usage. Alright. Next, the describe method is used for calculating statistical information such as mean, standard deviation, the percentiles of the numerical values of the data frame, and much more. It analyzes both numeric and object series and also the data frame column sets of mixed data types. So let me show you how using the describe function you can display some statistical summary. I'll just write describe and give parenthesis. Let's run it. Okay, if I scroll down, you can see here by default the describe function will only give information about numerical columns. So here you can see we have the total count, the mean of each of these columns, you have the standard deviation, the minimum and maximum value, and then we have the 25th percentile, the 50th percentile, and the 75th percentile value of the columns ID, age, height, weight, and year. Alright. Now one thing to notice here is, if you see the year column, the minimum year is 1896. So this is when Olympics started, and until recently the Rio Olympics that was held in 2016. Alright. Now moving ahead. Now let's check if there are any null values present in the columns of the data set. So first I am going to create a variable called nan values, give equal to, I'll say athletes underscore df, and the function to check is, I'll say is na. I'll create another variable called nan underscore columns, and here I'll use the any function. I'll say nan underscore this variable which is underscore values dot, I'll say any, and I'll print my NaN columns variable. So this will display the result in terms of Boolean values. So if there are any null or NaN or missing values in any of the columns, it will say true, otherwise it will say false. Let's display the result. There you go. So if you mark here clearly, so there are nearly 6 columns where we have missing values. You have age, height, weight, medal, region and notes columns that have missing values, so hence it has given us true. The rest of the columns do not have any NaN or missing values, hence they are false. Alright, let me scroll down. Now let's see the total number of null values for the above 6 columns. So I'll say athletes underscore df dot, I'll use the function is null, and again I'll use the sum function. Okay, this should be is null. If I run it, you can see it here. So our age column has 9474 rows where we have null values. Then we have some null values for the height column as well, for the weight column. So these are the total number of rows where we don't have any information regarding age, height, weight or region. Notes, this medal is self-explanatory because a lot of the athletes who participate in Olympics don't win any medals, so for them the value is NA. Now before I move ahead, I have a question for you people. So the question is, I want you to print the column names containing null values or missing values in the form of a list. So please answer this question and put it in the comment section of the video. We would be happy to know your approach. So the question, I'll repeat it again. I want you people to print the column names containing null values or missing values in the form of a list. So basically on the top we saw there were 6 columns that had null values. I want you to print these 6 columns in the form of a list. Alright, now moving ahead. Now let's see the data for specific countries. Let's say you want to see the athletes who have participated in the Olympic Games from the beginning for India. For that, you can filter your result using a function called query. So let me show you how to do it. I'll say athletes underscore df dot, we'll use the query function, and then I'll say team, which is my column name, should be equal to, and the value I'll give is India. Now let's display the first 5 rows of information or the details for the athletes who are from India. If I run this, okay, there is some error here. Okay, so we need to make sure this entire expression or the condition should be within single quote. I'll just delete this single quote from here and we'll add it in the end. Now let's run it. There you go. So here you can see we have the top 5 rows of the athletes who are from India. You can see here the region is India, you can see the NOC is India, the team is India, and let me go to the left. You can see the name of the athlete, the sex, age. So for age you have some missing values, you have the weight, team, year and everything. Alright, similarly you can also check for Japan. Let me just copy the above code, I'll paste it here, and instead of India I'll say Japan. I'll run it. There you go. So if you see here, you can see all the details are for the athletes who are from Japan. Alright, now moving ahead. Now I want to know the top 10 countries who have participated since the inception of Olympics in 1896. So for that I'll create a variable called top_10_ countries. I'll say equal to, I'll use my data frame, that is athletes_df. I'll say dot team, then I'll use the function value_counts. I'm going to sort my count in ascending order. Just mark the way in which I'm writing the functions. Any error in terms of syntax or the flow will throw you an error. I want to display the top 10 countries. Now let's go ahead and print it. I'll say top_10_ countries. Alright, let me run it. Okay, it has given us an error. Let's debug it. Okay, so this should be value counts and not count. Let's run it again. Another error. Okay, so this should be short_values and not value. Let's run it again. There you go. So here you can see the top 10 countries participating in Olympics since 1896. You have United States, then we have France. So these are the number of participants who have taken part since 1896. So the most number of participants have come from US, then we have France, Great Britain, Italy, Germany, Canada, Japan, Sweden. We also have Australia and Hungary. I'll scroll down. Now we are going to convert this table that we got, or the output that we got, in the form of a graph. So I'm trying to create a bar plot to plot the top 10 countries who have participated in Olympics. So here I'm using the figure function to give the figure size. So these are the dimensions 12,6. Now I'll tell you what this PLT_X means. Just wait for a while. I have given a title to my plot saying overall participation by country, and then using the Seaborn library and the bar plot function, I am plotting the X and the Y axis. So my X axis has top. I should make this top 10 countries because above we used top_10_ countries. Similarly for Y axis I'll make it top_10_ countries, and then I'm using a color palette called set2. Let's run it. There you go. So if I scroll down, you can see here we have a nice bar plot. This is a vertical bar plot, and here you can see the bars which represent the different country names. First we have United States, which has the highest participation since the beginning of the Olympics. Then we have France, Great Britain, Italy, Germany, Canada, and we have the rest of the countries. Cool. Now moving ahead, the next visualization we are going to see is the age distribution of the athletes. So for this we are going to create a histogram. I'll be using the Matplotlib library specifically for this visualization. So I'll say plt.figure will give the figure size using the argument fig size equal to, and this will be a tuple actually. My size is going to be 12,6. I'll say plt dot title. Now you can give any title that you want. I'll say age distribution of the athletes. Then we'll also give the X labels. I'll say plt dot X label. This will have age. Then we'll say plt dot Y label, and this will have the label as number of participants. Next, I'm going to use the hist function, so I'll say plt.hist and I'll pass in my data frame, that is athletes underscore df dot age, which is my column name, comma, I'm going to pass in the bins. For that I'm going to use the np.arange function, so np is for numpy, and inside this I'll say 10, 80, 2. So my bins will start from the value 10 and go until 80 with a size of 2, comma, I'll give another parameter that is going to specify the color of the bins. I want my color to be orange, and then I'll use the edge color to separate the bins. I'll say edge color, this is the parameter or the argument name, and the color I want is white. Let's give a semicolon here, and this should be edge color. There's a spelling mistake here. Now let's run it and we'll see the output. So there you go. So this is a nice histogram that shows the distribution of the age of the athletes. You can see the title age distribution of the athletes. On the y-axis you have the number of participants. On the x-axis we have the age values ranging from 10 to 80 with a size of 2. And if you see this, we have most number of athletes who have an age between 20 to 30. You can see here. So early 20s we have maximum number of athletes participating in the Olympics. We also have a few athletes who are beyond 40 years of age. You can see here we have a few athletes even closer to 60 also, and similarly we have a few athletes who are under 18 years of age. Alright, now you can see here the bins we had taken orange color, so all the bars are represented in orange color, and the edge you can see here we have the white color. Alright, now moving ahead. Now in the initial slides of the video we discussed the summer and winter Olympic Games. Let's look at the different sporting events that are part of the summer and winter Olympic Games. Just to give you a heads up, the winter Olympic Games are held once every 4 years for sports practiced on snow and ice. So here I have my variable name winter underscore sports, so I'm extracting for season equal to winter, and I am going to display only the unique values. Now let me run this cell. Okay, so you can see here these are the different winter sports that are held during the winter Olympics. Now similarly, let's see for summer Olympics. So what I'm going to do here is I'll just copy this cell of code and we'll edit the variables. I'll say summer underscore sports, athletes underscore df remains the same. Here season we'll change it to summer, dot sport dot unique remains the same, and here I'll say summer underscore sports. This should be small. Now let's run it. There you go. So here you can see we have more number of Olympic sports that are held during the summer Olympics compared to winter Olympics. So these are the sports that are played on snow and ice, and these are the sports that are played during summer. Moving ahead, now it's time to analyze the total number of male and female participants who have taken part in different games since 1896 till 2016 Rio Olympics. Alright, so I'll say gender underscore counts, which is my variable name. I'll use my data frame, that is athletes underscore df dot my variable name, that is sex, dot value underscore counts, and then we are going to print gender underscore counts. Let's run this. There you go. So since the inception of Olympics, we have more number of male participants than female participants. Now here in this current cell, you can see we are trying to plot a pie chart for male and female athletes. So I have given my figure size, then I have my title as gender distribution. I'm using the Matplotlib library and the pie function. I'm using the variable gender counts that we used here. Then I'm giving my labels as gender underscore counts.index. Now I'm using this auto PCT. The auto PCT parameter enables you to display the percent value using Python string formatting. So this is my string formatting that I have used, and I'm initialized my start angle for the pie chart as 150 degrees, and I'm also giving shadow to my pie chart. So I have written shadow equal to true. Let's run it. Alright, so you can see here this is my pie chart that shows you the distribution of the male and female participation. So for male it is 72.5%, for female so far it is 27.5% as per the dataset that we have. We can change this start angle to, let's say, 180 degree, and it will change the pie chart to this direction. Cool. Now moving ahead, this time we are going to find the total number of medals that the athletes have won. So I'll use my data frame athletes underscore df dot, and then my column, that is medal, I'll say dot value underscore counts. Let's run it. There you go. So you can see the gold medals, the bronze medals and the silver medals are very much similar to each other. The numbers are pretty much the same. Alright, now it's time to focus on the total female athletes who have taken part in each Olympics. So I'll create a variable called female underscore participants. I'll say equal to, and then use my data frame name, that is athletes underscore df. Using square brackets, I'll say athletes underscore df dot, the gender should be equal to female, and I'll use ampersand. I'll say, just copy this, paste it here. I'll say dot season equal to, we'll check for Summer Olympics, and I want to extract only the gender column. So here it is sex, comma, my year column, which is year. Okay, and then I'll say female underscore participants equal to, I'll just copy this, paste it here, and then I'll use the group by function. Say group by, which is part of the Pandas library. I'll say year, and then I want to find the count. I'll reset the index, say reset underscore index is a function, and finally we are going to print female underscore participants, and let's say the head. Alright, so what we are trying to do is, I'm trying to filter my data only for the female athletes for Summer Olympics, and here I am printing the participation based on each year, so I'm finding out the count. So here we need to add one more square bracket. Alright, now we'll run it and see the result. There you go. So you can see here from 1900, 1904, all these years you can see the female participation. Let me change it to tail so that we have the recent data of the Olympics. You can see it here. For the Beijing Olympics, 5,816 women athletes participated. In 2012 London Olympics, we had 5,815 Olympics. Similarly, for the 2016 Rio Olympics, we had more participation than the London Olympics. So 6,223 women athletes had participated. Alright. Now here, this is another way in which you can filter your data for female athletes. So I'm using two parameters. My gender should be equal to female and season is Summer Olympics. Let me just run it. I have stored it in a variable called Women Olympics. Now here I am trying to find a count plot, or I am trying to create a count plot using my Seaborn SNS library. I have set my style to dark grid. Then my figure size I have given as 20,10. My count plot will have the x-axis as year. The data is Women Olympics, and palette I'm using as spectral, and then I've given a title Women Participation. Let's run and see the output. There you go. If I scroll down, you can see on the top I have the title for my count plot, which says Women Participation, and on the y-axis I have the count, and at the bottom you can see the different year values from 1900 till 2016, and 2016 had the highest number of female participation. Cool. Let me scroll down. So in this cell of code we are trying to plot a line graph. Let me run it and show you the output. So this line graph shows the trend which says plot for female athletes over time. So here you can see the line graph. So gradually the women participation has increased in Olympics since its inception. There was a slight decrease here. This is around 1950s, and again you can see here there's a decrease with the women participation in 1980, but since then, since 1980, there has been continuous increase in the participation of female athlete numbers. Cool. Now coming to the next section of our analysis. Now we are going to filter the data to see the details of the athletes who have won gold medals. So I'll create a variable called gold medals. It's equal to, I'll use my data frame as athletes underscore df, and within parenthesis I'll use my data frame name, which is athletes underscore df dot, I'll use the condition medal equal to, and my value would be gold. Next, I'm going to say gold medals dot head. Let's run it. There you go. So here we have the top 5 rows of the athletes who have won a gold medal. You can see all the records have medal as gold. Now we are going to use this subset of the data and perform some more analysis. So here I want to take only the values that are different from NaN. So I'm going to use is finite function, and inside that I have set gold medals age. Let me just run it. Cool. Now I want to see the athletes who have secured a gold medal beyond the age of 60 years, which is very rare. So we'll see the total number of athletes with more than 60 years of age having won a gold medal. So here I'm going to say gold medals. I'll use my column as ID, and then I'll use my variable gold medals, and then I'll say age should be greater than 60, and then I'll close my square bracket and say count. Okay, let me just verify if everything's fine. Yeah, I'll run it and we'll see the result. So there are total 6 athletes who have won a gold medal having age more than 60 years. Cool. Now let me check for which sport these 6 gold medals have come. So I'll say sporting underscore event. This is going to be my variable name, equal to, I'll use the same variable name, gold medals. I'll going to choose my sport column, and then I'll give my condition age greater than 60. Now let's go ahead and we'll print the variable sporting event. If I run this, you can see it here. So for art competitions, even for archery and shooting, and this one called rook, we have had gold medals from athletes who had an age more than 60 years. Now we are going to plot this result or the table that we achieved on the top. So I'll say plt dot figure. I'll give my figure size equal to, let's say 10,5. Then I'll say plt dot, we'll use the tight layout, say tight underscore layout. Then I'm going to use the Seaborn library and create a count plot for my variable sporting underscore event. Then I'll say plt dot title. I'll give the title as gold medals for athletes over 60 years of age. Let's run it, and if I scroll down, you can see here we have a nice count plot. I have my title gold medals for athletes over 60 years, and since for archery we had 3 players who secured a gold medal having an age more than 60 years. You can see here archery is 3, art competition 1, rook is 1, and shooting we had 1 medal. Alright, now we'll see the total gold medals from each country. So for that I'll say gold medals dot, we'll use the region column, and followed by that I'll use the value underscore counts function, and I'll reset the index with name equal to, I'll provide the medal column. Then we are going to print the head for the top 5 countries. Let me run it. You can see it here. So USA has secured the most number of gold medals. Then we have Russia, Germany, UK, and then we have Italy. Cool. Now in this cell I am going to create a plot to visualize the table that I got above. So I've used my labels, my titles. I'm using the cat plot function that is present in the Seaborn library. I have my x-axis, my y-axis, the data which is total gold medals. Let me just verify. Okay, and we'll run it. If I scroll down, you can see this is a different palette that I had used, which is a rocket, and you can see USA has got the most number of gold medals. Then we have Russia, Germany, UK, Italy and France. Now we also have included France here, which was not present in this table. The reason being I have used head as 6. So it will give me the top 6 countries. Alright. Now we will analyze and look at the data for the most recent Olympic event that is present in our dataset. I'm talking about the 2016 Rio Summer Olympics. So first of all, I'll create a variable called max year, which will be equal to my data frame name athletes underscore df, my column name year, and I'll use the max function. Then let's go ahead and print my max year. I'll just show you the output. You can see here my max year present in the dataset is 2016, the Rio Olympics. Next, we will create another variable called team underscore names that will be equal to my data frame name athletes underscore df. Within square brackets, I'll give parenthesis and then say athletes underscore df dot year should be equal to my output, that is max year, which is actually 2016, and then I'll say ampersand. I'll just copy this, we'll paste it here. This time I'll use the medal column and say equal to gold. I'll say dot team. Then I'll say team underscore names dot value underscore counts dot head, and will display the top 10 countries. Let me run this. There you go. So in Rio Olympics, United States secured the most number of gold medals. Now the reason this is 137 is we have also counted the team events, for example basketball. Similarly, Great Britain had 64 gold medals in total, Russia 50, we have Brazil 34, Argentina 21, France 20 and Japan 17. Alright. Now using the above result, we are going to create a bar plot. I'll just change this team underscore list to team underscore names. Similarly here also I'll make the corrections as team underscore names. Cool. Now we'll run it, and you can see here we have a nice horizontal bar plot. So we have United States at the top, Great Britain, Russia, Germany, China, Brazil. So here I am displaying the top 20 nations since I have used head as 20. So these are the top 20 nations who secured the most number of gold medals in the Rio Olympics. Alright. Now in the final section of this video, we will create a scatter plot to visualize the height and weight of male and female athletes who have won a medal. Now it can be a gold medal, a silver medal or a bronze medal. But before that, we need to filter the data only for athletes who have won a medal. Now if you had noticed here, our medals column also had a few null values, so we are not going to consider those null values here. We are only going to consider for the athletes who have won a medal. So for that I'll create a variable called not underscore null underscore medals equal to, I'll say athletes underscore df, then I'll give my, let's make it df, I'll give my condition. Let me just copy this, I'll paste it here, and then I'll give my condition height and use the not null function, and then I'll say ampersand, create another parenthesis, I'll say athletes underscore df. This time we'll consider the weight column. Again, I'll use the function as not null, and I'll close the parenthesis. Okay, I had missed one s here. Cool. Let me just run it now. Alright. Now we are going to create our final plot. I'll say plt.figure. I'll give my figure size equal to, I'll say 12,10. I'll say axis equal to SNS dot. We'll be creating a scatter plot to plot the height and weight of the athletes who have won a medal. I'll say scatter plot. In my x-axis I'll have height, comma. In my y-axis I'll have weight, comma. My data should be not underscore null underscore medals. So this is what we created here, not underscore null underscore medals, comma. I'll use hue equal to my sex column. Cool. Finally, I'll say plt dot, I'll give a title to my plot saying height versus weight of Olympic medalists. Cool. Now let's see our scatter plot. This might take some time to give the result because there are so many athletes present in a dataset who have won a medal, and also we are filtering in terms of hue, which is for male and female. There you go. So if I scroll down, you can see here we have a nice scatter plot. On the top we have the title of the plot saying height versus weight of Olympic medalists. You can see our age as the hue. So blue points are for the male athletes and orange points are for the female athletes. And on the y-axis we have the weight in terms of kilograms, and you have the height in terms of centimeters. Cool. So that brings us to the end of this demo session on Olympics dataset analysis. So we used two datasets to carry out this exploratory data analysis, and we created some visualizations to analyze and visualize the data. Welcome to this video tutorial on Introduction to SQL by Simplilearn. In this session, we are going to learn about databases, how data is stored in relational databases, and we'll also look at some of the popular databases. Finally, we'll understand various SQL commands on MySQL Server. Now let's get started with what is a database. So according to Oracle, a database is an organized collection of structured information or data that is typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed, and updated. You can organize data into tables, rows, columns, and index it to make it easier to find relevant information. Now talking about some of the popular databases, we have MySQL database, we also have Oracle database, then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server. Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze, and manipulate databases. With this, let's look at what a table is. So this is how a table in a database looks like. So here you can see the name of the table is players. On the top, you can see the column names. So we have the player ID, the player name, the country to which the player belongs to, and we also have the goals scored by each of the players. So these are also known as fields in a database. Here, each row represents a record or a tuple. So you have the player ID, which is 103 here. The name of the player is Daniel. He is from England, and the number of goals he has scored is 7. So you can use SQL commands to query, update, insert records, and do a lot of other tasks. There are mainly 4 types of SQL commands. So first we have data definition language or DDL. So DDL commands change the structure of the table, like creating a table, deleting a table, or altering a table. All the commands of DDL are auto-committed, which means it permanently saves all the changes in the database. We have create, alter, drop, and truncate as DDL commands. Next, we have data manipulation language or DML. So DML commands are used to modify a database. It is responsible for all forms of changes in the database. DML commands are not auto-committed, which means it can't permanently save all the changes in the database. We have select, update, delete, and insert as DML commands. Now select command is also referred to as DQL or data query language. Third, we have data control language or DCL. So DCL commands allow you to control access to data within the database. These DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. So we have grant and revoke, which are the examples of data control language. Finally, we have something called as transaction control language or TCL. So TCL commands allow the user to manage database transactions. Commit and rollback are example of TCL. Now let's see the basic SQL command structure. So first, we have the select statement. So here you specify the various column names that you want to fetch from the table. We write the table name using the from statement. Next, we have the where clause to filter out our table based on some conditions. So you can see here where condition 1, condition 2, and so on. Then we have the group by clause that takes various column names. So you can write group by column 1, column 2, and so on. Next, we have the having clause to filter out tables based on groups. Finally, we have the order by clause to filter out the result in ascending or descending order. Now talking about the various data types in SQL. So we have exact numeric, which has integer, small int, bit, and decimal. Then we have approximate numeric, which are float and real. Then we have some date and time data types such as date, time, timestamp, and others. Then we have string data type, which includes char, this varchar, and text. Finally, we have binary data types, and binary data types have binary, var binary, and image. Now let's see some of the various operators that are present in SQL. So first we have our basic arithmetic operators. So you have addition, the subtraction, multiplication, division, and modulus. Then we have some logical operators like all, and, any, or, between, exists, and so on. Finally, we have some comparison operators such as equal to, not equal to, thus greater than, less than, greater than equal to, or less than equal to, not less than, or not greater than. Now let me take you to my MySQL workbench where we will learn to write some of the important SQL commands, use different statements, functions, data types, and operators that we just learned. Let me now go ahead and open my MySQL workbench. So in the search bar, I'll search for MySQL workbench. You can see I'm using the 8.0 version. I'll click on it, and here it says welcome to MySQL workbench. And below under connections, you can see I have already created a connection which says local instance. Then you have the root, the local host, and the port number. Let me click on it. You can see the service, the username is root, and I'll enter my password and hit OK. Now this will open the SQL editor. So this is how the MySQL workbench looks like. Here we learn some of the basic SQL commands. So first, let me show you the databases that are already present. So the command is show databases. You can hit tab to autocomplete. I'll use a semicolon. I'll select this, and here on the top you can see the execute button. So if I run this, below you can see the output. It says show databases, 7 rows are returned, which means currently there are 7 databases. You can see the names. Alright, now let's say I want to see the tables that are present inside this database called world. So I'll use the command use world, which is the database name. Now let me run it. So currently I'm using the world database. So to display the tables that are present in the world database, I can use the show command and write show tables. Give a semicolon, and I'll hit Control Enter this time to run it. Alright, so you can see the tables that are present inside this world database. So we have 3 tables in total: city, country, and country language. Now if you are to see the rows that are present in one of the tables, you can use the select command. So I'll write select star, which basically means I want to display all the columns. So star here means to display all the columns. Then I'll write my from the table name, that is city. So this command is going to display me all the rows that are present inside the city table. So if I hit Control Enter, alright, you can see the message here. It says 1000 rows were returned, which means there were total 1000 records present inside the city table. So here you can see there's an ID column, a name column, this country code, district, and population. Alright. Similarly, you can check the structure of the table by using the describe command. So I'll write describe, and then I'll give the table name, that is city. Now let's just run it. There you go. The field shows the column names. So we have ID, name, country code, district, population. Type here shows the data type of each of the columns. So district is character 20, ID is an integer, population is also integer. Null says yes or no, which means if no, then there are no null values. If it's yes, which means there are null values in your table. Key here represents whether you have any primary key or foreign key, and these are some extra information. Now let's learn how to create a table in MySQL. So I'll use the create table command for this, and before that let me create a database, and I'll name it as SQL intro. So the command is create database, and I'll give my database name, that is SQL_intro. Let me give a semicolon and hit Control Enter. So you can see I have created a new database. Now if I run this command, that is show databases, you can see this newly created database, that is SQL intro. If I scroll down, there you go, you can see the name here, SQL intro. Okay, now within this database we'll create a table called employee details. Now this will have the details of some employees. So let me first show you how to create a table that will be present inside the SQL intro database. So I'll use the command create table, and then I'll give my table name, that is going to be employee_details. Next, the syntax is to give the column names. So my first column would be the name column, which is basically the employee name, followed by the data type for this column. Since name is a text column, so I'll use varchar, and I'll give a value of 25. so it can hold only 25 characters. Okay. Next, I also want the age of the employee. Now age is always an integer, so I'll give int. Okay. Then we can have the gender of the employee. So gender can be represented as F or M, F for female and M for male. So I'm using the car data type or character data type, and I'll give the value as 1. Then let's have the date of join or DOJ, and this is going to be of data type date. Alright. Next, we'll have the city name, that is the city to which the employee belongs to. So again, this is going to be varchar 15. Finally, we'll have a salary column, and salary we'll keep it as float, since salary can be in decimal numbers as well. Now I'll give a semicolon. Alright, so let me just quickly run through it. So first I wrote my create command, then the table, which is also a keyword, followed by the table name, which is employee details here, and then we gave the column names such as name, age, this gender, date of join, city and salary. For each of the columns we also give the data type. Alright, so let me just run it. Okay, so here you can see we have successfully created our first table. Now you can use the describe command to see the structure of the table. I'll write describe emp underscore details. If I run this, there you go. So under field you can see the column names, then you have the data types. Null represents if the table can accept null values or not, and these are basically empty, and we haven't set any default constraint. Alright, moving ahead. Now let's learn to add data to our table using the insert command. So on a notepad I have already written my insert statement, so let me just copy it and then I'll explain it one by one. Alright, so if you see this, so we have used an insert into statement or a command followed by the table name, that is emp details. Then this is the syntax. Using values I have passed in all the records. So first we have Jimmy, which is the name of the employee, then we have 35, which basically represents the age, then M means the gender or the sex, then we have the date of join, next we have the city to which the employee belongs to, and finally we have the salary of the employee. So this particular information represents one record or a tuple. Similarly, the next employee we have is Shane. You can see the age and other information. Then we have Mary, this Dwayne, Sarah and Amy. Alright, so let me go ahead and run this. So this will help you insert the values in the table that you have created. You can see we have successfully inserted 6 records. Now to display the records, let me use the select statement. So I'm using select star from emp underscore details. If I run this, you can see my table here and the values it has. So we have the name column, the age column, the state of join, city, salary, and these are the values that you can see here. Moving ahead, now let's say you want to see the unique city names present in the table. So in this case you can use the distinct keyword along with the column name in the select statement. So let me show you how you can print the distinct city names that are present in our table. Now if you notice this table clearly, we have Chicago, Seattle, Boston, Austin, there's New York, and there's Seattle repeated again. So I only want to print the unique values. So for that I can write my select statement as select distinct. Then I'll give my column name, which is city, from my table name, that is emp details. If I run this, you can see my query has returned 5 rows and these are the values. So we have Chicago, Seattle, which was repeated twice, is just been shown once. Then we have Boston, Austin and New York.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's see how you can use inbuilt aggregate functions in SQL. So suppose you want to count the number of employees in the table. In that case, you can use the count function in the select statement. So let me show you how to do that. So I'll write select. I'll use my function name, that is count. Now since I want to know the total number of employees, I'm going to use their name inside the brackets from employee underscore details. Now if I run this will return the total number of employees that are present in the table. So we have 6 employees in total. Now if you see here in the result, it says count name. Now this column is actually not readable at all. So what SQL provides is something called as an alias name. So you can give an alias to the resultant output. So here I can write select count of name and use an alias as I can give an alias as count underscore name and run this statement again. There you go. You can see here in the resultant output we have the column name as count name, which was our alias name. Now suppose you want to get the total sum of salaries, you can use another aggregate function called sum. So I'll write my select statement, and this time instead of count I'm going to write sum. And since I want to find the sum of salaries, so inside the bracket I'll give my salary column from my table name, that is employee details. If I run this will result in the total sum of salaries. So basically it adds up all the salaries that were present in the salary column. Now let's say you want to find the average salary. So instead of sum, you can write the average function, which is avg. So this will give you the average salary from the column salary. So you can see it here. This says average salary. Now if you want, you can give an alias name to this as well. Now you can select specific columns from the table by using the column names in the select statement. So initially we were selecting all the columns. For example, like you saw here, the star represents that we want to see all the columns from the employee details table. Now suppose you want to see only specific columns, you can mention those column names in the select statement. So let's say I want to select just the name, age and the city column from my table, that is employee details. So this will result in displaying only the name, age and city column from the table. If I run it, there you go. It has given only 3 columns to me. Now SQL has a where clause to filter rows based on a particular condition. So if you want to filter your table based on specific conditions, you can use where clause. Now where clause comes after you give your table name. So suppose you want to find the employees with age greater than 30. In this case you can use a where clause. So let me show you how to do it. I'll write select star from my table name, that is employee details, and after this I'll use my where clause. So I'll write where age greater than 30. If I run this, it will give me the output where the age is only greater than 30. So it excluded everything that is less than 30. So we have 4 employees whose age is greater than 30 here. Now suppose you want to find only female employees from the table, you can also use a where clause here. So I'll write select, let's say I want only the name, the gender, which is sex here, comma city from my table, that is employee details, where I'll give my column name, that is sex, is equal to, since I want only the female employees, I'll give F and run this statement. Okay, you can see here our employee table has 3 female employees. Now suppose you want to find the details of the employees who belong to Chicago or Austin. In this case you can use the OR operator. Now the OR operator in SQL displays a record if any of the conditions separated by OR is true. So let me show you what I mean. So since I want the employees who are from Chicago and Austin, I can use an OR operator. So I'll write select star from emp details, which is my table name. Then I'll give my where clause where city equal to, I'll give my city name as Chicago, and then I'm going to use the OR operator, or city equal to, I'll write Austin. I'll give a semicolon and let me run it. There you go. So in the output you can see all the employees who belong to the city Chicago and Austin. Now there is another way to write the same SQL query. So you can use an in operator to specify multiple conditions. So let me just copy this, and instead of using the OR operator, this time I'm going to use the in operator. So I'll delete this. After the where clause, I'm going to write where city and use the in operator. Inside bracket, I'll give my city names as Chicago and I want Austin. So I'll give a comma and write my next city name, that is Austin. So this query is exactly the same that we wrote on top. Let me run this. You will get the same output. There you go. So we have Jimmy and Dwayne who are from Chicago and Austin respectively. Now SQL provides the between operator that selects values within a given range. The values can be numbers, text or dates. Now suppose you want to find the employees whose date of join was between 1st of Jan 2000 and 31st of December 2010. So let me show you how to do it. I'll write select star from emp details where my date of join, that is DOJ, between, I'll give my two date values, that is 1st of Jan 2000 and I'll give my second value, the date value, that is 31st of December 2010. So every employee who has joined between these two dates will be displayed in the output. If I run it, we have two employees who had joined between 2000 and 2010. So we have Jimmy and Mary here who had joined in 2005 and 2009 respectively. Alright. Now in where clause, you can use the AND operator to specify multiple conditions. Now the AND operator displays a record if all the conditions separated by AND are true. So let me show you an example. I'll write select star from employee details table where I want the age to be greater than 30 and I want sex to be male. Alright, so here you can see I have specified two conditions. So if both the conditions are true, only then it will result in an output. If I run it, you can see there are two employees who are male and their age is greater than 30. Now let's talk about the group by statement in SQL. So the group by statement groups rows that have the same values into summary rows. Like for example, you want to find the average salary of customers in each department. Now the group by statement is often used with aggregate functions such as count, sum and average to group the result set into one or more columns. Let's say we want to find the total salary of employees based on their gender. So in this case you can use the group by clause. So I'll write select, let's say sex, comma, I want to find the total sum of salary as, I'll give an alias name, let's say total salary, from my table name, that is employee details. Next I'm going to group it by sex. Okay, let me run it. There you go. So we have two genders, male and female, and here you can see the total salary. So what this SQL statement did was, first it grouped all the employees based on the gender, and then it found the total salary. Now SQL provides the order by keyword to sort the result set in ascending or descending order. Now the order by keyword sorts the records in ascending order by default. To sort the records in descending order, you can use the DESC keyword. So let's say I want to sort my employee details table in terms of salary. So I'll write select star from emp underscore details, and I'll use my order by clause on the salary column. So this will sort all the records in ascending order of the salary, which is by default. You can see the salary column is sorted in ascending order. Now suppose you want to sort the salary column and display it in descending order, you can use this keyword, that is DESC. Let me run it. You can see the output. Now this time the salary is sorted in descending order, and you have the other values as well. Now let me show you some basic operations that you can do using the select statement. So suppose I write select and do an addition operation, let's say 10 plus 20, and I'll give an alias name as addition. If I run this, it will give me the sum of 10 and 20, that is 30. Similarly, you can use the subtraction operator, and you can change the alias name as, let's say, subtract. Let's run it. You get minus 10. Now there are some basic inbuilt functions. There are a lot of inbuilt functions in SQL, but here I'll show you a few. Suppose you want to find the length of a text or a string, you can use the length function. So I'll write select and then use the length function. I'll hit tab to autocomplete. Let's say I want to find the length of country India, and I'll give an alias as total length. If I run it, you see here it returns 5 because there are 5 letters in India. There's another function called repeat. So let me show you how repeat works. So I'll write select repeat. Let's say I want to repeat the symbol that is at the rate. I'll put it in single quotes because it is a text character, and I want to repeat this character for 10 times. Close the bracket and let's run it. You can see here in the output it has printed at the rate 10 times. You can count it. Alright. Now let's say you want to convert a text or a string to uppercase or lowercase. You can do that as well. So I'll write select and use the function called upper. Let's say I want to convert my string, that is India, to uppercase. I'm not giving in any alias name. If I run this, see, my input was capital I and everything else was in small letter. In the output you can see it is converted my input to all caps. Similarly, you can change this. Let's say you want to print something in lowercase, you can use the lower function. Let's say this time everything is in uppercase. If I run it, it converts India to lowercase. Now let's explore a few date and time functions. Let's say you want to find the current date. There's a function called CUR, which stands for current, and this is the function I'm talking about, which is current date. If I run this, you will get the current date, that is 28th of Jan 2021. And let's say you want to extract the day from a date value, so you can use the day function. Let's say I'll use day and I want to find the day from my current date. If I run this, you get 28, which is today's day. Now similarly, you can also display the current date and time. So for that you can use a function that is called now. So this will return the current date and time. You can see this is the date value and then we have the current time. Alright, and this brings us to the end of our demo session. So let me just scroll through whatever we have learned. So first, I showed you how you can see that databases present in MySQL. Then we used one of the databases and checked the tables in it. Then we created another database called SQL Intro for our demo purpose. We used that database and then we created this table called employee details with column names like name, integer, the sex, date of join, city and salary. I showed you the structure of the database. Let me run this again so you get an idea. You can see this was the structure of our table. Then we went ahead and inserted a few records. So we inserted records for 6 employees. So you have the employee name, the age, the gender, the date of join, the city to which the employee belongs to, and the salary of the employee. Then we saw how you can use the select statement and display all the columns present in the table. We learned how you can display the unique city names. We learned how to use different aggregate functions like count, average and sum. Then we learned how you could display specific columns from the table. We learned how to use where clause. Then we used an or operator. We learned about in operator, the between operator. Then we used an and operator to select multiple conditions. Finally, we learned about group by, order by and some basic SQL operations. We are going to learn two important SQL statements or clauses that are widely used, that is group by and having. First, we'll understand the basics of group by and having and then jump into MySQL Workbench to implement these statements. So let's begin. First, what is group by in SQL? So the group by statement or clause groups records into summary rows and returns one record for each group. It groups the rows with the same group by item expressions and computes aggregate functions for the resulting group. A group by clause is a part of select expression. In each group, no two rows have the same value for the grouping column or columns. Now below, you can see the syntax of group by. So first we have the select statement and then followed by the column names that we want to select. From, we have the table name followed by the where condition, and next we have the group by clause, and here we include the column names. Finally, we have the order by and the column names. Now here is an example of the group by clause. So we want to find the average salary of employees for each department. So here you can see we have the employees table. It has the employee ID, the employee name, the age of the employee, we have the gender, the date on which the employee had joined the company. Then we have the department to which each of these employees belong to. We have the city to which the employees belong to, and then we have the salary in dollars. So actually we'll be using this employees table on MySQL Workbench as well. So if you were to find the average salary of employees in each department, so this is how your SQL query with group by clause would look like. So we have selected department and then we are using an aggregate function that is AVG, which is average, and we have chosen the salary column, and here we have given an alias name which is average underscore salary, which appears in the output. You can see here from employees, and we have grouped it by department. So here in the output you can see we have the department names and the average salary of the employees in each department. Now let me take you to my MySQL Workbench where we will implement group by and solve specific problems.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Okay, so I am on my MySQL Workbench. So let me make my connection first. I'll enter the password. So this will open my SQL editor. So first of all, let me check the databases that I have. So I'll use my query that is show databases. Let's run it. Okay, you can see we have a list of databases here. I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. So this will take us inside this database. I'll run it. Alright. Now you can check the tables that are present in SQL underscore intro database. if I write show tables, you can see the list of tables that are already present in this database. To do our demo and understand group by as well as having, let me first create an employee table. So I'll write create table employees. Next, I'll give my column name as employee underscore ID, which is the ID for each employee. I'll give my data type as integer and I'll assign employee ID as my primary key. Next, I'll give employee underscore name and my data type would be varchar. I'll give the size as 25. My third column would be the age column. Age would obviously be an integer. Then I have my gender column. I'll use character data type and assign a value of 1 or size of 1. Next, we have the date of join and the data type will be date. We have the department column as well. This is going to be of varchar and 20 will be the size. Next, we have the city column, which is actually the city to which the employee belongs to. And finally, we have the salary column, which will have the salary for all the employees. Okay, now let me select and run this. You can see here we have successfully created our table. Now to check if our table was created or not, you can use the describe command. I'll write describe employees. You can see the structure of the table so far. Alright, now it's time for us to insert a few records into this employees table. So I'll write insert into employees and I'll copy paste the records which I have already written on a notepad. So let me show you. So this is my EMP notepad and you can see I have already put the information for all the employees. So let me just copy this and we'll paste it here. Alright, let me go to the top and verify if all the records are fine. Alright, so let's run our insert query. Okay, so you can see here we have inserted 20 rows of information. And now let's check the table information or the records that are present in our employees table. I'll write select star from employees. If I run it, you can see here I have my employee ID, the employee name, age, gender, we have the city, salary, and in total we have inserted 20 records. Now let me run a few SQL commands to check how the structure of our table is. Let's say I want to see the distinct cities that are present in our table. So I'll write select distinct city from employees. If I run this, you see here there are total 8 different cities present in our employees table. So we have Chicago, there's Seattle, Boston, we have New York, Miami and Detroit as well. Now let's say you want to know the total number of departments that are present. So you can use distinct department. If I run this, alright, you can see we have 7 rows returned and here are the department names. So we have sales, marketing, product, tech, IT, finance and HR. Alright, now let me show you another SQL command. Now this is to use an aggregate function. So I want to find the average age of all the employees from the table. So I can write select AVG, which is the aggregate function for average. Inside that I have passed my age column from employees. If I run this, So the average age of all the employees in our table is 33.35. Now, say you want to find the average age of employees in each department. So for this, you need to use the group by clause. I'll give a comment here. I want to find the average age in each department. So I'll write select department, comma, I'll write average of age from employees group by department. Now if I run this, you can see here we have our 7 departments on the left, and on the right you can see the average age of employees in each of these departments. Now you can see here in the output it says AVG of age, which is not readable, so I can give an alias name as average age. Alright, I can bring this down, and if you want you can round the values also. So you can round the decimal places, so I'll use a round function before the average function, and the round function takes 2 parameters. One is the variable and the decimal place you want to round it to. So if I run this, there you go. You can see here we have the average age of all the employees in each of these departments. Alright. Now suppose you want to find the total salary of all the employees for each department. So you can write select department, comma. Now I want the total salary, so I'll use the sum function, and I'll pass my column as salary from employees group by department. Let's run this query. You can see here in the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again, and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I am going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly, we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next we need to insert a few values to our sales table. So I have already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information. I'll just paste it on the query editor. Okay, now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 1, 2, 3, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay. Now suppose you want to find the revenue for both the product IDs 1 to 1 and let's say 1 to 3, since we have just 2 product IDs here. So for that you can use the select query. So I'll write select product ID. Next I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally I'll group it by product ID. Let's run it. There you go. So here you can see we have the 2 product IDs 1 to 1 and 1 to 3, and here you can see the revenue that was generated from these 2 products. Alright, now let's say we have to find the total profit that was made from both the products 1 to 1 and 1 to 3. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 1 to 1. Let's say the cost price was $270 for each, and next we have my product as 1, 2, 3, and let's say the cost price for product 1, 2, 3 was $250. Let's insert these two values. Okay. Next, we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot sell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with S dot quantity, close the bracket. I'll give an alias name as profit from sales as S. So here S stands for the sales table. I'm going to use inner join C underscore product table, as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID. Next, I am calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I am using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by C dot product ID. Let's run this. There you go. So here you can see for product ID 1 to 1, we made a profit of $1,100, and for product ID 1 to 3, we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees, we have grouped it by city and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function, that is average salary. I'll give an alias name as avg underscore salary from employees. Next, we'll use the group by clause, and I want to group it by each department, and then I'm going to write my having clause. So in having clause, I'll use my condition, that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total 3 departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So this will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function, and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma, this time since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next, I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT, where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees, where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees group by department, and in the having clause I'm going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000. This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay. So let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table, and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL. We will learn about joins in SQL. Joins are really important when you have to deal with data that is present on multiple tables. I'll help you understand the basics of joins and make you learn the different types of joins with hands-on demonstrations on my SQL workbench. So let's get started with what are joins in SQL. SQL join statement or command is often used to fetch data present in multiple tables. SQL joins are used to combine rows of data from two or more tables based on a common field or column between them. Now consider this example where we have two tables, an orders table and a customers table. Now the order table has information about the order ID, which is unique here. We have the order date, that is when the order was placed. Then we have the shipped date. This has information about the date on which the order was shipped. Then we have the product name, which basically is the names of different products. We have the status of delivery, whether the product was delivered or not, or whether it was cancelled. Then we have the quantity, which means the number of products that were ordered. And finally we have the price of each product. Similarly, we have another table called customers, and this customer table has information about the order ID, which is the foreign key here. Then we have the customer ID, which is the primary key for this table. We also have the phone number, customer name and address of the customers. Now suppose you want to find the phone numbers of customers who have ordered a laptop. Now to solve this problem, we need to join both the tables. The reason being, the phone numbers are present in the customers table, as you can see here, and laptop, which is the product name, is present in the orders table, which you can see it here. So using a join statement, you can find the phone numbers of customers who have ordered a laptop. Now let's see another problem where you need to find the customer names who have ordered a product in the last 30 days. In this case, we want the customer name present in the customers table and the last 30 days order information, which you can get from the order date column that is present in the orders table. Okay, now let's discuss the different types of joins one by one. So first we have an inner join. So the SQL inner join statement returns all the rows from multiple tables as long as the conditions are met. From the diagram above, you can see that there are two tables, A and B. A is the left table and B is the right table. The orange portion represents the output of an inner join, which means an inner join returns the common records from both the tables. Now you can see the syntax here. So we have the select command, and then we give the list of columns from table A, which you can see here is the left table, followed by the inner join keyword, and then the name of the table, that is B, on a common key column from both the tables A and B. Now let me take you to the MySQL workbench and show you how inner join works in reality. So here I'll type MySQL. You can see I have got MySQL workbench 8.0 version installed. I'll click on it. So it will take some time to open. Okay, I'll click on this local instance, and here I'll give my password. Okay.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So this is how an SQL editor on MySQL Workbench looks like. So first of all, let me go ahead and create a new database. So I'll write create database. This is going to be my command, followed by the name of the database, that is going to be SQL_joins. If I give a semicolon and hit Control Enter, this will create a new database. You can see here one row affected. Now you can check whether the database was created or not using show databases command. If I run it, here you can see I have SQL joins database created. Now I'll use this database, so I'll write use SQL_joins. Okay. Now to understand inner join, consider that there is a college, and in every college you have different teams for different sports such as cricket, football, basketball and others. So let's create two tables, cricket and football. So I'll write create table, and my table name is going to be cricket. Next, I'm going to create two columns in this table. The first column is going to be cricket ID. Then I'm going to give the data type as int and use the auto increment operator. I'm using auto increment because my cricket ID is going to be my primary key. Then I'm going to give the name of the students who are part of the cricket team, and for this I'll use varchar data type and give the length as 30. I'll give another comma and I'll assign my cricket ID as primary key. Within brackets I'll give cricket_ID. Cricket ID is nothing but a unique identifier for each of the players, like you have roll numbers in college. Okay, let me just run it. Alright, so we have successfully created our cricket table. Similarly, let me just copy this and I'll paste it here. I'll create another table called football. This will have the information of all the students who are part of the football team, and instead of cricket I am going to give this as football ID. Alright, and the name column will have the names of the students. I'll change my primary key to football ID. Alright, let me run this. Okay, so now we have also created our football table. The next step is to insert a few player names into both the tables. So I'll write my insert into command. First, let's load some data to our cricket table. So I'll write cricket and I'll give my name column followed by values, and here I'll give some names such as, let's say, Stuart. I'll give another comma, The next player I'll choose is, let's say, Michael. Similarly, I'll add a few more. Let's say we have Johnson. The fourth player I'll take is, let's say, Hayden. And finally we have, let's say, Fleming. Okay. Now I'll give a semicolon and run this. Okay. So let me just check if all the values were inserted properly. For this, I'll use select star from table, that is cricket. If I run it, you can see I have created a table and have successfully inserted 5 rows of information. Now similarly, let's insert a few student names for our football table. So I'll change this to football, and obviously there would be students who will be part of both cricket and football team. So I'll keep a few repeated names. Let's say Stuart, Johnson, and let's say Hayden are part of both cricket and football team. Then we have, let's say, Langer, and let's say we have another player in the football team, that is Astle. I'll just run it. Okay, you can see there are no errors. So we have successfully inserted values to our football team as well. Let me just recheck it. I'll write select star from football. Alright, so we have 5 players in the football team as well. Okay, now the question is, suppose you want to find the students that are part of both the cricket and football team. In this case, you can use an inner join. So let me show you how to do it. So I'll write select star from cricket, as I'm using an alias name as C, which stands for cricket. Then I'm going to write inner join. My next table is going to be football as F, which is an alias name for the football table. Then I'm going to use the on command or operator, and then I'll give the common key, that is name here. So c.name is equal to f.name. So based on this name column from both the table, my inner join operation will be performed. So let's just run it. There you go. So Stuart, Johnson and Hayden are the only 3 students who are part of both the teams. Alright. Now you can also individually select each of the columns from both the tables. So let's say I write select c dot cricket underscore id, comma c dot name, comma f dot football underscore id, comma f dot name. From, I'll write cricket as C, inner join football as F on C dot name is equal to F dot name. Now if I run this, you see we get the same output here as well. Alright. Now let's explore another example to learn more about inner joins. So we have a database called classic models. Let me first use classic models. I'll run this. Okay. Now let me just show the different tables that are part of classic tables. Alright. So here you can see there are tables like customers, there's employees, office, there's office details, orders, payments, products and product lines as well. Alright, so let me use my select statement to show what are the columns present in the products table. Okay, so this product table has information about different product names. You have the product code. Now this product code is unique here. We also have the product vendor, a little description about the product. Then we have the quantity in stock, buying price, and MSRP. Let's see what we have in product lines. If I run it, you see here we have the product line, which is the primary key for this table. Then we have the textual description for each of the products. This is basically some sort of an advertisement. Alright, now suppose you want to find the product code, the product name, and the text description for each of the products. You can join the products and product lines table. So let me show you how to do it. I'll write my select statement and choose my columns as product code. Then we have product name, and let's say I want the text description, so I'll write this column name. Okay, then I'll use from my first table, that is products, inner join product lines, I can use using the common key column, that is product line. Close the bracket, I'll give a semicolon, and if I run it, there you go. So you can see the different product codes. Then we have the different product names and the textual description for each of the products. So this we did by joining the products table and the product lines table. Alright. Now suppose you want to find the revenue generated from each product order and the status of the product. To do this task, we need to join three tables, that is orders, order details, and products. So first let me show you what are the columns we have in these three tables. We have obviously seen for the products table. Now let me show you for orders and order details table. So I'll write select star from orders. If I run it, you can see it has information about the order number, the date on which the order was placed. We also have the shipment date. We also have the status column, which has information regarding whether the order was shipped or cancelled. Then we have some comments column. We also have the customer number who ordered this particular product. Similarly, let's check what we have under order details. So I'll write select star from order details. If I run it, you can see it has the order number, the product code, quantity of each product, we have the price of each product, then we have the order line number. Okay, so using the product, orders, and order details, let's perform an inner join. So I'll write select o dot order number, comma o dot status, comma I need the product name, which I'll take from the products table. So I'll write p dot product name. Now here O, P are all alias name for the tables, orders, products, and I'll use OD for order details, comma since we want to find the revenue, we actually need to find the product of quantity ordered into price of each product. So I'll use a sum function, and inside the sum function I'll give quantity ordered multiplied by the price of each item. I'll use an alias as revenue. Then I'll use my from clause, from orders as O, inner join order details as I'll use an alias name as OD, on I'll write O dot order number is equal to OD dot order number. I'll use another inner join, and this time we'll join the products table. So I'll write inner join products as p on p dot product code is equal to od dot product code. And finally I'll use the group by clause and group it by order number. Alright, let me run this. Okay, there's some mistake here. We need to debug this. It says you have an error in your SQL syntax. Check the manual. Alright. Okay, I think the name of the tables is actually orders and not order. Alright, now let's run it. Okay, there's still some error. It says classic models dot product doesn't exist. So again, the product name is, the table name is products and not product. So let's run it again. Alright, there you go. So we have the order number, the status, the product name and the revenue. This we got it using inner join from 3 different tables.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now talking about left joins, the SQL left join statement returns all the rows from the left table and the matching rows from the right table. So if you see this diagram, you can see we have all the rows from the left table, that is A, and only the matching rows from the right table, that is B. So you can see this overlapped region, and the syntax for SQL left join is something like this. So you have the select statement and then you give the list of columns from table A, which is your left table. Then you use the left join keyword followed by the next table, that is table B, on the common key column. So you write A dot key is equal to B dot key. Okay, now in our classic models database we have 2 tables, customers and orders. So if you want to find the customer name and their order ID, you can use these 2 tables. So first let me show you the columns that are present in customers and orders. I think orders we have already seen. Let me first show you what's there in the customers table. Okay, so you can see we have the customer number, the name of the customer, then we have the contact last name, the contact first name, we have the phone number, then there's an address column. There are 2 address columns actually. We have the city name, the state, and we have other information as well. And similarly we have our orders table. So I'll write select start from orders. So I'll write select star from orders. If I run this, you can see these are the information available in the orders table. Okay, so let's perform a left join where we want to find the customer name and their order IDs. So I'll write select c dot customer name, or let's say first we'll choose the customer number, comma, then I want the customer name, so I'll write c dot customer name. Then we have the order number column which is present in the orders table, and let's say I also want to see the status. Then I'll give my left table, that is customers as C, left join, orders as O, on C dot customer number equal to O dot customer number. Let's run it. Okay, again there is some problem. Alright, so the table name is customers. Let's run it. So there's another mistake here. This is customer number, so B is missing. Cool. Let me run it. Alright, so here you can see we have the information regarding the customer number, then the respective customer names, we have the order number and the status of the shipment. So if I scroll down, you'll notice one thing, there are a few rows. You can see which have null values. This means for customer number 125 and for this particular customer name, there were no orders. And similarly, if I scroll down, you will find a few more null values. You can see here there are 2 null values here for customer number 168 and 169. There were no orders available. Alright, now to check those customers who haven't placed any orders, you can use the null operator. So what I'll do is here, I'll just continue with this. I'll use a where clause and write where order number is null. Now let me run this. Okay, so here you can see there are 24 customers from the table that don't have any orders in their names. Okay, now talking about right joins. So SQL right join statement returns all the rows from the right table and only matching rows from the left table. So here you can see we have our left table as A and the right table as B. So the right join will return all the rows from the right table and only the matching rows from the left table. Now talking about the syntax. So here you can see we have the select statement. Followed by the select statement, you will have the list of columns that you want to choose. From table A, right join table B on the common key column from both the tables. Alright. Now to show how right join works, I'll be using 2 tables, that is customers and employees. So let's see the rows of data that are present in the customer table first. So I'll write select star from customers. Let's run it. So here you have the customer number, the customer name. Then we have the phone number, the address of the customers. You also have the country to which the customer belongs to, the postal code, and the credit limit as well. Similarly, let's see for the employees table. Here I'll change customers to employees. Let's run it. Okay, so we have the employee number, the last name, the first name. We have the extension, the email ID, the job title, and also reports to here means the manager. Okay, so based on these 2 tables, we'll find the customer name, the phone number of the customer, and the email address of the employee, and join both the tables, that is customers and employees. So let me show you the command. So I'll write select c dot customer name, comma, then we have c dot phone. I'll give a space here. Next, I want the employee number from the employee table, so I'll write e dot employee number, comma, e dot email from customers as C, right join employees as E on E dot, my common key column is employee number here, so I'll write E dot employee number is equal to C dot, we have sales representatives employee number, and I'm also going to order it by the employee number column. Okay, so you can see I have my customer name selected from the customers table, the phone number of the customer, then we have the employee number and the email address. So let me run it. Okay, there's some problem. Alright, so the table name is customers actually. Let's run it once again. There you go. So you can see here we have all the values selected from our right table, which is the employees table. You can see right join employees, which means your employees table is to the right, and then we have the customer name and phone numbers of the customers from the customer table, which is actually your left table. So you have a few employee numbers such as 1002, there's 1056, which don't have any customer name or phone numbers. Okay, so there's another popular join which is very widely used in SQL known as self joins. So self joins are used to join a table to itself. So in our database we have a table called employees. Let me show you the table first. Alright. So here you can see we have the employee number, the last name, the first name of the employee. We have the email ID. And here if you see, we have a column called reports to. Now this you can think of as the manager column. So the way to read is, for example, for employee number 1056, the manager is 1002. So if you check for 1002, we have Dane Murphy. Then if I scroll down, let's say for employee number 1102, for employee number 1102, the manager is 1056. So here you can see who is at 1056. You have Mary Patterson. Similarly, if I scroll down, let's say for employee number 1188, we have the manager as 1143. Now if I check the table at 1143, we have Anthony Bow. So the employee Julie Firelli reports to Anthony Bow. Alright. Now suppose you want to know who is the reporting manager for each employee. So for that you can use a self join. So let me show you how to join this employees table. I'll write select, and then I'm going to use a function called concat. Within brackets I'll start with my alias name, that is m dot, then I'll write last name. I'm going to concat last name followed by a comma, then I'll have my first name. I'll close this bracket, and then I'm going to give my alias name, let's say manager, comma. Next I'm going to concat the same last name and first name, and this time I'm going to use a separate alias, let's say E, which stands for employee. So I'll write E dot last name, comma, and within single quotes I'll give my comma, and then I'll write E dot first name. I'll close this bracket. I'll give an alias as, let's say, employee. From, I'll write employees as E, inner join employees as M on M dot. I'll use my common key column as employee number, so I'll write M dot employee number is equal to E dot, here I'm going to use the reports to column, and then I'll order it by, let's say, manager. Okay, now let's run this. There you go. So you have your two columns as manager and employee. So for employee Louis Bonder, the manager is Gerard Bonder. Similarly, if I scroll down, you have there are multiple employees reporting to this particular manager. Similarly, we have our manager as Anthony Bow, and we have different employees who are reporting to this particular manager, and so on. Alright, now moving ahead. Now let's see what a full join is. So SQL full outer join statement returns all the rows when there is a match in either left or right table. Now you must remember that MySQL Workbench does not support full outer join by default, but there's a way to do it. So by default, this is how the syntax of full outer join looks like. Now this statement will work on other SQL databases like Microsoft SQL Server, but it won't work on MySQL Workbench. I'll show you the right way of using full outer join on MySQL Workbench. So to show full outer join, I'm going to first use a left join, and then we'll also use a right join, and finally we'll use a union operator. So the union operator is used to combine the result set of two or more select statements. So first of all, let me write C dot customer name. So for this example, I'm using the customer table and the order table, comma O dot order number. So I just want to know the customer name and the order number related to the customer. From, I have customers as C, left join, I'll write orders as O on C dot customer number is equal to O dot customer number. Let me just copy this, and after this I am going to use my union operator. So union operator is used to merge results from two or more tables. So basically this performs a vertical join. And next I am going to use my right join operation. So here instead of left join I'll write right. Rest all looks fine. Let me just run it. There you go. So we have successfully run our full outer join operation. You can see we have the different customer names and the order that each customer had placed. Alright. We will learn advanced SQL queries. In our previous videos, we have learned the basics of SQL, that includes where, group by, having, as well as joins in SQL. So in this video, we will learn subqueries in SQL. We'll also have a look at stored procedures and learn about triggers in SQL. We'll cover views in SQL and look at some of the important Windows functions in SQL. Now to learn all of these, we'll be using the MySQL workbench on Windows. So let's get started with subqueries in SQL. So let me head over to my MySQL workbench. So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright. So this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause, or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee. From my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select, I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than, I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with 2 different tables. So suppose you want to display some information that are present in 2 different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using 2 tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay, now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay, so first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players, and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay, In the delimiter, I'll write ampersand ampersand. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top underscore players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was double ampersand. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top underscore players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top underscore player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top underscore players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL underscore IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records. So I'm using this limit keyword and my variable var, which I created here. I'll end my select statement. I'll end my stored procedure with / and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is sp_sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is sp_sort by salary, the other two were top_player and top_players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is sp_sort by salary, and inside this I'll give my parameter, which was actually var, and this var we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay, now instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be / then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in two parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says one row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay. So suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore EMPs, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter to / I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore EMPs. From my table, that is EMP underscore details, where sex is equal to F, which means female, I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp underscore count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table emp underscore details. So I've used my out parameter and I'm creating a new variable called total underscore EMPs. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I'm storing it in total underscore EMPs. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp underscore count employees. Now to call it, I'll write call the name of the procedure, that is count underscore sp underscore count employees. Within brackets, I'll pass in the parameter as @f underscore emp. I'll give a semicolon. Then I'll write select @f underscore emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure, and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now, there are mainly three types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we will learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I am giving it as 30, finally we have the marks as floating type. So let's create this table which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting, if any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. age is 13, the name is Dave, and let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. I'll give this as a comment. Okay, now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is I'll write create view followed by the view name which is cust underscore details. Then you write as select. I'm going to select a few column names from my original customer table which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright, I'll write from my table that is customers. If I run this, my view that is cust details will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view I can write select star from followed by the view name that is cust underscore details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that I'm going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside classic models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there is some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name, that is product underscore description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table, I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay, so here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay, now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cust details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be Okay, so instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that, you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright. Now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay. I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over. I want to partition it by department. So I'll write partition by department, which is DEPT, and I'll give an alias as total salary, so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright. Now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num, give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name. which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values. I'll give 101. The name is Shane. Give a comma. I'll insert the second student name 102. The name is Bradley. I'll give a comma. This time for 103 we have two records. Let's say the name of the student is Hirath. I'll give a comma. I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the fifth student, which is Kevin, we have two records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over within brackets. I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here. Okay, let me just delete n from here and do it again. Alright, now if you see here, there is just one student in the name Shane. We have one student in the name Bradley. But here if you see, for Hirath, the second record it says 2, which means there are two records for Hirath. And if I scroll down, there is one record for Nathan and there are two records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when two or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable that is var underscore a as an alias name, let's say test rank, from my table that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function has assigned the same value which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column that is salary descending. I'll give an alias as highest underscore salary from my table that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function that is first underscore value followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Today we are going to discuss how to work on SQL queries using Python. Python, as you must be aware, is a high-level general-purpose programming language that can be used for data science and analytics. In this tutorial, we will learn how to work with databases and tables using SQL with Python. To do this demo, we will be using our Jupyter Notebook and the MySQL Workbench. You can see it here. So we will write our SQL queries in the Jupyter Notebook with Python-like syntax. If you don't have MySQL or Jupyter Notebook installed, so please go ahead and install them first. While installing the MySQL Workbench, you will be asked to give the username and password. Let me show you. So I am on my MySQL Workbench. So once you connect, it will ask for the username and the password. So I have given my username as root, and password you can give while installing it. We will be using the same user ID or the username and the password to make our connection. So let's get started with our hands-on demonstration part. First and foremost, let me go ahead and import the necessary libraries. I'll give a comment as import libraries. Alright, so first I'll import mysql.connector. Next, from mysql.connector, I'm going to import my error method or the error module. Next, I want to import pandas as PD. So let's run this. Okay, there is some error here. This should be capital E and not small e. Alright, you can see I have imported my important libraries. Now I'm going to create a function that will help us create a server connection. So I'll write my user-defined function by using the def keyword. I'll write create underscore server underscore connection. This is going to be my function name, and it will take in 3 parameters. First is the host name, next is the username, and then we have the user password. Alright, I'll give a colon, and then in the next line I'm going to define a variable which is going to be connection, and I'll assign it to a value called none. Now we'll be using exception handling techniques to connect to our MySQL server. The try block lets you test a block of code for errors, and the except block will handle the errors. So I'll write try and give a colon, and then I'm going to reassign the connection variable to a method which is mysql.connector.connect. Now this mysql connector.connect method sets up a connection, so it establishes a session with the MySQL server. If no arguments are passed, it uses the already configured or default values. So here we are going to pass in 3 parameters. The first is the host name. I'll write host equal to host name, which is host underscore name. I'll give a comma, then I'll write user equal to user underscore name. Next will be my password, and I'll assign the value user underscore password. Alright, now I'm going to use a print statement and write MySQL database connection successful. After this, I'll give my except block. So I'll use the keyword except. Here I'll write error as ERR, give a colon, and then I'm going to use the print statement. Here I'm going to use some print formatting techniques using the F letter. I'll write error colon and I'll use curly braces, give error, and then I'll close the double quotes. After this, I'm going to return my connection. Alright. Let me give a comment here. We are going to assign our password. So we need to put our MySQL terminal password. So this password you assign it while installing MySQL Workbench. I'll write pw and I'll give my password, which is simply @12345, and then I'm going to give my database name. So I'll give database name. Here I'm going to write db equal to, this is the database I want to create, which is going to be MySQL_Python. Let me just scroll this down. Okay, now I'll say connection equal to, I'll pass in my user defined function name, which is create server connection, and the parameters, which are going to be localhost, that is my host name, my username, which is root, and then I'll give pw, which is my password, that is exactly simply @12345. Let's just run it now. Okay, there is an error here. We need to remove this double quotation. Alright, made another mistake here. This should be root. Okay, you can see here MySQL database connection successful. Alright, next we are now going to create a database, that is MySQL_Python. So I'll give a comment, create MySQL_Python database. Again, to create this database, I'm going to create another user defined function using the def keyword. I'll write the function name as create database, pass in the parameters as connection, query, give a semicolon, and in the next line I'll write cursor equal to, I'm going to make the connection, so I'll write connection dot cursor, and I'll give the parenthesis. So this MySQL's cursor of MySQL connector Python is used to execute statements to communicate with the MySQL database. The MySQL cursor class initiates objects that can execute operations such as the MySQL statements. Okay, next I'm going to again use my try and except block. So I'll write try, give a colon, and here I'm going to use cursor dot execute. Within that I'm going to pass in my query. Next I'll use a print statement, and the message I'm going to display is database created successfully. After this I'm going to write my except block. I'll write except error as err, give a colon, and then I'll use a print statement. I'll write print, I'll use the formatting again, error colon, and I'll write within single quotes, I'll give curly braces error, and then I'll close the double quotes. Next, let's use the variable create underscore database underscore query, and here I'm going to write my SQL query to create the database. So I'll write create database, and followed by that I'll give my database name, which is going to be mysql underscore python. Okay. After this, I'll call my function, which is create database, and I'll pass in the parameters. The first one is connection, and next the query is create underscore database underscore query. Let me just copy it, and I'm going to paste it here. Alright, so what I'm doing here is I am creating a new function, that is to create a new database with the name mysql underscore python, which you can see it here. Now this function takes in two parameters, connection and query. I'm using the connection.cursor function, which is often used to execute SQL statements using Python language. And then I have created my try and exit blocks. So this try block statements will try to create my new database, which is mysql underscore python. In case it fails to create the new database, the exit block will work. So here I am writing my SQL query to create a new database, which is create database followed by the database name, and I am assigning it to a variable which is create database query, and then I'm calling my function create database and passing in the two parameters, connection and the query. Alright, so let's just run it. Alright, you can see here it has created my database successfully. Now you can verify this by checking the MySQL workbench or the MySQL shell. You can see on the MySQL workbench here on the left panel under schemas, there is a database called mysql underscore python. Let me just expand it. Now we haven't created any table, so it's not showing it now. The next step, we are going to connect to this database. So let's go ahead and connect to our database that we have just created. I'll write the comment as connect to database. Now to connect to our database, I'm again going to create a user defined function using the def keyword. I'll write create underscore db, which is for database underscore connection, and the parameters it will take is the host name followed by the username, then we have the user password, and finally we have the database name. I'll give a colon. In the next line, I'm going to create my variable, which is connection, and then I'll assign it to a value none. After this, I'm going to use my exception handling techniques. So I'll write my try block first. I'm going to reassign my connection variable using the MySQL connector method. So I'll write mysql dot connector dot connect. So this method will take in the parameters. So first it will take the host name. I'll write host equal to host underscore name. I'll give a comma. Next it will take the username, so user equal to user underscore name, give another comma. Next it will take the user password. I'll use passwd equal to user underscore password. I'll give another comma, and this time it is going to be the database name. So I'll write database equal to db underscore name. Now let's use the print statement, and the message we are going to print is MySQL database connection successful. Alright, finally we'll write my except block. I'll write except error as err, give a colon, and then I'll use the print statement. F within double quotes I'll write error colon, within single quotes curly braces I'll write err, and we'll close the double quotes. Finally, this function will return the connection value. Alright, let's run it, and there you go. It has run successfully, so we have connected to our database. Now it's time for us to execute SQL queries. I'll give another comment saying execute SQL queries. Alright, now to execute our SQL queries, I'll use another user-defined function, which is execute underscore query, and I'll pass in the parameters as connection and query. I'll give a colon. I'm going to write cursor equal to connection dot cursor. Now this is used to establish a connection and run SQL statements. Next we'll use the try and except block, so I'll write try cursor dot execute. This will take in one parameter, which is going to be my query, and then I'll write connection dot commit, which is another method. Now let's use the print statement. So I'll write print. Let's say the message would be query was successful. And then we'll write our except block, which is except. If the try block doesn't work, throw an error using the print statement. Within double quotes, inside the curly braces, I'll write err and close the double quotes. Alright, so let's run it. Okay, so we have successfully created our various functions that were needed to create a database, establish a connection, and to execute our queries. Alright, now it's time for us to create our first table inside the MySQL_Python database. So to do that, I'm going to write my create command in SQL. So first we are going to assign our SQL command to a Python variable using triple quotes to create a multi-line string. So let me show you how to do that. I'll write my variable name, which is going to be create orders table. It is always recommended to use relevant variable names to make it more readable. And now I'm going to use triple quotes. So the triple quote will ensure I can create my multi-line string. Inside the triple quote, I am going to write my create command, which is create table. Here I am going to create an orders table first, and inside the orders table I am going to create my column names, the first column would be the order ID. It is going to be of type integer, and I'll assign this order ID as my primary key column. We'll give a comma. Next, the second column would be customer underscore name. The customer name column would be of type varying character, so I'll write varchar and I'll give a size of 30, and this is also going to be not null. Moving ahead, my fourth column would be the product name column, so I'll write product underscore name. Product name will be of type varying character. The size is, let's say, 20, and it is also not null. Next, I'm going to create my fourth column, which is the date on which the item was ordered or the product was ordered. So I'll write date ordered. The data type will be date. Next, I'll create a quantity column to keep track of the number of quantities that were ordered. This is of type integer. My next column would be unit price, which will basically have information about the price of each unit of product. Unit price can be of type float. And finally, I'll have the phone number of the customer. I'll write phone number. Phone number can be kept as of type varying character. I've assigned a size of 20. Now let's give a semicolon and we'll close the triple quotes. Alright, so this is how the syntax would look like. Next, to run this, we are first going to call our createDB function. So let me give a comment as connect to the database. I'll write connection equal to create underscore db underscore connection. My parameters would be my host name, which is localhost, my username, which is root, comma, my password, and then my database name, which is mysql underscore python. So I'll write just db. Alright. Finally, let's execute this query using the execute underscore query function that we had created earlier. This takes in two parameters. The first one is connection, followed by the variable name, which is create orders underscore table. Let us run it. Okay, there is some error here. Let's see what's the error. Okay, so here we have put 4 double quotes. This should be triple quotes. Now let's run it. Okay, there is another here. Let's debug it. It says name cursor not defined. Let me just roll it to the above cell. If you see here in our execute underscore query function, instead of cursor, I have written cursor. So R is missing. Let's rerun this. And now let's run this again. There you go. You can see here MySQL database connection successful. Even our query was also successful. Now if you want to recheck if the table, that is orders, was created or not, you can check it on the MySQL workbench. So let me show you how to do it. So I am on my MySQL workbench, and under MySQL underscore Python database you have something called as tables. Let me just right click and I'll select refresh all. There you go. You can see this arrow. Just click on this arrow and here you can see we have a table called orders. So we have created a table called orders. Now you can check the columns as well. You have the order ID, the customer name, product name, ordered date, quantity, unit price, and phone number. Now it's time for us to insert a few records to this table, which is orders. Now to insert records, I'll give a comment as insert data. I'll start with the variable name. let's say the variable name is data underscore orders. I'll give triple quotes. Next, I'll write my insert into command. So I'll write insert into my table name, that is orders, followed by values, and now I'll start entering my records for each of the rows. So first I'll give 101, which is the order ID. Then I'll give the customer's name, let's say Steve, and the product he had ordered is, let's say, laptop. Then I'll give my date in which the item was ordered. Let's say it is 2018. I'll choose 06 as the month and the date is, let's say, 12. I'll give another comma. This time we'll pass in the quantity, which is 2. Let's say the price of each laptop was $800, and we'll give a phone number. This is random, let's say 62937330, let's say 802. Alright, similarly I am going to insert 5 more records of different customers and their items that they have purchased to this table orders. So here on my notepad I have my rest of the 5 records. Let me just copy it and we'll paste it in the cell here. This will save us some time. Okay, let me recheck if everything is fine. I'll give a comma here. Alright, so we have 6 customers in our table which have their customer IDs from 101 to 106. You have Steve, Jaws, Stacy, Nancy, Maria and Danny. You have the different items they have purchased: laptop, books, trousers, t-shirts, headphones and smart TV. This is the date on which they had ordered this item, the number of quantities they had ordered, and then we have the unit price and some random phone numbers. So let's create the connection now. I'll write connection equal to, I'll write create underscore db underscore connection. Then I'll going to give my same parameters. Let me just copy it from the top, which is localhost, the host name, root is my username, then we have password and the database name, and then I'll use the same query as above, which is execute query. I'll copy this, paste it here, and instead of create orders table variable, I'll put as data underscore orders. So this will store my insert into command. You can see the variable I have used here is data underscore orders. Now it's time, let's just run it. Alright, there was some mistake here. Let's debug it. Again, this should be triple quotes and not 4. Now let me rerun it again. There you go. You can see here my SQL database connection successful and my query was also successful. Now we'll create another user-defined function which will help us read query and display the results. So I'll write my function name as def read underscore query. This will take in 2 parameters, connection and query. Then I'll write cursor equal to connection.cursor. I'll put my result as none, and then I'll use my try and accept block. I'll write try cursor dot execute. This will take in 1 parameter, which is query, and then I'll give another variable which is result equal to cursor dot fetch all. Now this fetch all method will return all the results in the table. I'll write return result. Next we'll use the accept block. So I'll write accept error as err, give a colon, and I'll use my print statement. Just scroll this down. I'll use my formatting F error, give a colon followed by a space, within single quotes, inside curly braces I'll give error and close my double quotes. Let's run it. Alright, so now we are all set. Now we are going to use our select clause, having, whereby, then we'll see how to use order by clause, some inbuilt functions, we'll update some records, delete some records, and do a lot of other stuff. So let's start with our first query. So our first query is going to be using the select statement. Alright, so suppose I want to display all the records that we have inserted into our orders table. So the way to do is, I'll assign my query to a variable, let's say Q1. I'll give triple quotes. Within triple quotes, I'll write select star from orders. I'll give a semicolon followed by the triple quotes. Now we'll establish the connection. So let me just go to the top and I'll copy this line, which is to connect to our database. I'll paste it here. Now we'll create a variable called results that will store the result of this query, and we are going to assign this variable to our function, that is read query, and this read query will have two parameters, the connection and the variable name, which is Q1 for the query. Next, to display, I'm going to use a for loop. I'll write for results, for result in results print, I'll say result. Now we are done. Let's just run this query. There you go. You can see here we have successfully printed all the rows in our table, which is orders. You can see we have 6 records in total. Now we are going to explore a few more queries. So let me just copy this and we are going to edit in the same query. I'll paste it here. Next, let's say you want to display individual columns from the table and not all the columns. So let me create the variable Q2. Now instead of star, I'm going to display only the customer name and let's say the phone numbers of the customer. So I'll write phone underscore number. Alright, the rest all remains the same. Let me just recheck it, and here instead of Q1 we'll put Q2, and let's run this cell. Alright, you can see here now we have displayed only 2 columns. The first column is the customer name and then we have their respective phone numbers. Okay, now let me just paste that query again. Now we are going to see how you can use an inbuilt function, that is, in our table we have the order date, and from the order date we are only going to display the different years that are present in the order date. So to do that, I am going to use the year function. I'll edit this query. Instead of Q1 I'll make it Q3, and here I am going to write select year, which is my function name, from my column which is date ordered, from orders, and here I'll change this to Q3. Q1, Q2, Q3 are basically query 1, query 2 and query 3. Let's run it. There you go. So we have successfully extracted the different years present in the order date column. Now if you want to display the distinct or the unique dates present in the column, you can use the distinct keyword in the select statement. So the way to do it is, I'll write select distinct, give a space, the rest of the query remains the same, and here instead of Q3 I'll write Q4. I'll make this as Q4. Let's run it. You can see 2018 and 2019 are the unique year values that are present in the order date column. Okay, now moving ahead, let's write our fifth query, and this time we are going to explore how you can use the where clause. So I'll change this to Q5 before I write my query. So let's say you want to display all the orders that were ordered before 31st of December 2018. So to filter this, we are going to use the where clause. So I'll write select star from orders. Next I'll write where my date underscore ordered is less than, within quotes I'll give my date value, which is 2018 December 31st. So all the items or the products that were ordered before 31st of December 2018 will be displayed. So let's run it. Alright, you can see here there are 3 orders in our table which have been ordered before 31st of December. Now moving ahead, we want to display all the orders that were made after 31st of December. So here what you can do is, I'll just copy the above query again. I'll copy this line. So instead of less than 31st of December 2018, I'll make it as greater than. So every order that was placed after 31st of December will be displayed. If you run it, so you can see here there are 3 orders in our table which were ordered after 31st of December 2018. Now moving ahead, let's write a 7th query. Now let's see how the order by clause works in SQL. So you can filter your results based on a particular column or sort it based on a particular column. So this is going to be my query 7. I'll write it from scratch again. Let's say you want to display all the columns from the table. So I'll write select star from orders. Then I'm going to use order by unit price. I'll give a semicolon. Let's run this query and see the output. Now if you see the result here and you mark the unit price column, the result has been ordered in ascending order of unit price. You see here it starts with the lowest price and then goes on with the highest price towards the end. Now if you want to order it in descending order, you can use the keyword DESC. So this will ensure your top or the most expensive products appear at the top and the least expensive products appear at the bottom. Alright. Next, now let's see how you can create a data frame from the given table. So as you know, using Jupyter Notebook and Pandas, you can create data frames and work on it very easily. So with this table also we can create our own data frame. So for that, let me create an empty list first. I'll write from db equal to, I'll assign this as an empty list. So we are going to return a list of lists and then create a Pandas data frame. Next, I'll write my for loop. I'll write for result in results. I'll assign result to list of results. So I'm converting the result into a list and then I'm going to append it to the empty variable or the empty list, which is from underscore db dot append. I'll append the result to my empty list. Next, we need to pass in the columns now that will be part of our data frame. So I'll write columns equal to this column. I'll pass it within a list. So I'll give my first column as order ID. Then we have the customer name. Next, I have my product name. Then I have the date on which it was ordered. Give a comma. Then we'll have the quantity column. let me write it in the next line. Next we have the unit price column, and finally we have the phone number column. So I'll write within double quotes phone number, and this we are going to assign it to a data frame. So I'll be using pd dot data frame, which is my function to convert a list into a data frame. My variable I'm going to pass is from_db, and I'll write my next argument is columns equal to my variable name, that is columns. Finally, let's display the data frame, which is df. Alright, so here I'm creating a empty list first, and then I'm creating a for loop, and I'm appending the results to my empty list. Here you can see I have created my column list, and using pd.dataframe I'm converting the list into a data frame. If I run this, this is append and not appends. Alright, you can see we have our data frame ready. This is the index column, it starts from 0 onwards, and then we have the different column names. Okay, now let's see how to use the update command. Now suppose you want to change the unit price of one of the orders, you can use the update command. So the way to do it, I'll first create my variable, let's say update, and I'll give 3 quotes or triple quotes. Then I'll use my update command, which is update followed by the table name, that is orders. Next I'll write set, let's say unit underscore price. If you see this, let's say I want to set the unit price of trousers from $50 to, let's say, $45. I want to update this particular record. So I'm going to write set unit price column equal to $45, where the order ID equal to 103. So this query will update the third row in our table, which is order ID 103. So it will update from $50 to $45. I'll close the triple quotes, and now I'll use the connection queries again. Let me just paste it here. Alright, I'll delete these 3 lines of code, and instead of that I'll put execute underscore query, and this will take into parameters as always, which is going to be connection followed by the variable name, that is update. Let's run it. You see here it says MySQL database connection successful, query was successful. Now you can recheck that. To do it, let me just go to the top and we'll just copy our first query, which is Q1. I'll copy this and I'll paste it here. Let me just rename this now. This will be Q8, and I'll change this as well. I'll write select star from orders, where my order ID equal to 103. Let's see the unit price of 103 now. You can see here instead of 50, now we have updated it to $45. Alright, now the last command we are going to say is how you can delete a record from the table. I'll write delete command as my comment. Now to delete a query, I'll first give my variable name, which is delete underscore order, and I'll pass in within triple quotes. Next I'll write my delete query, which is delete from my table name, that is orders. Then I'll give my where clause, where let's say I want to delete my order ID 105. Let me just go to the top and explain you again. So if you say this, we want to delete the order ID 105, which was for customer named Maria and she had ordered headphones. We want to completely remove this particular record. So I have my delete query ready. Now let me just create my connection and display the results. So I'll go to the top and I'll copy this connection command, which also has the execute query command, and I'll paste it here. And I'm going to make a change here. Instead of update, we'll write delete underscore order. Everything looks good. Let's just run it. You can see our query was successful. And now if you want to print it, let me just show you. I'll just copy this. We'll paste it here. I'll make this as Q9. I want to verify if my order ID 105 was deleted or not. Instead of this statement, I'll write select star from orders, and here I'll change this to Q9. If I run this, you can see it here. You can mark order ID 105 was deleted and it no more appears in this table. Alright, so this brings us to the end of the demo session on SQL with Python. Let me just scroll you through what we did. So first we imported the important libraries, MySQL connector, then we imported the error function, then we imported Pandas using PD. We learned how to create a server connection to MySQL database. We created a new database, that is MySQL_Python, and now we connected to that database. We created a function to execute our queries. We saw how you can write a create table command. Then we inserted a few records to our orders table. We created a read underscore query command to read the queries and display the results. Then we started exploring our different SQL commands one by one. We saw how to use select query. Then we selected a few individual columns from our table, followed by using a inbuilt function which was year. Then we saw how to use the distinct keyword. After that, we used our where clause to filter our table based on specific conditions. We saw how to order your results based on a particular column. Then we saw how you could convert the table into a data frame using pd.dataframe function. Finally, we learned how to use the update command and the delete command. Thank you all for watching this session on data analysis using Python and SQL full course 2022 by Simplilearn. We hope it was useful and interesting. If you have any queries, please feel free to put them in the comment section of the video. Thanks again and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.